Welcome to Stationeers. Before I give you an introduction of how to play the game on the Moon, which is one of the easiest worlds next to Mars, I first want to show you a bit about this Europa base, so that you get an idea of what it's like once you have, built up your station to some degree. Because at the beginning you have nothing. You're standing next to your lander on the naked lunar surface, and you have to build everything from scratch. And you need to survive. You need oxygen. And you need the right temperature. Here we have 24 degrees Celsius, and if I close my helmet, that doesn't even matter much. But ultimately you want to be able to survive without your spacesuit. So, what atmospheric composition do we have here? Here we have almost half of it is oxygen, there's some nitrogen, and there's some CO2. This actually matters. Not how exactly you compose it, because you could as well use an atmosphere of 100% O2, so that's not as realistic as it should be. But, you have gases here, and they can even liquefy, or they can even turn to ice. They even have phase change diagrams, so depending on pressure, that's different temperatures. And as it changes from its, for example, liquid form to its gaseous form, it cools down, like in reality. Or vice versa, it heats up. So you can build elaborate cooling and heating cycles with pumps and such, and pipes and valves. We have electricity systems. We have you can also plant stuff, and everything is meaningful. This thing works, this thing works, this thing shows me what's going on in the pipes, and this is not just the one tool that you use to measure your environment. It's a tablet which has multiple different cartridges that you can put in here. It consumes battery, and as you can see, we have a complex inventory. But let's go into that stuff later. First I want to show you the station a bit. Yeah, you can adjust the field of view freely, and even while you're in the game if you wish. And then reset to the default that you set in that you defined in the settings. This is my manufactory room. These are all 3D printers, and there are even some more of these in the game, I think. Centrifuge. A computer that I put here. And what you can see here is actual source code, because there's an assembly language in the game that you can use to automate things. You don't have to, but it's highly advised. But you can also use logic chips instead. Oh look, we actually have in-world liquids. This is water, and other gases would have a different color, and they will actually mix their colors accordingly. Potato seeds. Here I have a potato. Do I have a microwave oven somewhere? Yeah, there it is. Down here you can see how my food is building up when I eat. Oxygen tank, fuel tank. I could also rename these. It's not like the oxygen tank that the game has. No, it's just a tank. Whatever you put in there is whatever you put in there. What is in there, for example, right now? Okay, 8 megapascals of oxygen. What does it mean? Well, we have a certain volume here. You can see that here with a very expressive tooltip. 790 liters capacity. We have in there 2.58 kilomoles of oxygen, and that then results in the respective pressure and temperature too. Yeah? So here's my air tank. I can drag that in here.
Air tank critical.
And now it has been topped up, and maybe you saw that the needle went down a bit here. Yeah. Those are things that you can do in this game. See, everything is physical, everything is real, and everything is functional. These pipes here, all of which have a purpose. I placed them here to achieve a certain outcome. This is my furnace, which is currently not empty. There's still some gases in there. You will heat this thing up and you toss raw material in there in the right mixture. So basically advanced crafting recipes, so to speak. Oh, talking about crafting recipes, here we have an airlock. Oh, did you notice the light turning on and off automatically as I entered and left? Or here, my manufactories. I mean, all of this consumes electricity and I don't want to waste that, so I turn that off automatically when I enter and leave. This airlock is not... an airlock doesn't have to be one box, you can also make it bigger, but there's some certain considerations. And also, it's not a crafting recipe, it is emergent. We have a room that can be sealed by the doors closing. Now it's pumping the gas away
Waste tank critical.
into the station. Oh.
Temperature low.
Yeah, that is a thing that can happen.
Temperature low.
My spacesuit's waste canister, which is filled with CO2, as I breathe in O2 and convert that with my lungs, with my body, has been filled up to the level that it can no longer be filled further. That's what just happened there. So this is not yet the moon introduction. I will do that in a minute or two. First I want to give you an overview. Yeah, we have a jetpack, and that's even what you have from the start, so it's easy to build your structures. The landscape, the terrain system is really vastly different in a few months. We already have some like that playable on the beta version of the game. But, I mean, ultimately it's about the engineering at the station building. Primarily, at the moment. What is this? Well, this is a few world boxes that I made, and inside of it there's one empty box, and I can toss ices here in there, which will then melt inside and build up pressure, and then I can stuff a canister into this slot here, which is connected to some pipes, which are connected to some opening, so yeah, then I can fill my canister like that. And here's my advanced furnace room with another computer, and there's a chip that runs the software. How do I get in? Oh, right. Yeah, you can see it's pretty hot in here. 400 degrees Celsius. Which means that my waste tank will be filled faster because my spacesuit is, well, heat is bleeding into it, and my spacesuit is trying to cool itself by pumping more of the gas here that is relatively cold. It's like 30 degrees Celsius maybe, through the suit. That is how this happens. This is how deep this game simulates everything. Are you intrigued yet? Okay, let's start with the moon then. This is the main menu. Don't bother with the tutorials, they will eventually catch up to the game. It's early access. I mean, the game you have seen is very, very complex. You have never seen such complexity in a 3D first-person experience. It is unique. The game is absolutely unique, it's outstanding, and you have to forgive a lot of things. But you will not have to put up with relevant bugs. I have been playing the beta version of this game instead of the main version for over a year. I've recorded videos with 8 hours duration easily, without crashes or anything, and we get a new beta version almost every day. So that's fresh from the developer's desktop, and it runs stable. You don't have that often with released games. They crash sometimes, but this game doesn't even crash in its beta version that comes daily. It's unbelievable. Rocketworks is an outstanding developer team, and yeah. Anyway, so you have to be a bit forgiving. New world. I will switch through them so we can check on the screen what is being shown, because I don't want to waste too much time on this now. So let's start on the moon. Creative mode doesn't have most of the simulation for food and atmosphere and so forth that you need for a survival, and of course we don't want that. Stationeer difficulty is pretty demanding. I mean, for a seasoned stationeer, it's of course a joke to survive on the moon, no matter how hard it is. But I mean, I want to do some explaining, and also why shouldn't you see what you will actually see when you play the game for the first time. That will be the easy mode, yes? Then we can select our starting gear, minimal or normal. Let's use normal. The moon. Over there, that's where you live. And this is where you're moving now, right? Day-night cycle is 20 minutes. You can slow that down with some tricks, but there's no official way for that yet. I mean, you would have to press F3 for the console, orbit. Then you can see the time scale listed there. You said orbit time scale 0.03 would be 1/10 of this number that you see there. Then you would have a 200-minute day, as an example, you know. But you would have to do that every time you load the save game. Also, the plants have their 20-minute cycle period, and they need not just brightness, they also need darkness. Oh, talking about brightness, let's turn off the flashlight, because it consumes a lot of electricity. How do I even get this mouse pointer? That's what they tell you in the first tutorial. As the first step, you press the left Alt key. Left Alt. You can also use 1, 2, 3 and so forth on the keyboard to open these, but ultimately you'll be using the mouse. Okay, here we go. Well, as you can see, I have some head-up display right at the top, which is not part of Stationeers. I made that a few days ago. Which analyzes my current save game. That's why it's saving all the time. That's something you normally don't have, but that gives you some idea of some of the primary values that you should keep track of. How full is your oxygen tank? How full is your waste tank? Do you still have enough battery? Do you still have enough filters? What about your jetpack? Anyway, so let's get to it. So we have nothing yet, and you have seen the station, so that looks like a lot of work, and yes it is. But the idea really is with this game to dwell in the moment. Instead of like, where's my rocket? Your rocket is 40 hours down the game, okay? That's not what you have right now. Okay, so we can see we have highlighting wherever you click. Here we have some supplies to build an airlock. And you always have the tooltips, which are pretty expressive. Here, for example, it tells you can use a tool, a wrench, to unfasten this box. And the lander, which has a simple tooltip, but this changes. I will just open my tool belt, pressing the left Alt key for the mouse pointer, and I will click the right mouse button on the wrench to teleport it into my hand. Now if I point the wrench at the lander, since I'm now holding a tool in my current hand, you can swap hand with E. You can see that down here, Press E to swap the hand, press T to place something carefully, press Q to toss it. So you can see here that I can use the angle grinder to deconstruct the entire lander. And since I don't need it anymore, that's what I'm going to do now. Now I'll use drag and drop so you can see the difference between the teleport clicking. It's just a convenience thing, See, that saves you some time. Like I already demonstrated in the introduction, here the oxygen tank, you can use that to dunk your air canister into that thing. But you shouldn't do that with the wrong canister.
Air tank critical.
Because this tank, the waste tank, let's look at the waste tank actually. Well, there's nothing in here yet. You can see the cartridge doesn't have anything in it. We have the network analyzer, but we don't have a current cable network to look at. Or the tracker, which allows you to look at the beacon or at or at other players, so you know where they are. Let's see what's in my waste tank.
Waste tank critical.
You can see most of it is CO2, some of it is oxygen. But if I would dunk that into this thing here now, the atmospheres would mix. And so henceforth I would get some CO2 here in my oxygen canister when I dunk that in here to refill. That's not tragic, but it's not making the best use of the small volume that I have here. And also, what if we have a canister that has different content? Like, for example, this guy here. That is fuel gas. Oxygen, yeah, that's fine, but volatiles, you don't want to breathe that, that kills you. So if I dunk that in here, well, that's the end of me, basically. Don't do that. And so if you pollute your oxygen reserve, which could be this, but it could also be, like you've already seen, just a canister holder into which you dunk your... into which you stick your canister, which can then be refilled with pumps or just with the natural pressure that's in the pipe, then, well, you might actually pollute the source that you have here with the gas that you don't want in there. And then, you know, if you don't have the filter for that, then that will come into your spacesuit and you will have to breathe that. That's dangerous. And you could say, well, what about nitrogen? I mean, 80% or 79% of Earth's atmosphere down here is nitrogen. That's the case, indeed. And almost 20% is oxygen, and the rest is CO2 and some trace gases of xenon and other noble gases. So nitrogen is harmless, right? What if there's some nitrogen in this canister? Well, that's a problem because this will not be removed. So you're getting a mixture. Well, you have already seen what an air mixture looks like here with the scanner. You're getting a mixture of gases into your suit for every ounce that is being pumped into your suit from this canister. And so you're getting a little bit of nitrogen. But the nitrogen will never be removed. The only thing that's removed is the O2 that you breathe and the CO2 that you breathe out, or that may already be in the air tank, but it shouldn't be. The nitrogen would not be removed. So eventually, almost the entire atmosphere inside the spacesuit here, where you can see the pressure, would be nitrogen. And then no more air can be filled in from this mixed bottle, which should ideally not be mixed. And then, then you will no longer have atmosphere. Then you will no longer have O2, and then you will have the respective suffocation events. Let's talk about the buttons for a second. Every button in Stationeers will tell you what it does when you click it. So is the filter currently off? No. Now it's off. And you will now slowly see that the pressure in my suit will increase because the CO2 that I breathe out will not be removed. But so that enough O2 is in there still, eventually some more of the oxygen, currently nothing, still a bit, will be pumped into the suit. So eventually the pressure will increase, and then it cannot go further, and then there will be the majority CO2, and then I will no longer have enough O2 to breathe. We will have that soon enough, I guess. Okay, let's take a look at the supplies that we brought. This duct tape is, by the way, necessary if your suit is damaged. Then you hold that in your hand, press the right mouse button, like you also use this thing or any other tool that you hold, right mouse button to turn it on and off. And left mouse button to use a tool like this. But it says no, you need the hand drill. Didn't it say wrench? Yeah, the wrench was to unfasten that from the lander. The drill would be used to explode this thing into where everything would fly all over the place. And then you would also have the folded crate here, which you could then unfold again. Nothing gets lost. Anyway, so we have the survival supplies.
Oxygen low.
Oh, that's the thing, no? We have the tracking beacon. I place it on the ground carefully with T, and then I turn it on.
Oxygen critical.
Now I could use the beacon, and no matter how far away I am, the arrow would always point here. And this battery will last for almost an hour. So even though it's a small battery versus my current spacesuit battery, see how convenient that is that you can swap them, it will last for almost an hour, yeah. yeah, let's do something about that. You can see here the pressure is 100 kilopascals. If I now turn on my filtration, you will see that this pressure will decrease incredibly, not to 97, but much lower. Why? Because now a much larger percentage of the gas in my spacesuit than normally is CO2. All of that will be removed as soon as I turn on the filters. Well, maybe I misremembered that, or maybe there was a different thing. Or maybe I should have turned off the air at the same time. I don't know. Okay, whatever. So, here we have the building materials that we need at first. For example, the iron frames. Right mouse button to build, and you can see the world is secretly consisting of boxes, but you know, you cannot actually see that. But if you use the tablet, you can see we're currently in a world box, and its capacity is 4,261 liters. And this one has a capacity of... Oh, I'm actually confusing, that's full 8,000. 4,093. Why? Because part of the world box is basically cut off by the surface. The rest is free volume, where some gases could be. Maybe you've noticed the sun is no longer moving. I froze it so that we have some daylight while I build everything. So right mouse button, so you get this build ghost, left mouse button, so that we build something. You can see you can also build underground, basically. The building and grabbing, you can even grab some stuff through the windows. I hope they, I hope they avoid that at some point. Is very lenient, but that doesn't really get in the way of the experience, because it is, I mean, in no other game will you have an experience as deeply as in this one, as in Stationeers, of wrapping yourself into your own deeply simulated personal reality. Here you can really build a home and experience it as such. And I think that's a very strong emotional thing, because that's what we've been doing for thousands of years. The home has a very special meaning, and here you can build one in space, on the moon, or on Mars. I guess that once you've seen this video, you will possibly just try to do your own introduction, your own first play attempt, and you might do that on Mars, and I recommend that you do so. Why not? Mars even has an atmosphere, so you can use that, it's CO2, to get some gases, while here on the moon I would have to use tricks like mining the oxide. I wonder why it's not melting. Normally it does that when it's out there in the sun. To get gases, but on Mars you can just use the Martian atmosphere, and it has a lot of CO2 in this game, so you could use that in combination with your plants to convert that to O2. And that's already very intriguing, right? You have to balance all that out. How many plants do you have? How you will pump maybe pure CO2 into your greenhouse facility, then you will maybe pump the gas from the greenhouse facility through a filtration unit that will just divert away the oxygen, and the rest you pump back in, so you only have pure CO2. See how cool this is, and all of that is simulated. We can play all of that freely. Yeah, that was the mining drill. And you can see here, if I mine something it falls to the ground. That is because my mining drill is not, my mining belt is not currently the... Oh, you see that? It's streaming away. It's melting. So now we don't have a vacuum here, but now we have a little bit of nitrogen, a little bit of oxygen. But now that has streamed away. All of that is simulated. So you would have gases streaming through your station. You will have temperature change in your station. If you're using the furnace on Europa, which is super cold, when you first build your station, when you wall it up, you will have super cold oxygen in your station, which is nice, it's just too cold. Well, what I often do is, what I always do on Europa is I build my furnace indoors, because it's an absolute beast. And It bleeds a lot of heat, so that is how I heat up my station. So much so that it heats up too much. Then I have 50 degrees, 100 degrees, it's way too high. So I just open the door, since the atmosphere out there is oxygen too, to cool it down. Or other means, of course. We have heat exchangers, for example, or an AC. Anyway, so if I use this belt and put it down here where my current tool belt is, see, now I have the tools and the mining belt, and the tool belt doesn't benefit from being down there in your belt slot. But now if I mine something, it will actually land automatically in my mining belt. You can also pick up things that had been fallen to the ground, or, you know, like ices, by clicking on them with your mining drill. Here you have some iron. That's one of the most essential things to ever mine. You will need so much of that stuff. But you will also find so much of that stuff. What you will find less of is gold, though on the moon, yeah, that's not so critical. It's one of the easier worlds. You will need a lot of copper, gold too. But look here, volatiles. That's part of the stuff that we had in our fuel gas. And fuel gas works as follows. I mean, there are two kinds of fuel gases, nitrous oxide and volatiles, and oxygen and volatiles. Let's just talk about oxygen alone, about volatiles and oxygen together right now. Maybe you can already guess how this works. You would have to mix this in the right ratio yourself. Though, let's take a look at the helpful Stationpedia, which even has hyperlinks internally. Click on the ores. And here we, for example, find the oxide. Here's some description. The human-made text descriptions up here are sometimes not reliable, since, I mean, they have a very small team working on this game for 10 years now, and it's underfinanced. They don't expect to actually make a buck with this, but they want to keep going even past version 1.0 eventually. That's what they keep emphasizing again and again. It's not a joke. They finance this with other projects, so this is a niche game. That's why it develops, why it evolves very slowly, but it is also absolutely unique. You have never seen a game like this. So that's the human-made stuff here, which cannot keep up with the changes of the game because they just don't have the manpower to keep up here. But the stuff below, that is written by the computer itself based upon the simulation implementation. And you can see here that oxide has a lot of oxygen and a little bit of nitrogen. So if you use that as the source for the oxygen that you breathe, then, I mean, for example, by taking some oxide and dunking it into... Oh, where's my stuff? Oh, there it is. Then you might have to add a nitrogen filter to your spacesuit, as it will eventually fill up with nitrogen. Though, I mean, you're not completely lost when that happens. Here, let's look at the helmet, which I can also, by the way, open.
Pressure critical.
Not advisable.
Oxygen critical.
On the moon. You can lock this, but never do. And you can flush it. That is how you would get rid of atmosphere from your suit that you don't have filters for.
Critical.
But it wastes a lot of oxygen, so yeah. So I can toss the oxide directly in here. I can do that. And then it will melt in there. Then I will always have some nitrogen in there. Until, of course, I mean, I can empty this entire thing. It can be screwed to some kind of base plate, and then you can connect pipes to it, and they can pump it empty and pump stuff into it. Yeah, I mean, the game is super flexible. You have seen nothing yet, man. Yeah, and fuel gas works as follows. The one fuel gas I want to talk about now, it needs 2/3 oxygen, which is basically 2 of these, and 1 volatile. And if you have a mixture that is wrong, that will still burn. It will just burn up in the ratio 2:1. So in the end you will be left with only oxygen or only volatiles, whatever the imbalance was. So very simple, very straightforward, very convenient, and very cool also. So this is my building materials, and here we have some airlock supplies that will come into play later. Then survival supplies like flags that you can plant, for example on hills to navigate. We have water bottles to drink from. Here I will just drink a little with the helmet closed, which is only possible in easy difficulty. Here we have some money, because you can build a landing platform for traders. And well, you can trade with them, you can sell stuff to them, you can buy stuff from them. Fire extinguisher, which actually uses gas, of course, because everything in here is simulated. Here we have a liquid canister, I think that's CO2, yeah, you can see that in the name here, the liquid CO2. It doesn't say liquid CO2 because there's liquid CO2 in there, but the ones who created this starting situation, the game developers, labeled it as such. You can also rename it. Where are the airlock supplies? Here's the labeler. Survival supplies. Now they have this name. Here we have hydroponics supplies. You land with some potato seeds, some wheat seeds, and some soybean seeds. Soybeans give you oil, which you can use then to, for example, create canned food, which is lasting much longer and gives you higher food quality. You can see here the 3 stars. If I only eat raw potatoes, there would only be 1 star. And what do the stars have as effect? The effect would be the maximum food and water that you can hold, basically. Not what 100% means, no, but where your roof is. The roof could be at 75%, at 100, 125, 150, or 175% even. Oh, have you seen? We have a compass here. So if you use that, you have some kind of cheap way to navigate back to your station. If you consider for lateral movement, of course. And the electrical supplies are also pretty important. Some battery cells, large like my own, and they actually discharge if the atmosphere is too cold. So on Europa we would already be at, I don't know, at this point 95% maybe, so there's a concern. Let's continue building the station. Where is... there it is. Or did I forget a box? Not quite. Okay, how do I know how to continue? Well, I already showed you the thing with the tool that you hold in your hands. Any tool you pick, when you hold it in your hands, you will get a tooltip that is more elaborate. Sometimes you don't get any tooltip, sometimes you get one, and sometimes the tool doesn't make a difference. But here it does. When you construct something, just pick a tool. If I pick the angle grinder, which can be used to deconstruct it, then you don't get that information. See, now you get the entire thing back. But not the battery that was wasted using the tool, you know. But if I use a tool that is unfitting, then it will tell me all the tools that would be fitting. Welding torch and 1 iron sheet. Okay, I have a welding torch. And if you observe here, if I turn it on, now we have some very hot gas, but at a very, very low pressure, so it doesn't matter much that the heat is so high. And we can see the mixture. Pollutant is basically the entropy outcome at the end of our gas processing. That's dead. That's pollutant, that's waste gases. Well, but it's pretty useful. I mean, let's take a look, for example, at the phase change diagram of pollutant. Up here, the blah 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 is possibly correct, but down here, all of that's definitely correct because it comes from the simulation. So let's switch that to Celsius and to non-logarithmic scale. The higher the pressure gets, the pressure is the vertical axis, the higher, the more longer this gas would stay liquid. Let's switch to logarithmic scale, which is more practical. Down here, it would just evaporate. Even if you have ice with very low pressure, it would just turn into gas. But once the pressure is high enough, the solid would stay solid, and it liquefies at this temperature, or it turns into gas immediately, depending on where you are pressure-wise. Pressure is the vertical axis, like I said. And here we have a long range from like minus 100 degrees to like plus 150 degrees Celsius, where it is liquid at roughly this pressure. So you can use it easily for phase change shenanigans, or for destroying your gas pipes, which don't take kindly when there's some liquid in them. There are also liquid pipes which can take gas or liquid, they don't care, but their maximum pressure is only 1/10 of the gas pipes. Yeah, let's continue. If this playthrough, if this demonstration is too slow for you, which it can easily be, I have a 35-minute turbo introduction video which uses cuts, which is really fast and really gets you very, very deeply into the game. The link is in the description. So we can see here you can weld that once, then it's solid, you can build on it, but it's not yet airtight. If I weld that twice, then it's solid, and then it's airtight. You will notice the sound changing. That's because currently there's vacuum, but this welding process excretes a lot of gas, more than when this thing is just idly burning away, you know? Okay, I already burned through all the metal iron sheets. That's a concern, because yeah, I think I'm overbuilding here. I think I'm building too much, made the foundation too large. Okay, let's clean this up a bit. A word on field of view. Some people complain that my field of view is so high, but only some. I mean, I have years of experience of doing this, making these videos, channel with over 2,100 viewers, so I can tell there's only very few people who seem to have a problem with this. Well, if you're watching this on a smartphone, then, which I can understand why you would do that, sitting on the bus or whatever, to waste some time and to learn something, something cool. Yeah, I can understand, and that would then be a bit off-putting, but I can't help you with that. This is for PC use. But on the PC, someone might still complain, and to those people I can only say, you are wrong, objectively wrong. There's no other way to slice it, period. And let me lay out why that is the case, while I fetch some walls and put them up. Because I will explain the walls shortly. Because this interface here, like in many other games, is a 3D first-person interface. the purpose of that interface is to give you the experience as if you're really there. The functionality of that interface is to replace your own human first-person view, field of vision, with that of the game. And therefore, the best way to use this interface is to replace as much as possible of your first-person human 3D field of vision with this 2D projection of a 3D space. In other words, your effective screen size should be large, which mine is. So I am doing it objectively right. Now, if you would have a screen that you're carrying in front of you that has a that's showing a rendering of your immediate environment, of your living room, of school, of whatever. If you would do that and aligned in a way that if you would point the screen in a different direction, if you would turn, then you would still see the surrounding space, which is showing the actual reality, because the screen is not infinitely large, would align that perfectly with what's being rendered on the screen. So you would have CG computer graphics on the screen, but the real world would be around it, and it would be perfectly aligned. Now, if you pull that screen closer to yourself, you would of course have to increase the field of view, like so. And the further you push it away, the less you will see actually of the rendered world, and around it you will see your real world. And that's how that works. And that's all there is to it. I don't know why there are so many game developers who don't understand the medium that they're developing for. There's so many people out there who don't understand how this works. And there cannot be a critique regarding my field of view, because I'm just doing it right. If the only thing you could criticize is that my field of view is too low, because even though my effective screen size is large, I can still see quite a lot of world around it. So I'm basically still doing it wrong. And well, when I say, are people really that mistaken? Is that not a bold claim of mine to make? No, it's not, because people are, in principle, you could say the general public, people are stupid. Look here, while I change the station, which is kind of fucking with my process here. You can see here the audio sliders, and in this game they are correct. You notice that it gets much less loud. Oh, whoops, wrong slider. As I move away from 100, and that's the way it needs to be. But most platforms, even YouTube, even Steam, the Steam store, all of them are doing it wrong. Loud, 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 less loud, less loud, less loud, less loud, less loud, kind of medium sound, kind of medium volume, lower, lower, and now it accelerates ridiculously to 0. That's what most volume sliders are like. And most of you are not complaining about that, or the developers, dim-witted as they are, for not realizing what the fuck they're doing wrong there. They would realize that. So when I say the field of view, as obvious and clear as it just laid it out, what is right and what is wrong about it, that most people are just not seeing it correctly. You can believe that. The average person is just stupid. That's the way it is. Anyway, so let's look at the walls here. Multiple things are coming into play now. One thing is we have a kit. I'm using my scroll wheel. You can see that here in the tooltip. There's a mouse icon and it has arrows. It shows you that you can scroll. And that gives you different types of this iron wall. There are different wall types in the game. This is the cheapest one, that's why it looks so crappy. I mean, you can tell this will be some welded iron sheets lumped together, and there are some variations of that here. And this is the window type that I want to use, which looks good. Lets light through, which also heats the station. That's a concern later. And what will give light to the plants, which need that. So that's one thing that just came in. The other thing that comes in is the placement. Will I put the wall like this on the outside of this block here, or will I put it like this on the outside of this block here? And that is not really important when it comes to. Oh yes, okay. Let's see the effect. If I would do this now, when it comes to air tightness, that would have no difference whatsoever. There is no air, no gas leaking through this. Absolutely perfectly tight. We can absolutely lean into that. But if I place cables here on the floor, for example, where this wall that you can see there, this box, is definitely on the outside of the box I'm currently standing in. I mean, that's the next box that we're talking about here. Same for this. But here, the wall is in this box. If I would place cables here, the cables would be on this side of the wall. So from this side, once placed, I could not access them. And so it makes sense that if you build your station, you would usually build your walls like this on the outside of the area. That's also where their decorative side is. You will see that eventually. So that's one thing. One thing is the type. The other thing is inside or outside. And the third is the rotation. For that, you can see that in the tooltip, you can use the 6 keys above the arrow keys to rotate that. Or you can also hold R. I think it's C in your case. You just have to check your tooltip, you know. I changed my... I've played over 2,000 hours of this game. So you can hold down the key, use the mouse wheel, and I suggest that you adapt your keyboard configuration according to your playstyle. For example, the jetpack is on J, right? Well, for me, it's on Shift. Because you cannot run in this game, you always move at the same speed. And Shift is kind of your movement modifier in every game. So it makes sense to modify your movement in this game, where you cannot run, with a jetpack. Sometimes you might be falling, you might have to protect yourself. The gravity on the moon is low enough, nothing would happen if I just fall from this height. But on other worlds, the gravity is higher, and that might break my spacesuit. And then you want to catch yourself. So you want to quickly push Shift instead of, where was the J key, where was the J key, you know? Okay, that is then the rotation. And, well, why would I use the key, this hotkey? Just so that I can use the scroll wheel to change the rotation quickly? Because if I tap it, I mean, that's rather slow and it's rather aimless, isn't it? Yes, it is. However, there will be situations where the game can surmise what rotation you possibly mean. For example, when you lay cables, and then you will love that you will have that key. That will use the very same concept with the rotation keys here, above the arrow keys, and this auto-rotate key. You will see that soon. Anyway, so these walls are obviously not yet complete. What do we need to complete them? Well, maybe I should get rid of some stuff here. Oh, by the way, yeah, before we actually put up the walls... it's too far away. We should get our stuff into the station. Because it's pretty cumbersome to carry them in through the airlock. Now we'll just toss some things on the ground that I don't need, so I have more inventory slots. The road flares are fun. They're not excreting any harmful gases, but they're excreting heat. So sometimes you can actually use those to, you know, lock yourself into your airlock of your almost but not quite yet built starter box base to heat up the air, to open your helmet, to eat something and to drink something. Remember, we're playing on the easy mode right now. On the normal mode and on the hard mode, stationeer mode, you cannot drink and eat with closed helmet. Let me just check the radio station. Yeah, that's fine. Why would I want to get my stuff in here? I mean, you can also build a station that is not encased like this, though you definitely want some box to breathe in, of course. But I mean, you can also just have your mini factory, your 3D printers, your furnace. Most of all, many people build it further away from the station, is that in case they get something wrong and it explodes and leaves a large crater. It does. You can build that outside your station, of course, but if you're playing on a world with atmosphere, which the moon is not, then you will have to contend with storms. That will happen from starting day 7 or day 9, something along those lines, not at the very beginning, and they happen every 2 or 3 days. and that will blow everything away, including your landing capsule, everything. And then you're kind of lost, right? Now, yeah, in this capsule we also have something to eat and something to drink. But that's all. Now everything is indoors. You can do that too, to build outside, but you have to keep in mind there will be storms. So that's why I'm just showing you, basically, I'm showing you kind of an average of how you play this game. Some things you should want to do faster. On the moon, though, you have the time. Yet I'm doing them faster, like using the angle grinder on the lander to get things detached quickly, instead of relishing in the individual tasks of simulating to actually be on the moon and to actually take that box from the lander down to the ground and so forth. All things that I propose that you should try to do. Try to love this moment instead of trying to quickly get somewhere. This is like the most zen game you can play, yet it's a survival game. Well, talking about survival, we will need an airlock. That's why I left this opening here. And like you already saw, an airlock needs at least 2 doors. I mean, yeah. Should I use maybe a solid wall here for entertainment purposes, so we have something different? Yeah, let's do that. So what do I need to complete this? I point at it with the tool and it tells me 1 iron sheet. Okay. This wall is now complete, and yes, it looks ugly. And what does this wall mean? Oh, it also needs apparently iron sheets, And what else? We need iron sheets, and then we need glass sheets. Now this is a complete wall. And of course you can be more efficient about this. Just keep holding down the button. And turn off your light when you don't need it. Your battery consumption is higher on higher difficulty levels. So is your jetpack consumption, so is your oxygen consumption, so is your sensitivity to heat, so is your water and food digestion. And no, we don't have to actually defecate or pee in this game, sadly, because I mean everybody when playing this game will think, of course, of the great film The Martian, which by the way is built on the book by Andy Weir, if I'm not mistaken. Let's not misinform, let's see. Andy Weir, Martian, I think that was Andy Weir. Yep, Andy Weir. And I have listened to the audiobook of that, and it's even much more elaborate when it comes to engineering. It's much more interesting to a real Stationeer player, so I recommend that. So let's see if everything is tight. Up here, that's easy. I just check whether I fall in, right? But for that, I have to be at every location, which can be a bit slow. Also, what about the walls here? And for that, you can use the crowbar. See, it's completely highlighted. Here too. Oh wait. Here also. But not when I point at the middle. So that's what you have to aim for. If you want to check the walls, look if everything is closed up. And here it is obviously not yet. man, I think I will be out of iron sheets, which is a problem. Because to build the 3D printer, the first one, this is the Autolathe, I'm already carrying it, to make more iron sheets, I will need iron sheets, 2 of them. So I cannot close up the entire station yet. Yeah, I've wasted a bit. Or can I? 1, 2, 3. Only 3 more? Unbelievable. Now look at that, we have a completely closed station. Now if I turn on my welding torch, which you can also do like this, you can see gas streaming away. Yeah, at some point it has streamed, it has spread out in this room too much to have enough of a differential or pressure level that the game would bother to show you the animated pixel, but ultimately it's streaming out here, out this opening. I think we should even be able to measure that. Yeah, but this tablet also doesn't show you the values down to the very last decimal place of the double precision floating point values that they're using. Anyway, okay, so here would be the airlock, and now since we have been talking about walls so much, let's talk about doors 2, which are related. For that we look at the airlock supplies, if I can find them. That's the box. And there's the door. Okay, again we can rotate, but now it's only allowing these 2 because there's no room and you cannot rotate these doors vertically. There is this floor hatch, which is a manual hatch, you just have to click on this thing. And there's also a manual hatch for the side, so just like the other door that we just saw there. I don't know why it's suggesting to build that in this place, while it is not doing that. Oh, right. It was me. I was confused. So I'm currently using the auto rotate key, and then indeed it will not suggest these meaningless placements. Okay, so we have the manual hatch and the manual hatch for the floor. Then we have the glass door and we have the composite door. And then we finally have the composite roll cover, which is not a door. It is something that will cover the door, but as you can see there, it has a handle. You can click on this thing that opens, so if there's a microchip or some cabling underneath that, you can easily reach that without the wall being fugly. Okay, that's the doors that we have. So should we put up the composite door here or the glass door? Well, let's ask the Stationpedia. Composite door. Here you can see that the max pressure is 300 kilopascals. This means that you can put 10 megapascals of pressure on one side of the door and 10.2 megapascals of pressure on the other side of the door, and then it will still work. See, this is about differential. So on the moon we have no pressure outside. On the indoors we will have a pressure of like 100 kilopascals. You can see here on the right side that my spacesuit pressure is set to 101 kilopascals, which is the pressure that we have on Earth at sea level, so you can just use that as your baseline for what you will have in your station, though I mostly have lower pressure. If the entire atmosphere is oxygen, then 20 kilopascals will suffice. But if a lot of it is oxygen, then you can go for like 50 or 60 or 70 kilopascals. And I like to keep it between 50 and 100 because the plants like that pressure the most. Anyway, so that's one of the aspects of this door. 300 kilopascals. So what about the other doors? Now let's learn something about the kit versus the structure. This is the structure that I built in the world, but it is built from the kit. You have seen the kit. I was switching through the individual doors. Let's look at the kit then. You can see here there's a hyperlink to the kit. There, that's the kit that I'm holding in my hands. And this thing also has a flashpoint, yeah. And here you can see the individual doors, so I can go to the other doors from here. That's pretty convenient. Back and forth. The glass door only can hold 200 kilopascals of pressure differential. But anyway, we're on the moon, the easiest world of all, or Mars also. Mars though has storms, that's why that's more to consider. And also, yeah, that's basically it. That's the main reason to consider Moon possibly even easier than Mars. But Mars is easy because you have endless atmosphere to pull from in case you lose all of your stuff, you know. It's not oxygen though. Okay, now we have learned some things about the Stationpedia and about the door kit. Let's put up some door. So right, another thing. The glass door is constructed from the kit door. Then we put that up and then we will have this empty frame. Then we have to use plastic sheets and then we have to use glass sheets to complete the build. What about the composite door? Or was that the composite door? Hey, you need more glass sheets here. How many glass sheets do I have still? 7. That's sufficient. I mean, everything's closed up, so we have the free choice. So does it matter which door I choose under these circumstances? Yes, it still does, because there's more to be considered. I know this sounds like a lot of things being thrown at you at once, which they are, but you don't have to consider all of these. You can also live through them and then experience the problem. But I'm just trying to show you the depth of the game, and also to avoid some beginner mistakes which would leave you possibly frustrated or even helpless. The composite door doesn't need any space to its left or right, but the glass door does. You can see here the glass door has bigger doors. So you cannot place a cable right here, but you can place it here. There's a small grid, like here and here and here and here, and there's a large grid, which we already know. So I will build both doors, then we have a demonstration of that. See, now this is closed. The station is now hermetically sealed at 2000 degrees Celsius, but no pressure. See, the thermal, it's about thermal energy. Indeed, if you look at the save game, you will find that the gas containers have a value that is energy. That is referring to the thermal energy. So if I would fill up the station now with gas, then it will cool down quickly if the gas that I fill it up with is basically 20 degrees only. Because, I mean, humans are already building fusion reactors on this planet, in reality, and they have temperatures in part of millions of degrees. How do we have any material that can withstand that? Well, apart from the magnetic fields that keeps the stuff contained, I believe, but the main reason is that it is such a low pressure that the actual thermal energy, the overall energy, is not that high, really. The composite door is different in another regard also. Let's look at the airlock supplies. There was this labeler thing. You can see it says here composite door. Well, let's rename that to Airlock. See, now it is saying Airlock here. But now I can't get out. Well, I push the button and it opens. No! It is not powered. Oh no, I'm now locked in. Now I have to unbuild the entire door. No, you don't have to. You can open and close the doors with your crowbar as long as the door is not powered. It will tell you that. But how do we power the doors? Well, let's see. What power sources do we have? We have the sun. That is casting thermal energy at us. I mean light energy, not thermal energy. Light energy. And we can catch that with, where's the electricity supply? With the solar panel. There are multiple different solar panel types in the game. This one is only of type flat or diagonal. So you can even place it on the wall if you wish. But there's also a type that can be oriented almost freely with your wrench. And it also has some servo motors, and so you can use some microchips or maybe the IC10 MIPS assembly language to program its orientation based upon a daylight sensor. Now this is me cheating basically. See, the day duration of 20 minutes is very short, but I froze the sun, so I now will have endless electricity here at almost 500 watts, which is the maximum that these things can output. If you would want to keep up with the sun, so later you unbuild this and build it up again in a flat because the sun is here, and then you build, you know, then you point the solar there. That's very tedious, and you know, with a 20-minute daylight cycle where you have like 10 minutes of day or 8 minutes, I don't know exactly. I mean, you have to remember this is a ball that we're on here. So the sun will be below the horizon, so the day duration is not as long as the night duration. I'm pretty sure that the day duration is actually shorter than the night. Is it? Anyway, whatever. But if you would slow down the day-night cycle to like 200 minutes, then it would make sense to manually unbuild this thing to point it at the sun again. Or to, for example, use your wrench on the advanced solar panel that you can point it at the sun manually. So that's one way in which you can kind of cheat, but there are so many factors involved in playing this game, it will not feel like cheating. Also, 20 minutes day-night cycle, really? I mean, this is so unpleasant that all games do that. They keep hasting you through all the features they have to offer. So does Stationeers. But some hackers, so to speak, have already spotted some invisible day duration slider in the world selection menu, so that will eventually be a thing. Now, how do we get power? That's a power source. I could now cable this up and connect that to the doors, and that would even work since the sun is frozen here, but eventually there would be no output here, so we need a buffer. Do we have a buffer? Well, we have some batteries, you saw those already. But how do I connect them? Well, there's a battery charger, but that's not the answer. The battery charger can only charge batteries. It cannot unleash their power back to the cable network. That, though, can be done with the area power controller. This thing is kind of like the battery charger, except it also has a switch here. You can see that down here. That allows you to turn... it has a second connector to where the power flows, you know, input and output. The output will not have any power, even if there's a battery in there, or even if there's power connected to it, but once you turn it on, there will be power. The power can flow through. So, now, rule number 1 for any and all Stationeer, no matter how many thousands of hours you have on your belt, then of course you know this already, the Airlock, the area power controller, at least one of them, belongs in the Airlock. Absolutely does. There is no doubt about that, and no, there's no two ways to slice it. Why is that so? Because if you're coming back from an excursion, there are two variants here which are just cosmetically different. I will just use this one. If you come back from an excursion, then you will find that you might find that your airlock is without power, and then you cannot get in. What will you do then? Break open a wall, release all the gas, try to walk against the storm, which might not be possible right away, and your plants might die and so forth, and the outer atmosphere might also be toxic. On Vulcan, you have sometimes you have 1,000 degrees daylight temperature out there, 1,000 degrees Celsius, and the atmosphere is explosive. Even if you unleash some CO2 here, it will just explode right away, and it cannot be breathed, obviously. You don't want that, so you need a power supply for your airlock in your airlock. And since this thing is battery buffered, you can just quickly drag your own suit's battery in there, or do the airlock cycle, drag it back. This will not be deadly normally. Yeah, so this thing belongs in the airlock, absolutely. How do we get power here then? Well, let's use the cable. I hope the constant saving that I'm doing automatically, which by the way you can set in the settings here, autosave. It is turned off, the minimum duration is 60 seconds. But you can also save manually, and I'm using auto hotkey to send, if Stationeers is the currently focused application, this F5 key press every 10 seconds, but with a condition that the left Alt key cannot be down, because if it's currently down, and if I would press F5 in the meantime, then this would drop the current thing I'm holding. So that's why I set this up like this. So saving this updates the XML file that contains the save game information, and so you can see the head-up display update. Anyway, so we have the thing here, which I didn't put on the airlock because there will be some things in the ceiling of the airlock soon, which would then collide with this, so that doesn't work. Now let's lay some cables. You can see here, when I press F2, I turn off the head-up display. F3 is for the console, and F1 is for the Stationpedia. You can also pause the game while you're in the Stationpedia. Or you just press escape, which pauses the game, and then you press F1 for the Stationpedia. So the cables, we have this cable, which is straight. We also have one that goes around the corner. Then we have this variant, the cable junction, which is very important, blah blah blah. Okay, I'm not gonna try to pull your leg here like I originally thought I would. Instead, I will just give you the short version. You don't have to know and use all of these at all. The only one that you really need is the straight and curved cable, because there's a trick, and it's not a hack, it's intentional. So I press the right mouse button to build, then I press the auto rotate key, in my case R, in your case it is whatever your tooltip says, or whatever you have configured here in the settings. Some few of these many things that are listed here are without function. I don't mean these ones where there's no key assigned, I mean some of them don't appear to do anything. Mouse inspect, for example, doesn't do anything. Oh, and there's, for creative mode, you can open a menu that shows you all the things that you can spawn, and then you can press the spawn key to, well, to spawn them. But you can also spawn a creative tool. That's what it's called. It's called the creative tool. It's like a wand, a blue wand. Once you have picked something with the menu for the creative mode, then you can use the wand to build it immediately without first having to spawn a stack of it or whatever. And you can even use the wand to complete the wall. If you're building a box, for example, come on. If you're building a wall here, for example, and you click on it with a wand, it will just complete the wall, blum blum, and very quickly. And unbuild it even if you keep holding it down. So, yeah, creative mode, I recommend that for learning and for trying things out, but also you must be aware that it will be a spoiler. It will give you spoilers as to what is possible. It will cheapen the simulation a bit. I mean, I played for almost 1,000 hours before I first really used the creative mode. So, yeah. Okay, you can see here we have a ghost visible there. It's yellow currently. Here it is not, because it doesn't have any connection, and here it is because it has a connection. You can see it has a yellow plus and a green plus. The yellow one is connected, the green one is not, and so you can even build blindly behind walls. This might seem a bit obscure to you, but once you have built a few cables, this will you will be sleepwalking. That's completely easy. Curved cable, straight cable, and so forth. Now I want to go down into this. This is the output side. You can see the tooltip of the area power controller, and behind here, nicely, we can even look through that, is the input of that. Yeah, let's use this. The wire cutters to remove cables. That gives me back the cables into my stack. Okay, now we have the solar panel that is pumping its power into this guy here And we have some batteries. And I will just take one of these. The saving is a bit off-putting, isn't it? And we'll put it in here. Alternatively, I could just have clicked like this. But it is already full. You can see it's at 100%, that's why it's blue. Let's swap that with my battery. And you should always swap in this direction, from here to there. You can also swap from here to there, but what if you accidentally drop your battery, which turns off your flashlight, so you don't see anything anymore? You might not find the battery even. And what if at that moment you also have some kind of airstream and things are rolling around? I mean, someone had reported that in the Steam forums, I believe, a few days ago. That was funny. And that's where I took that tip from. I never really bothered with this, but now I realize, don't drag from here to there, drag from here to there. Because if you drop this battery, well, not only will nothing happen, but also if you would drop it, who cares? It's just your airlock being without power for a moment. 30%. 31%. 32%. You notice in the head-up display and here, which is fake, that is not part of the Stationeers experience, and up here in my suit, that the battery is now full. Basically full. Alright, so we can now power the doors, right? Let's cable them up then. See, it's not offering me all possible rotations, but only the ones that make sense here. While here, it's offering me all rotations. That's why the auto-rotate key is so
Hydration critical.
So useful. So now, what do we here? If you check the tooltip, you already know. I cannot do this here. So instead of cutting away this cable and then picking out the junction, I can just take the wire cutter in my other hand and then just place the cable, not select the wire cutter, I don't want to cut something, but the cable, and then build it. Yep. See, that's how easy this is. Now the doors are powered. I mean, as the next step, I could basically put some gas into the station, but if I then, I could, you know, close the outer door and the inner door, and then toss some oxide on the ground and melt it. Oh, let's just do that. I have enough. It's not a problem. Now it's melting because it is, well, it easily melts when it's on solid ground and the sun is shining in. If it doesn't melt, you can just always aim it with your welding torch and melt it. That works too. It's a new thing for a few months now. There's also a different welding torch later, the arc welder, that you can print with a 3D printer that doesn't have any waste gas. So this one has fuel gas. We already saw what type of gas that is. Let me just top that up. And the other one is electric. And this one can set the air on fire, which can be useful, but is often undesired. The other one cannot. So that's one consideration. Anyway, now we have some gas in here, a little bit. You can see here, it's already heating up. Why is it heating up? Because the sun is shining in. And it seems to be heating up quickly. Yeah, that's what it does. Pressure 5 kilopascals. Actually pretty high. I didn't expect it to be this high already, from only 17. Anyway, now if I open this door, the pressure decreases because the overall volume is now larger. And then I can close this and then open this, and then everything escapes out into space. Obviously the airlock is not yet complete, but we have kind of an airlock because, you know, the gas in there is protected, mostly. Now we need a pump to get the gases out from this room. So let's install a pump. Here, as part of the airlock supplies, we have the active vent, one of the most used devices in the game, which is... Oh, I will place it... where will I place it? I will place it here. You see it has a big plus and a small plus. The small one is for the cable, the big one is for the pipes. And spoilers, the pipes are being laid and used exactly like the cables in every way, except you don't use the wire cutters in the other hand, you use the wrench in the other hand. So this thing is an inlet or an outlet for gases. It itself doesn't have... It is not a gas container, it's a device that moves gases. How is that relevant? Okay, let's not think about it too much, but that's just a fact. I don't want to go too much into detail. So let's place a cable here, a pipe here, and that's enough, right? No, it's not. Every pipe in Stationeers is closed until it bursts, maybe, or until you add, for example, a pipe cowl, or this thing here, a passive vent. The passive vent is like a pipe. It can have some gases inside of it. We can use the tablet to look at the pipe network, which is number 2181. This number doesn't mean anything to us other than it is the identity of this pipe network. If I place 100 more pipes here as part of this here, this would still be the same pipe network, and no matter which pipe I point this at, and the capacity would be bigger. Currently we have 110 liters capacity. Here, same pipe network, because this thing still counts as that. Let's look at the pipes. Pipe straight. 10 liters capacity, which means that the passive vent has 100 liters capacity, because we measured 110. It is a kit. From this you can also build the pass-through, which you can place on a wall, which basically is as if you're taking down the wall, the gas can just stream through in both directions. And there's also this thing which we just put up, except this variant here has a switch that allows us to lock, to prevent it from leaking out any gases. And if I close that then, not this one, this doesn't have the lever, then, well, the gas in there will stay in there. So it's closed on the outside, not in there. Yeah, so now I could, let's pipe that up, cable that up. And you might think, well, we could connect that to that cable up here. No, you have to absolutely think about cable networks. Let's use the cable network analyzer to deepen that knowledge a bit. Where will I find... on the ground somewhere, huh? There it is. Cartridge tracker, and there is cable network analyzer. Here you can see there's a solar panel and the area power controller. They're both connected to that cable. You can see what the actual power flow is there. The air power control, this guy doesn't currently need anything because the battery is full. Let's change that situation. Now it needs 1000 watts, 1020 watts, because this thing charges with 1000 watts speed. So if you would put in like 20,000 watts, it would not charge at faster speed. It would still be that same speed, which is important because these cables have a capacity. Let's look at the cables. Here we have heavy cables, 100,000 watts, and here we have the small ones that we have at the start, 5,000 watts. So if I put 20,000 watts in here, not a problem as long as the overall consumption connected to the cable, as in the currently active consumers, including which batteries are in there, are they full and so forth, are not consuming more than 5,000 watts. Otherwise, one of these cables would burst. So the actual flow is this. Why? Because that's the actual power that is coming in. Now the battery is full, consumption fell to 20 watts. And on this side we have the airlock. What is airlock? That's the door that I call the airlock. And the air power control and the glass door. Yeah, and they're consuming 20 watts because they use 10 watts the whole time. Both of them. Yep. That's how that works. The battery is pretty empty already. What can we do about that? Well, I could charge it. I mean, I have a battery charger. So I will just put up the area power controller and the battery charger on the inside here. And maybe I want to drink something so we get rid of that annoying beep. See, I'm pressing, but nothing's being drunk. When I release or when the bar is full, then I drink. In other words, when you're in a pickle, when that is at 0%, so that the little cross shows up here as the next entry, as an extra entry, which shows your health counting down from 100%, then you want to click on this thing for a very short time, so that you have something inside you, so you're no longer at 0%. So immediately starting to heal again, instead of still taking damage. Same for food. Okay, I wanted to put up these things. Where is the power coming in? Man, the saving interruption is a bit off-putting, I must admit. So I need to continue this cable here. I can also do this. This will not lose you a cable. It's just, you know, not a problem. Auto-rotate once again. How do I want to rotate this, huh? Can you guess? Obviously the arrows show the direction of the electricity. And you can see here, if you're very perceptive, that there is the word on is written there in this build ghost, and off also. And I want this to point into the station. I mean here into this area. So I use the scroll wheel. And then I use auto-rotate again. Now I have the other variant and it is rotated correctly. And for some stupid reason it's closed per default. Where will I put the battery charger? Next to it. Now, a thing you have to consider when you are laying cables like this, what I'm doing here is to that direction. Now it's a junction, it goes from here to there and also to there. What you have to consider is that you might be... I mean, this is correct, this works, not a problem. But maybe there would already be a cable here from a different cable network. And when I do this now, this cable that goes into the depth here, this curve, that would join that, and suddenly we would have both cable networks connected. That's not what you want. Anyway, so this guy consumes 5 watts the whole time, even right now. And it will not draw that from this battery, of course, because this is a different endpoint of our power source here. It just means that constantly some of the power will be diverted, not here, but instead here. Okay. So we have another large battery. I will just put that here, and I will power my station from this small battery. You have already seen the actual station batteries in the intro at the beginning. But here we don't have that yet. We have to first make steel, and we have to have the electronics printer to make that, and so forth. Okay, so my tools, let's charge them up. The crowbar doesn't have anything, the screwdriver not, the wire cutters not, the welding torch only has gas. The angle grinder would be interesting, so we'll just swap that directly. Done. The wrench doesn't have anything. The mining drill can benefit, yep. And then we have, of course, the handheld tablet. You don't have to wait here, of course. I mean, that's the cool thing. You will have so many things to do in Stationeers. So many things. You will always be doing things in parallel. This thing is cooking. Okay, let's do this other thing over here. In the meantime, you will always be busy with something, and all of it will mesh, will be meaningful, will have emergence effects, will have surprising effects. For example, sometimes you might suddenly be suffocating because a pipe burst in your station because the gases from the furnace inside of it had a lot of pollutant. And as we know now, pollutant becomes liquid under high pressure when it's not too hot. And so as the furnace cools down, is waste gas, most of which, or a lot of which, is pollutant, in the pipe that you might have connected to it to release the gases, but you haven't released them. That will cool down and it will liquefy. And the gas pipes, they cannot stand liquids. They will stress will build rather quickly, and then they will burst, and then they will release their content into your station, and then you will suffocate. So yeah, this is a survival game. And it's very laid back too, but it's also action engineering, depends on what you're doing. I mean, I'm currently playing the easy version of this game on the easiest world, so yeah. Nothing special yet. So let's power the this thing here. This extra cable that I'm laying there is for later, when I will have 2 pumps in the airlock. Currently I have only 1. You might think, why do you need 2 pumps? The other one for the outside? This is the moon, there's nothing on the outside. You don't have to, when the airlock is open, when you're coming from the lunar side, you don't need a pump to pump gases there, there's no gas here. Yeah, however, what if I have the arc furnace running out there, which excretes gases when it melts my ore into ingots? And that gas might stream in here too. And then every time I cycle the airlock, some of that pollutant would get in here, which at some point will then be a problem. I of course can filter the air. There's even a portable scrubber device that is very powerful that you start with. It's somewhere in my survival supplies. I mean, I don't want to even start with that kind of problem, so. Head-up display needs updating. And now it updated. Okay, so now we have this thing and I can turn it on. It has 2 switches. What are they good for? To set the direction. What's currently happening is that this thing is pumping gas into this room from this pipe, from this opening here. In other words, if I close the airlock now, we should observe that the pressure in here decreases, and it does. 4.81 kilopascals, 4.8 kilopascals, it keeps decreasing. Similarly, the pressure in the airlock keeps increasing. And I can flip it around. Now the air is streaming a bit more strongly than it was before. Why is that? That is because in reality and in the game there's no such thing as sucking. There's only pushing. Your dust devil at home, it doesn't suck air. It pushes air away, which means that there's a lower air pressure in the place from which it has pushed the air inside of it, which means that the outside air, which has 101 kilopascals where you live, will stream forcefully into this place. So as this guy pumps the gas into this room, from the only space from which it can grab it, which is here, the air here in the room voluntarily has to stream into this. I wonder if we should turn off this autosave HUD thing, because it's really just off-putting, isn't it? It's the first video that I make with this thing, so... Yeah, I will turn that off. 1 second. Dum, 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 dum. Is it still saving? I think so. No? Okay, good. Ah, damn, it still is? How do I stop this? Now it should be stopped. Okay, but if I if I pump like this, when it pumps from this room into the pipe, then it can reach into this entire box here. That's how that is implemented, and pump that into the pipe. So that's why we currently basically have a vacuum in here, because there's very little gas to begin with, and so this thing is fast enough to really evacuate this room. Anyway, that's the pump. So I could use the airlock now, yes, but it's not automated, so I would be prone to failure. I would just go here and push that because I'm so sleepwalking, and then I will lose all my station pressure. I want to automate that. Can I? Yes, of course. There is the kit console. I mean, okay, before we go into that, I realize this is one of those playthrough explanation videos where I explain every little detail, and well, so it is then. If you look at the Stationpedia, at the doors, as an example, glass door for example, and scroll down with the non-existent handle here, then we will find this stuff, logic values. What are they good for? Well, you can use programming to read whether the door is open, or to even write that so the door opens or closes. You can see whether it's on. Not that it makes much... Can I turn it off actually? I never tried that. Huh. You can see whether it's currently moving. If idle is 1, then it's not moving. If it's 0, then it's moving. So you can read all these values and write them too. I mean, some of them. You can also lock the door so you can no longer open or close it manually. And many devices have this lock value, or have this open value. Yeah, that too. The on value, and setting is a very common value that devices have. For example, there's an LED display, which incidentally I have here. That's the big one, which needs 3 of these consoles in my hand so that I can build it. The smaller one needs 2, the smallest one needs 1, so I could build this now. I only have 1 console. And the value that you can write onto this thing is being written into the value setting. And once you have written that, you can see the number here. So you can use logic, you can use chips. There's a value reader chip, there's a value writer chip, there's a memory chip, there is a comparison chip, there's a math unit, stuff like that, you know? There's even a chip that has a switch on it that you can use to turn something on and off directly. And they have screws, so you can use the screwdriver to configure those chips, which devices they should access, which logic value they should read and write and so forth. So you could build your airlock based upon that. Or you could use an IC10, which is the chip on which you can write assembly scripts, and then you can have your own automated airlock. And I made some of those. They're really fast and flexible. I even made an airlock that is as small as this one, but has 4 doors and is even separating 4 different atmospheres properly, and is also super fast. And the entire ceiling is 1 fan. I mean, there's a bigger version of this, and there's an even bigger version which takes the entire wall and is appropriately powerful, you know. It would even reach deep into the room, so if I would have one here and would turn that on, even this field would be sucked from. I mean, of course, all fields are being sucked from because they stream towards each other to equalize the pressure, but this thing would immediately take from this box. That's what I'm saying. Now you might say, okay, that's not realistic. Indeed, but that's, you know, at some point the fact that this is a game will come into play. But okay, for the beginning we have the consoles, which we have this diagonal monitor thing here, or this one which has 2 connectors, power and logic, or this one which has only 1 connector. I will use this one. And we can build the airlock with that, which is much simpler, but also much more limited. Power and logic. Here we also have that. We have the power connector and the logic connector. You have already seen what the logic connector is good for, because I showed you the logic values. If you don't have this connector, then you will not have these logic values available to your programming, to your logic chips and so forth. But the power will be on, and yeah, and vice versa. But some devices have their power and logic connectors combined into one, like this variant of the console, for example. This seems all very complicated to you, I guess, but it's only complex. At some point you will need a device that has 2 different outlets, for example the solar panels. But most of the time you will do fine with just 1 connector, which has power and logic combined. I mean, the game is very, very complex, and it's very, very, very fun. Once you have really gotten into the flow of building your station, of printing your stuff, of having a project, like I want to expand to over here, but this means that if I build out there and then I break open the walls to expand this part of the station, then the pressure in here will drop. So I first have to build up some pressure over here, or maybe temporarily build the pressure in here for a lot, and so forth. Or maybe you will have the problem that you're playing, for example, on Venus, which has very high pressure out there. And so if you have an airlock, which of course evacuates itself completely in between the different atmospheres, then you will have zero pressure in here. But the pressure of Venus is so high that this wall, which, let's check it, holds 200, I believe. ...200 kilopascals pressure, including the iron window, then the airlock will be under... So, I mean, the wall will begin to take damage every time you cycle your airlock. And similarly, when you are on a world that has a lot of atmosphere, high pressure, and you want to expand your station, then you will first have this toxic atmosphere in there. But you don't want to break open the wall with that toxic atmosphere. So what you want to do then is you evacuate that. And then you break open the wall, which drops the pressure in here ridiculously, so you have to think of that too. But also, if the pressure out there is too high, then in consequence, when you evacuate that, the walls will take damage and so forth. So you might want to scrub the air, want to purify it, want to swap that out with some buffer atmosphere and so forth. All of that has to be considered. What also has to be considered is getting warmer in here, warmer and warmer over time. And at some point we will have 100 degrees, 200 degrees. My plants will certainly have died. I can no longer breathe in here. Can I breathe in here right now?
Pressure critical.
Nope.
Oxygen critical.
Way too low. So you have to cool the station. How do you do that? Well, spoiler alert. Here, let's take this pipe network as an example, and let's look at all these values. I like this. Let's ignore the gases. Oh, there's some pollutant in here. Yeah, I guess I welded something. That's probably the reason. Okay. You can see the pressure. You can see the temperature, and it keeps rising. There's no liquid in that pipe network. And you see convected nothing, or I guess the pressure in here is too low for convection, but is radiating. What does this mean? It is radiating away its thermal energy, its heat, very weakly. And it's doing that, it's radiating that away into space, since this is on the wall. So I could basically have a pipe filled with some gas, for example, by just adding an opening to the pipe so there's the station atmosphere in the pipe. And if I put this pipe in the wall, then it will take in some thermal energy by convection, by touching the atmosphere of the station. Currently the pressure is too low, that's why there's no convection, into itself, and it will radiate that away into space. So that's one way to cool your station. What I normally use is I have the pipe outside the station, and I will pump gas off the station through it, which will then of course cool the station a little bit. But you can amplify the radiation that this thing receives or gives off, or the convection that the convection exchange of this pipe, with two different kinds of radiators that you can put onto the pipe. For those though, you need steel, and we don't have that yet. So my station cooling usually on the moon consists of a pipe with some radiators, and I will just pump some gas into them. And when the cooling is done, I will just evacuate them again so they are ineffective, and then the station will be idle and will heat up very slowly again. And I control that with IC10 logic, usually. But I can also use that manually. I mean, if my suit would warn me that it's getting too hot in here, for example, then I could say, okay, just turn this thing on for a while, now it's cool enough, turn it off again. So that kind of fun you can have in here. You can play with actual gases, with actual liquids, with an actual survival environment. Supposedly later there will even be surgery, though I don't know if that is still on the current long-term roster of plans. But that was on the list because, for example, currently we have a brain organ and we have a lung organ. The lung organ can even be damaged. And the brain is being used for to determine whether there's currently a player or whether the multiplayer avatar is currently doesn't have a soul right now. Anyway, the lungs can get damaged, And you can heal yourself by eating this pill here, of which you have only one, and it heals you completely. It's just a cheap solution. But you can also have a device that heals you. You have to build that first. You can also create those pills with a certain device and certain ingredients. If your lungs are damaged, then they will take in less oxygen, and that might lead to suffocation. But if you increase your environmental pressure and the purity of the oxygen, or the purity of the oxygen that you could potentially breathe, then you might actually escape that threshold problem. But if the lungs are even more damaged, then you might not be able to do that, and then you will suffocate and die. The lungs will, I believe, heal over time. And how do the lungs get damaged? If the gas that you breathe is toxic, or if the gas that you breathe is colder than 0 degrees, which is a bit hilarious because, I mean, in Siberia we have sometimes minus 80 degrees Celsius, truly, on Earth. Yep, it's like on a different planet, man. Though that's a record temperature, it's normally not that cold. 50 degrees or hotter damages your lungs too, which is also hilarious because we can easily breathe 40 degrees and 50 degrees is not that much hotter, right? Anyway, okay, that's the way the rules are set up, and the further outside that range you are, the more damaging it will be. Okay, before I start with the sensors, let's complete the console. Here we have the Airlock board. You might think, hey, can we put the board in here? No, you cannot. It's a different kind of board. That is the cartridge, and that's a motherboard for a console. And you cannot put this thing here either. So there's the airlock, and we have also the advanced airlock, and there's some gas sensor motherboard, and there's a graph display where we have a 2D graph here with a curve that you can program somewhat to show temperature change and such. Yeah. Okay, this thing is not yet complete. Obviously we need some glass. A tool would have told you that if you would have pointed it at this thing. Okay. Cycle to interior, but it is blinking. Why? Console currently flashing an error. Because it's not yet configured. Configured? Yes, we need to configure it, and for that we need the data disk, which doesn't hold any data, it's just a key. And you will notice that there are some data disk slots in some other devices, the computer for example. They're completely without function, except you can check them with logic. So if I want to switch this thing and check how it is switched, I could add and remove the disk in addition to have another kind of data bit that I can check. And well, I can store the disk up here when I no longer need it. There's the disk slot on the bottom here. You cannot see that, but there's this lenient little thing, this hitbox. Aha! So now we have these things here, and we will also have other entries. If there would be other devices, I could, for example, connect the 3D printer to this cable network, which we don't. We keep this pure only for the airlock. And then that would be here too, but it cannot be selected. It's not an airlock device. This though is definitely an airlock device. Now it is selected. Then we have the glass door and the airlock door, which, you know, the composite door here that I called airlock. That's why it's written here. And both are saying exterior. What does that mean? It means that, once again, the button will tell you what happens when you click it. Filter is now turned off. Air is now turned off. Air conditioning is now turned off. Now let's turn them on. In the same way, oh yeah, you can drag these around and reset them. In the same way, you can you select here which door will become the exterior door. Now this one is red, it's locked. It's currently disabled. Because this thing now has a control. The other one you can see now will become the interior door. In case you don't know which is which, maybe you have two glass doors, you haven't renamed them yet, you can just look at which door is turning red. And then you can see, ah yeah, that's the exterior. No, that's not exterior, that is the exterior door. That's important for the airlock logic, man. Now we're done. I cannot select anymore, but it's still showing an error. Is it because there's a disk in there? No. The reason is different. The reason is that we also need a gas sensor. Because the gas sensor will tell the airlock whether it's empty. And that's indeed how this thing works. It uses the normal logic values that you'd also use yourself if you program something. Let's look at the various sensors that we have. Here is the daylight sensor, which you should normally put on the ground. It functions still in this way, I believe. For example, to detect whether there's light in this world box here, or what angle the sun has, but the angle of the sun will be inverted here, and that is often not desired. You can see the horizontal and vertical angle of the sun, which is important for your
Hunger caution.
solar panel programming. Then we have the motion sensor, which detects whether someone is in that world box where you're in. So in the airlock, or in this part of the room, or in this part of the room, you know? I mean, now this thing would not detect me because I'm in a different part of the room. And then we have the occupancy sensor, which is the same as the motion sensor in the context here of the airlock, because it only has one box. But here it's different, because it detects whether someone's in the room. How do rooms function? Well, it's pretty easy. Once you have walled everything up, the wall doesn't even have to be closed, the game knows what you mean. And so now this is room 9, whatever the number means, it's just some internal value that's assigned, and this one is room 8. Just like the pipe networks also get some arbitrary number. Okay, we have the motion sensor, the daylight sensor, the proximity. Okay, we had the motion sensor, the daylight sensor, the occupancy sensor, and now we have the proximity sensor, which you can set with a little dial or with logic programming to a distance, and once you're closer than that distance, it would say activate. So you can use that, for example, to turn on the computer when you're nearby, so that it doesn't waste its 200 watts of power every second, or every half second even. Well, and then finally there's the gas sensor. Let's connect that here. And shut that woman up. That came out wrong, right? Because I first wanted to say shut her up, then I, in my head, pivoted to shut the girl up. Then I thought, well, girl is inappropriate. She is more like an adult, she's more like a woman. So I said woman, and this sounded like I'm misogynist. So yeah, it's in the eye of the beholder. Not in me. Okay, now we have everything set up, and we can cycle the airlock. It pumped the airlock empty and detected that it's empty. That was rather quick because there's so little atmosphere here. And now we're on the outside. We have a functional airlock now. However, when I want to go back inside by clicking on the door or clicking on this thing, doesn't matter, you will observe that there's a problem. It doesn't let us through. Why? Is this thing buggy? No, it's not. It just has a default setting. This is the simplest airlock chip for which you cannot configure that setting. The advanced one, which allows us to separate two atmospheres, so we'll have the other active vent here, and then we'll just place the passive vent that you can see there right next to it, adjacent to it, from the outside, so it points to the outside, because that thing counts as a pipe. You have already seen that because it's part of the same pipe network. You can place it directly adjacent. Then you can see that also with the yellow color. If it's yellow, you know it can be placed there. Then I would pump the gas to the outside when I come in. Anyway, that is what this advanced airlock chip allows, and it can also be configured. And what it's doing right here, it's trying to achieve its default repressurization value of 100 kilopascals. Which, I mean, this would take eons. I don't know if there's even enough gas in here to fill this 8,000 liter box to 100 kilopascals, 101. I don't know that. That's pretty annoying, particularly since if you turn this thing off, the airlock still works. Still works fine. But this now saves you 50 watts. That's significant. Not to us, because I'm still cheating my daylight situation here. You know, so that we see more, so that it's less annoying, so that we don't have tunnel vision the whole time when I'm using the flashlight, which by the way is a slightly cyan hue instead of the nice white-ish color of the sun. Yeah, so, but you normally would like to save that power, but this means that if I want to cycle the airlock now, I cannot click this button. So then you can turn this off for on for a short moment, abort the cycling, turn it off again. So very inconvenient. We want the advanced airlock chip, right? Okay, now that we have a closed up station, which I realize I don't want yet. Or do I? 21 degrees, man. It's okay. Let's just continue. I would like to be able to print some stuff, to build some stuff. In other words, let's finally go and set up the 3D printer, which we find in the construction supplies crate. Okay, how do I place these? This can only be placed in the horizontal rotation, and it has to be placed on a frame, or within a frame is even possible. And some people stack them, so I could place one here in the air by placing an empty frame that is not yet welded. So one would be here, and then when there's the frame around it, I can place it in the air above it, which is cheating, but I mean, it's within, you know, the game is so complex. It is not like, oh, since I cheated it like this, I now have more space in my station. Haha, I beat the game. Haha. It's not so significant. I mean, you just make the station 3 blocks bigger, which is completely arbitrary, basically, once you have enough resources. And then that will not be a significant cheat at all. But stacking them like these will give you a different design choice, with different experience of playing this. And it's completely legitimate, really. It's not... it doesn't take away from the game at all. It is not actual cheating. What is actual cheating is how I do something like this. I just reached through the glass. That is cheating. I would have to go outside, really. Anyway, so let's place this with some room. I want to be able to stand conveniently in front of it. And it needs to be able to spit out its products so that they don't fall outside the station. This is what would happen here. They would not be squished between the wall and the thing. It would just be teleported outside. And this is a bit close. Let's do this. And now, for the more tedious part, I have to build this thing up, which is a bit complex if you're doing it for the first time. But at some point you will have some routine and then see that's how fast you can do this very easy. And you don't have to build them often, you know. Oh, how warm is it? 63 degrees from that little bit of welding. That is because there's so little atmosphere in here that the thermal energy that I just added to that little bit of atmosphere means that we have a lot of heat here. See, that's what I was talking about when I was referring to the fusion power plant that we're building.
Power low.
Oh. Oh, do you hear that? It's a very faint sound. There's not enough atmosphere here. You will hear a high tweeting sound if this thing is, well, charging its battery. And you will hear a lower tweeting sound if it is discharging its battery. For example, if it would be night, the battery is still full, the airlock still works fine, but it would be discharging the battery. Okay, now this thing is on, consumes power. And currently there's some kind of power struggle, haha, going on between the solar panel giving us electricity and this thing consuming electricity with its base power. So we click here to select from the recipe list. And what I would want to print is, for example, some iron sheets, because these, I have used all of them up. I have none left. But I cannot do that. I need iron for that. Oh, I have iron. Here. But that doesn't work. It doesn't swallow it. Because what you have to put in there is ingots. So we have to make them. So we need the arc furnace, which I will not place on the indoors, because that would be insane. Because it excretes a lot of toxic gases. We don't want that indoors. I could have placed it closer to the wall, so I could toss things in directly, that's the inlet, through the wall, but I don't want to cheat if possible. So, yeah. Oh, what about the cable? I will be indoors soon enough. That is still fine. That is already cheating. But it has two connectors, power and data. This thing is very important when it comes to programming, because you can check whether there's something in the input slot and then automatically turn it on. Yes, these things can even be programmed while they are powered off. That's pretty cool. In Stationeers, you can just say top powered on with the logic of the device, even though you'd think it needs some kind of hidden chip in there that needs to be powered so that it can digest your programming. That's not how this works. So that's gamified a bit. So, and this is the activate button, and you can have both automatically happen. And then if you would have some input stack here, some chutes, you know, you can also pipe materials through some kind of little boxes here with input and outputs and so forth. Then you would have a stack of stuff that would go in there, and a long stack where it comes out again is being tossed into your station. That's something you can do. And so it's pretty cool. You can just toss things from your station into that opening, and it will take care of the rest when it's programmed. So that's why you would want to cable this up too. Not right now necessarily, I will do this though. And here you can see this cable cannot be placed here, because the tooltip says is blocked by the glass door. Here though, I can place it next to the composite door, like I said before. Oh man, I can even cheat it like this. Okay, let's do that. To see what that's like. Oh. Okay, not quite. Like I said, I could also have used the airlock manually without the console shenanigans. Oh, and you should turn that off. Consumes power. Currently not relevant, but in principle, you know. And there's another cable coil, good thing, because I don't yet have everything set up so that I could print cables. You print cables and batteries and stuff like that with the electronics printer, but the most basic things you need, like pipes and cables and even light sources, you can print even with this guy. So you have two printers with which you can print that stuff. And let's see, can I print batteries with this? Battery? No. Pipe? Yep, but not the liquid pipes, only the gas pipes. Cables. Yeah, but only the simple ones, not the heavy ones. And this one prints also much more slowly. Because, I mean, for those things, it's not specific to that. The other things, it prints fast. Alright, that's, ha 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 hee. See, that's the cheating thing you should try to avoid. Now it's excreting gases. Which gases is it excreting? These gases. A little bit of CO2, lots of pollutant. Pollutant you don't want, CO2 you would like. So yeah, I could use that inside the station, but it also produces some heat, I believe. And, well, definitely the pollutant would have to be pumped away. I don't have that equipment yet. I mean, the portable scrubber can only do so much, and I don't want to be constantly coughing while I'm using this, so yeah. I think we should go mining, because we need some more materials. We can see how far it is. Oh, it's done. And the moon has low gravity, so yeah. By the way, notice I jump. Or let's just toss this. See, the gravity is always norm Earth gravity, or whatever the game thinks it is, once you're inside a room, even if you're playing in outer space, where there's absolutely no gravity in this game. But on the outside you have the respective world gravity. That's a hack, obviously, that the developers use to, you know, for game flow purposes. Okay, what do we need? Let's mine some silicon, which is important to make anything plastic related, like glass or some devices that need that. It's one of the most fundamental things that you mine, like copper, iron, gold, and well, oxide and volatiles is not something you normally mine so much. Those are rather for exceptional situations, I think. At the beginning, when you want to put some gas into your lunar station. Of course, I could have... maybe you have noticed the tank that we landed with, where I topped up my spacesuit's oxygen canister, had a little wheel on top of it. With that, I can set the target pressure of the surrounding environment. So if I use that in a room that has 100 kilopascals pressure and turn it up to 90, nothing will happen. If I turn it up to 110, the room will fill up to 110 and then it will stop. Except, of course, if the tank doesn't even have that amount of gas. But I'm not using that to fill up my station because the gas in that thing is pure. It's pure oxygen. I already explained the problem of impure gases in your spacesuit. So, oh, that's water. That's cool. We'll need that at some point. And this one is not pure water. You have, I mean, if you go and freeze, oh, it's already more. If you freeze some, if you freeze gases yourself instead of finding them as ore here, which is what this is basically, then you will get pure ice. That will have nothing but that gas inside of it. But these ore type of things, which are melted 0 degrees, as opposed to, I mean, if you want to freeze gases, depending on phase change diagram, they would have to go much colder. These ores, they have mixtures. The oxide has 90% oxygen, the thing that I want, and a little bit of nitrogen, which I'm friends with, no problem. Some of my plants even need that, so that's a good thing to have then. You can see there's always some more of that same stuff around, normally, in most cases. And this means that maybe you want the stuff on the surface that got you to going there and digging, leave that. First dig around it. But currently I would just dig out everything, so that's not necessary or not meaningful. Also, it's not like oh, you have to, you know, the resources are scarce, you know. That's not how it is, really. In other words, I believe this here to express myself. Then we have coal, also very important. I forgot that, yeah. Because I think we even land with that. I think we even have that already. It is the solid fuel generator. It outputs indeed 20 kilowatts of power. Let's do this first, because it is very fast. The copper takes longer. So I can swap that in. I don't know what I wanted to say. Anyway, 20 kilowatts of power, which is too much for the weak cables, but it doesn't matter as long as you don't actually consume that. Well, any type of battery that you build here, I mean, okay, there are two types of batteries. The big station battery you already saw is not in fact the big one. There's a bigger one that takes the entire vertical space of a box, but I think it's not really worth the materials that you have to put in, because they are advanced materials that are tricky to make. And I mean, this thing has barely double, I mean, it has double, a bit more than double the amount of power that a small station battery has. So if you take two small station batteries and stack them, for which you would have the frame trick that I already explained, because they have to build on frames. That was not so a few months ago, but now that is so. You can no longer stack them without the trick. If you would stack them, then you would have basically the same volume used in your station, but it would only be slightly less than the large station battery can hold in power. But you would also have much cheaper materials. So that is badly balanced in my opinion. In my opinion, the large station battery should have more than 3 times, a bit more than 3 times the storage capacity than one small station battery has, because of its costs and because of its volume. but sadly that's not the case. The game as it is not set in stone. See, the developer team did not set out with a plan that they are still following. They are, I mean, you can tell that this game is very complex. This means that, I mean, if you have programmed something in your life, you will know that the problem of complexity is a significant one. Even small things can easily build up to a very complex scenario. And I mean, this game, particularly to implement it, not just to play it, that is super complex. And so the developers certainly encountered scenarios that they didn't expect, that they felt the experience of the game different from what they had originally planned. I mean, it's a very dynamic process to build this, and so they are basically living from moment to moment, you could say. It has a stable trajectory, yes, but that is only because the game already has a stable overall form. But if they feel that when, I mean, see, they are now implementing the new terrain system fervently. They're really on it, and we can play that already on the beta channel, but in a limited fashion. Some things are not yet implemented, some things are still ugly. We cannot yet make our own planets, but soon we will be able to with the tools that are being made available to us and so forth. Yeah, they built this whole thing with modding in mind from the ground up. Like they're already also currently building a Kerbal space program, basically. It's called Kitten Space Agency, but they are building it proper. They have made their own engine to make that happen. Instead of tapping into Unity, which even in an empty scene can drop down from 2000 frames to like 80 frames, even though there's nothing there yet, because it's such a shitty engine.
Waste tank caution.
And yes, it is shitty. I mean, I trust the judgment of the developers of Stationeers when they say that it is a shitty engine. I mean, it's great to start a game, but it's not great if you want to finish it, for example. And they say Unreal is a great engine if you want to finish your game, but if you don't want it to be, I don't know, spread or well-known, but maybe that was hyperbolic. But still, what they're saying about the Unity engine, that is what they're really convinced of. It's a shitty engine. They're also not updating to a newer version of the engine because of, you know, so that's not the engine of choice. Anyway, for Kerbal Space Program 2, which was a game, or is still even being sold on Steam, even though it's not yet done and will not be developed further, that's basically a scam, which is significant, you know, and Steam is participating in that. They're not shutting that down. It's interesting. See, gold takes a much longer time to melt. And we get some oxygen and some pollutant, because that's what this stuff excretes. Well, so for that Kit Space Agent, okay, Kerbal Space Program 2 is not will not be finished, but that a game like that should exist. The popularity of Kerbal Space Program 1 shows that particularly. And Rocketworks is currently making that, and there's even a developer from the original Kerbal Space Program on it, and there's an SpaceX employee. I mean, some people have some unreasonably idiotic attitude against Musk because he's associated with Trump, because they have an unreasonable idiotic attitude against Trump because they're listening to the legacy media. And you might think that I'm just pooping out some kind of party line thing, but that's exactly the thing that, well, I'm not saying you, but most guys are doing when it comes to Trump and Musk. Their opinion is not founded. What they are saying is bullshit most of the time. And by now it is a religion, because the news media, they have to follow. I mean, what if they would suddenly turn by 180 degrees? Can they do such a thing? You might just say, well, there's no reason to do that in this case. Okay, maybe, but could they? That's the question. Could they, given their advertisement customers, given their readership? Can they? See, the classic news media are not a good source for news. If I want to say something because I feel like it, I will try to go out and say it. because I feel motivated to do so. The news media, they have to run 24/7. That's their business. So they have to say things to you. When I say something to you, I say it because I feel like it. When they say it to you, they say it because they need to say something. See what I'm getting to? The truth value doesn't matter so much. The conviction, what conviction? When I'm telling you something, I believe it's true. I'm convinced of it. I believe it's important. And see, when they talk about Musk, for example, they're saying, this morning, I shit you not, I have some AI apps on my mobile phone, and one of them is Perplexity. I don't know if it's good. I installed it only because I can talk to this thing and will talk back. But I realized I can also do that with ChatGPT, so I'm using that these days for that. But when I use an AI to interact with, I basically only use the one of Elon Musk, which is Grok, because it's the best. It's the best free available that you can find. And, well, even better is Google's Gemini 2.5 Pro, which is also free, but will only give you a few prompts before it shuts down. Grok is much more lenient in this regard, even though they are blasting lots of power and money into it for your free use of it, you know. I have dabbled with these things enough to be able to have that opinion. I've also used ChatGPT and DeepSeek and so forth, and I'm also using them professionally. And I'm not using just one professional, I'm using multiple, but I mostly use Grok, because I'm too convinced enough of it and I have lots of experience with it. Anyway, this is not me being a Musk fanboy. I'm trying to express that if you have an anti-Musk opinion, you must realize a few things. This morning, for example, a news item was popping up from Perplexity, and I have since turned that feature off, even though before I even learned that the Pope died on the day that he died. Because of that, I would have learned that by other means, but there was a reason for me to not turn it off. But now I have turned it off because this morning it was pumping some completely fake news to me. It was telling me that the board of Tesla is considering removing Musk as the lead because of his involvement in the Trump administration and because of the stock price of Tesla having fallen. But that turned out to be fake news. It was just flat out a lie. The sources quoted by that very article, I checked one of them, which was Yahoo News, was stating the exact opposite. They were saying, no, that is not the case. Someone was saying that maybe, but it's not true. That was used as a source for that even. Hilarious. Anyway, people will tell you that Tesla is a bad car. Why then is the Model Y of Tesla, the Model Y, the one most sold car in the world? Not the most electric car sold in the world, but the most sold car, period. It doesn't have the greatest spread, but when it comes to rate of sale, you know. During the first months of this year, Tesla's multiple factories in multiple nations, all of them changed their production line. And it's not like they built just some other factory or some other hall like they can do here and some other manufacturing facilities, but they use the ones they already have. And so they changed the ones for the Model Y because they bring a new version of that. But during that time, they couldn't really use them for production, could they? That is why sales dropped, also because people are anticipating the new model. This means that people would now hold back from buying since they know the new model is coming out. So that's why the sales are dropping currently. But Tesla is the only company in the world has actual functional autonomous driving. From what I've heard, from what I've seen. For example, them driving supervised but without interference in Amsterdam, which is a very complex territory to drive. They will now launch autonomous robotaxis in Austin in June. I can talk a long time about AI and robotics as they're coming in the future, not just from Tesla and Musk and such, but autonomous driving will be so important in the future because a car that you may manufacture once can be driven by you for an hour or two a day. But once it's autonomous, it can drive for 20 or 24 hours a day. It just has to swap out its battery. I mean, why charge a battery if you can just swap that while the other battery is charging? Right? And this means, plain simply, by us as a people, mankind globally, worldwide, as a civilization, having to build cars to have them, the amount of energy and power involved in making them, and the change that I just described, the amount of hours that you can use a car per day, will ultimately, inevitably, change the overall global personal transportation landscape towards autonomous because of that extreme energetic relationship, because of how little you have to put in for the kilometers that you can drive the car a day. That's what would change, and so that's why robo-taxis are a big fucking deal, man. And, well, then they are saying Musk is an asshole for doing all these cuts in the United States government. He's not even cutting, he's only finding out where things can be cut, and the decisions then are being made by Trump and by Congress. And many of the things, billions, hundreds of billions, that they have found out where they can save money, they haven't actually done yet, because Congress still has to decide on that. So I don't know what all the fuss is about. But what you hear is what the legacy media, who hate Trump for whatever reason, and what the majority of the people who hate Trump for whatever stupid fucking reason, have just decided to tout the whole time. That is why you are in this matrix that has been pulled over your eyes to blind you from the truth. If you're not willing to also consider alternative media and to open your mind to the possibility that the entire world is insane, if you look at a boundless mass migration, which we all must agree, yeah, fine, but it has to be limited. It has to be controlled. If it's boundless, that's insanity. That destroys a nation. You can see that in Germany, you can see that in France, you can see that in the United Kingdom, you can see that in the United States, where they're now thankfully turning around, which they wouldn't have if they would have elected that obvious political liar, Kamala Harris, who said, I will do this and this once I'm in power, while she was in office. And, you know, all of that, I mean, can talk for hours on this, the policies that she touted and so forth. She would have even ramped up that mass migration thing, which was indeed destroying the United States. Because a nation has only a finite amount of resources. That's completely insane, man. I mean, I'm not saying Trump is the golden choice, but they had two choices to make. And Kamala would have destroyed the nation. They had to elect Trump. But interestingly, the majority of Americans is still standing behind Trump. So, okay, that's that then. Well, and see, I'm thankful for what he's doing with the trade tariffs, because that pulled down the entire stock market artificially. Stocks that are actually have a higher value would now drop. And during COVID, there was the same thing. So during COVID, I bought airlines, and now I bought Tesla and artificial intelligence and robotics stuff, because that stuff will skyrocket anyway in the near future, regardless of this market drop. So once the market returns to its normal level, which it will, once it does that, I will have a bunch of money more. I already have like 200, but I will stay in until I have like 1,000 or so, and then we'll get out. Just like that. I'm just like, because that's how these things work. And, okay, but I'm very off topic here. I don't know how it got to AI and Musk and all of that, so let's return just to topic. Yeah. Anyway, I hate that people are being lied to on a large scale. Okay, and this morning it was even telling me this lie about Musk, and they're lying about Tesla this whole time. I mean, I saw a video that was quoted by a channel who was pointing that out. In January, the channel was showing that a Tesla car, and the door handles was opening and closing them easily. And then 4 months later, that same guy was making a video about the Tesla cars and was pretending as if he couldn't really use the handles because they're like so complex. You have to first like push so that they come out and so forth. That was a complete lie, and that is all over the place. I mean, if I put out, in what I'm currently saying to you is unpopular, and you might dislike this video, and you might dislike me for saying these things. But isn't it possibly a fact that you're only believing this because you're living in a big, large bubble that is only blowing up to that size because people are preferring to tell you the things that you want to hear? isn't that what I'm saying to you then now? Rather useful than destructive? I'm showing you a different perspective, one that I happen to know is true. So in other words, not only am I helping you develop your skepticism skills, which you should, but also I'm telling you the truth. Anyway, let's continue here. Now we have gold and iron and copper, plenty of resources. All right, I have to do this thing. Let's toss that in. And while we're at it, also some of the gold, all of the gold actually, and some of the copper. And then I will produce, let's say, some iron sheets, so you can see what that's like. And you can see it takes 1 iron. There are some items that only take like 0.5 iron or 0.5 steel, for example. And if you flip this lever here, this tosses out all the materials that you have. But this is 41 grams. It will not be 41.5 grams. So I'm saying if you have an 0.5 production kind of situation going on, I mean, who cares about 0.5 really? But if you don't want to waste that, and that's the only way that can ever accidentally waste something other than overproducing, then you might want to produce enough so that you're rounded again. Like produce 1 extra. Okay. Yeah, I was talking about Kerbal Space Program. They are making their own engine, which has the camera always at floating point location 0, so that we don't have the problem of planets far away from the 0 point of the solar system jumping around due to floating point properties. Let me print the electronics printer. And then I will select a different recipe, so that I don't get like 5 electronics printers. Now it will just print this and then it will stop. It will not just print the other recipe afterwards. And they have everything is seamless. You can fly from the planet's surface to outer space through the atmosphere with clouds and so forth, all seamlessly, and then to the next planet, all in realistic space. I mean, it's awesome. So that will be the new Kerbal Space Program, made by Rocketworks, which are aptly named, aren't they? Their flagship product, by the way, is Icarus, which is kind of a game like this one, kind of, roughly, but it's more like a survival crafting game. I have that too, but I haven't played it really yet. I'm a fanboy, you know, or a super fan rather, not a fanboy. I'm critical of them too, but a super fan as in, if they have a new product, I will probably buy it because I love this company and I want to finance them, and their shit's good, you know. Okay, so we have this printer, and it's actually like all electronic devices, it will heat up the room. We had 70 degrees already. This should normally lead to my waste tank being filled faster because my spacesuit needs to be cooled, but the thermal energy bleeding into my suit is probably very weak because the overall amount of energy, not the temperature but the energy in the air around me, is very low, and so that doesn't have much of an effect. But we have to consider to find a cooling solution, and I have an idea. 0 degrees, remember? That cools down the station quite a lot. Also, it fills up the pressure. 20 kilopascals, 90% oxygen. Okay, I think we can open the... Oh no, that was near this thing here. Where it's melting, the pressure is higher than further away. So I need more of that stuff. Oh! Okay, so very basically we can already breathe here. On the moon. Nice! Lighting is a bit off-putting, huh? They don't have any kind of global illumination, and they're not going to put that in for calculation purposes, sadly. In my opinion, they could use some kind of Minecraft cheat approach to find out box-wise what the brightness is, fade over, but not show you that brightness, instead use that as the ambient brightness level for this, for example. But, okay. Electronics printer. Do I have iron sheets? I do. Whoops.
Temperature critical. Temperature high.
Have you seen that? My lungs were just damaged. That's why my body showed up to show me where I am damaged, and then my health showed up. So the heat was so high from the welding that this actually damaged my lungs. But yeah, then it vanished again because the lungs, they heal over time, and the damage was very low, so they healed instantly. See, building them is always the same. I love the original tutorials. Yeah. Too bad they don't have those anymore. They couldn't keep up with the constant changes, so they changed their entire tutorial approach to this new concept, but that is also currently at least not keeping up because they're currently completely occupied with making the new terrain system. Yeah, and I wanted to say something about the game evolving from moment to moment, basically. Once they have the new terrain system, you will have, from the get-go, that's already implemented, you will have different regions. Here you might have more iron, over there you might have more gold, or a lot of gold, and here you might have none, or whatever. And you might also have geysers. They are not yet implemented, but they might come, that excrete gases. And you might also have broken stations with some equipment in it that is broken, or some of it might not be broken. That is something that exists already in the game but cannot be played currently because it was removed again from the actual worlds, because the calculation budget could not be planned for the infinite world, so that was taking too much calculation processing power. But the new worlds, they will be finite, and they will not be procedural like these ones. Many people are objecting to that, but I think what the developers are doing there will actually work out in the end. So yeah, that's the solid fuel generator for the coal. I will use that soon. Now I have at least one more manufactory to build, the atmospheric sprinter, which is the pipe bender. There we have the hydraulic pipe bender, yep. Only one, please. With that you print, for example, pipes and the active vent, stuff like that, atmospheric stuff. And then the fourth printer, so the first one, the Autolathe, you have right from the start here in your construction supplies box, which, by the way, is empty enough for me now to just remove it. Same maybe for the Airlock supplies. See, now we have two of these things. And the second one would be the atmospheric sprinter or the electronic sprinter, depending on what you want to do next. The third one you would print is the tool manufactory. I mean the fourth one, tool manufactory, which allows you to make the hand drill or the crowbar if it gets lost. Or to make more advanced things. You can, for example, make a pneumatic mining drill, which, by the way, you have here in the survival supplies, I think. Yep, that one is gas-driven and will be slower the less gas is in there, but will be much faster than the basic mining drill when the pressure is relatively high. And there's a heavy mining drill, for example, which is the fastest mining drill that runs through this landscape like through butter. Oh, by the way, and here in the survival supplies we also have mining charts. Those are explosives. I should basically get those out now, so we can take a look at those. And I should save again. There's a hydraulic mining drill, which still doesn't have the clickety-click sound when turning it on. Here we have white flares, and you can spray paint them for pink or whatever, or red, like the ones we already have. Just like you can also spray paint the electric lighting that you can put up so that you have red light or green light or whatever. And also there's an LED light type, much like the wall lights you can put up, that will whose color you can program. You can see we have 40 degrees, 40.4, and over here yes, now it's heating up. It was outside the station, I think. The entire station is being heated by this. Something I don't want, so let me just sheet that a bit. The light rendering is pretty beautiful, apart from the global illumination problem. If you see someone else walking around here with a flashlight, you will see a volumetric, foggy cone of light in front of them, shining across this with some God ray effect, and so it looks pretty cool. So that's that printer. Maybe I should also make the tool manufactory while I'm at it. For that we need more iron, which we do have.
Temperature high.
Oh, it's already 50 degrees in here. Whoa. Not good. Damages the lungs. So with cabling you have to take care. If I cable this up now to this, the cable network will be recalculated. This may or may not affect this device here that is currently printing, so the printing process, which is currently at 43%, would be aborted. This is pretty lame, and the power network systems will be revisited at some point. Yeah, what was I saying? The landscape system will give you reason to travel. And at some point, you have seen that the store page and possibly in the loading screens in your instance of Stationeers, there is some vehicles that you can drive that can transport stuff, that also have some filters here for the inner atmosphere and such. Oh, one of my filters is gone already. But they're removed again because they're not playing well with this terrain. So once the new terrain is there, they might be reintroduced. Well, reason to travel, and there will be high cliffs that you cannot even fly past, I believe. And maybe there will also be hardened rock, I hope, that you cannot dig through. I hope they will introduce that, otherwise that would be pretty bullshit, because, I mean, everything being completely malleable, no matter what drill you're using, they should rather use the approach that Astroneer is using, where some stone can just not be dug with your basic drill, where you need better drills for that, I think. Anyway, so that terrain system is coming. And when that is there, I believe the fact that we will then have reason to travel will give people a reason to, well, to build little outpost stations. And this in turn will give the developers the
hydration critical.
The inspiration, basically. They will be steered in the development slightly in the direction of giving you reasons to build outposts, because that is then suddenly a thing that people would do anyway. So that would then be amplified a bit, but also then you would have some kind of mission situation. And since, I mean, they want to do some kind of mission thing anyway, where you would, for example, have to build some kind of hotel-like scenario where you have guests that will have certain needs. That is something that is already in the game slightly, because some of the traders need their own atmosphere. So you have to build large hangars with these large vent things which cover the entire wall, to give them the atmosphere that they need. So that is kind of in the game slightly already. So now let's print the furnace, so that we can make steel. And then I should go out and mine some stuff, so that we can make that steel. Need to drink something again. Okay, so this thing has a slot where you toss in the coal. You can see that here on the right, where the arrow is. And it has the power outlet, which is there. Will I put this right here? Or maybe here? No, that's wrong, because I don't want to put the power into my station network. I want to put that into the network that is coming from the outside, my input network. That's tricky. Of course, I could plan an entirely different network. I couldn't just say, well, I will have the station battery at some point, and then I will just, you know, have heavy cables, and the station batteries, yeah, that's something I wanted to say, they take in electricity at infinite rate. So the load will be infinite. So if you put in 20 kilowatts of power, the load will be 20 kilowatts. In other words, the cable will burst, so you need the heavy cable. Okay, to fuel the furnace I will need some oxide, because instead of using the fuel gas that I have, instead of making some elaborate setup there with pipes and such, I will just toss in the gas directly, because the furnace thankfully has that kind of setup, has that kind of build. By the way, you don't have to put in fuel gas into the furnace to smelt gas, to smelt ore. What you have to put into the furnace is heat. So you could just put in some hot nitrogen, for example. But obviously for me now it's easiest to just toss in some oxide and some volatiles. Then click the ignite button, which will spark that, then it will burn. That itself will then produce more and more heat until everything has been burnt up. And this will then also smelt the materials in there. To make steel we need 2/3 iron and 1/3 coal, which we can look up here. Let's go back to the home page. We look at the ores. Now we look at the ingots. These are the advanced ingots, for which you need the advanced furnace. These are the ingots that we can make with the furnace I'm currently printing. And these are the ingots that we can already make with the arc furnace. The higher up furnaces can make all the lower up ingots. The lower ingots. So, ingot steel, what does it need? It needs the advanced furnace. What? No, that's not true. It's just not in a good... It's listed here automatically and not in a good way. These are the various recipes that you can use. One of them is the furnace, the one I'm currently printing, Tier 1. Or the advanced furnace Tier 1. Oh, they done goofed. And there's only the furnace and the advanced furnace. The advanced furnace is basically the furnace Tier 2, so to speak. I don't know why it's saying Tier 1 here. I'll take a screen here and bring that up in the forum. Which is meaningful. It's meaningful to interact with the developers on Discord. For example, this this thing here that we can teleport things between your hand by clicking right. They introduced that because I suggested it. That is, before that we only had drag and drop. And between me suggesting that and them implementing that, that was one day I could use it. That is not typical. I'm just saying that's what happened, you know. Anyway, so what do we need? We need the furnace at the temperature of 627 degrees Celsius or 900 Kelvin, which is the same thing except shifted. This Celsius has its 0 point at where water freezes on Earth sea level pressure, and 100 degrees where water boils at sea level pressure. You know that the pressure is different. That's different depending on the temperature. And Kelvin starts at absolute zero, where there's no molecular Brownian motion, where the materials become one superatom, one Bose-Einstein condensate at minus 273 degrees Celsius. But the step width between is the same. One more of these is one more of those. And that's the same in reality. So we need 900K or more. This is basically the phrasing or more expressed as a number. And we need 1 megapascal or more. So that is easily achieved. And then we need 3/4 iron. Did I say thirds before? I think so, right? We need 3/4 iron and 1/4 coal. So thirds, no, that was wrong. Sorry. Okay, we need more iron and we need coal. Where's the station? Over there. Well visible during the day. And thankfully it is still day during the night. That would not be so easy. Visibility is low during the night. I mean, if there's a light in the station, you will see that from far away, yeah, but, you know. So what systems do we have in Stationeers? We have the atmospheric systems in the room and in the pipes and containers. And we have the devices that can pump atmospheres, and we have also the phase change, which has to be considered. Things might become liquid in pipes, or might even freeze, that destroys any type of pipe. And we have devices that can remove liquids from pipes and move it over to the other type of pipe, or gases, vice versa. And we have the passive liquid inlet that will yeah, I think I have enough of that stuff. What's the direction? 260-ish degrees. That will let liquids that are on the ground or even in the air, well, that's on the ground, that in the air thing is over. Until they had actual in-world liquids about a year ago or so, if you would have liquid water, that would just express as foggy air. But that no longer exists. Of course, there's still potential for there to be steam. Of course. Anyway, so the passive liquid inlet lets that into a liquid pipe system. Then we have inline tanks, which are like pipes, except they just have a lot more volume, because volume of a pipe network also matters. How does it matter? You will figure that out over time. I don't want to tell you everything. Oh, look at that. A little cave. And down there we have one of the shortcomings of the old terrain system. There was a hole, but now it's filled. Is what she said. Anyway, so all kinds of devices to deal with atmospherics, with liquids. We have the filtration unit to pump in gas and to filter that then with up to 2 different filters. I can use the same filter in there, who cares? I need coal and iron. There was coal over here. Oh, iron. Nice.
Waste tank critical.
Yeah, that's very unfortunate. Let's go back to the station quickly, which I think I can afford. I mean, if I would be on Vulcan, that would be deadly, because my gas will be used to cool my suit. Currently, nothing can be pumped into the waste tank, so my suit would just keep heating up, because currently that's cannot be pumped away. So let's take a look at the waste tank. What's in there after all this time? We have 4 megapascals, 46 degrees. Now it's heating up because the station is hot. Lots of O2, lots of CO2, of course. Currently in the station we have basically no CO2. But if I open my tank here, click on it and open, now we have a lot more CO2, and that's what the plants like. They want at least 1%. So I'm indeed producing something here by breathing, by existing, for the plants to live off of.
Temperature high.
And now it's temperature high. Why? Because my AC is down. Let's just solve that. See, my in-suit temperature, now it's falling, because now it can pump away that hot gas.
Air tank critical.
Oops, that's not what I intended. Where's my gas? My air tank.
Air tank critical.
No, that should stay here because I have plants. Maybe I wanna charge the battery of my mining drill, which is almost empty. And for the time being, just use this battery. That I can smelt. What I toss into my furnace will be ore, but you can also toss smelted materials in it. That doesn't hurt. Actually, it can help. Because you can see here, there is gas in there. I showed you that in the Stationpedia also, that there's gas in the iron ore and in the other ores that you find here. And so, if you toss that thing in the furnace and smelt it, then that gas will also be in the furnace, and that will contribute to the materials that have to be heated, and it will also contribute to the pressure. I mean, some materials that you want to produce, some ingots, will have a certain range of minimum and maximum pressure that you have to achieve, and a minimum and maximum temperature, and a certain mixture of stuff, of course, that you have to put in there, iron, nickel, and so forth. So it matters. Sometimes you might actually want to toss materials in there that are already degassed, and that's something you can do. For example, by turning them into ingots with a furnace, arc furnace for example, or by using the centrifuge, which can be used also for other purposes primarily, but the centrifuge can also be used for degassing, which is a good thing, because it's what happens in reality too. Definitely need more materials here. I want to make one full batch of steel. Of course I could just take 3 individual iron ore items and 1 individual coal stack item and then make steel with it, but that would be completely wasteful. I don't want that. I don't need gold right now, but gold otherwise is needed, so...
Hydration critical.
Yeah, this is a long introduction, like I said, a detailed one. I have a bunch of these already on this channel. I even have a German channel, so yeah, you can go there if you speak German and don't understand a word of what I just said. And I also have some fast introductions, and I will, that's a plan, make eventually a very polished fast introduction for Stationeers. I'm also using DaVinci Resolve, the studio version even, which costs something, to make some very polished videos. I mean, I have a playlist up that is explicitly for the polished ones, so you can just focus on those if you're a connoisseur. And yeah, I mean, some of these videos I put a month, even more than a month of work into one video, even if it's only like 35 minutes long. So that's something. And I want to make a very polished moon introduction video, or Mars maybe, but not before the new terrain system is out, obviously. That would be a waste of my efforts. But I felt like doing another moon introduction, so yeah, here it is. Soon we have 3 full stacks of iron. Then I need to get the rest of my coal stack, and then we can make steel. And then we can make the station battery, because we already have the electronics printer. Nothing more here, huh? Okay. Never forget where your station is. If you lose it, the planet has infinite size. So you just keep walking and walking and walking, and you will not find it. There are some tricks, but I will not say those because I don't want to spoil the experience. Because these tricks are basically hacks, yeah. Not basically, they're actual hacks. I don't want to take the rest, I just want to make... Oh, I just want to make clear where it is. If I look from afar. Now I need some coal. During the day you can see that all nicely. And by the way, can you see the silver and the gold? Yes, you can. If we're flying like sideways, we're getting some glinter effect. Not with this stuff, but with the only stuff that glinters, which is gold or silver. I don't know what that is over there. Now let's zoom in, maybe we can discern that. I would even guess that it's silver, which we will need at some point. Hey, Since I'm seeing that already, maybe I should just fetch that. Station is in the direction of 220-ish degrees. Sorry. Yeah, you can see we also have hygiene. Oh, nickel! That's not too often that I meet that old... Hey, nickel, old buddy. Let's take that right away. That is important for upgrading the manufactories, I believe, because they have two levels, the basic level and the advanced one, which can print faster, also consumes more electricity, and can produce some things like, for example, the heavy mining drill. Or I believe the deep miner, there's an automatic mining facility thing that drills through the ground into the bedrock where I cannot even go, and will just keep delivering goods from there. Forever. Yeah, indeed, that's silver. Cool. Silver and gold together in the furnace makes Electrum. That's something that we need for the what's its face? For the IC10. Maybe I will actually go so far as to show you a bit of programming in this video. Yeah, that's enough. Can I take more with me? Can I use some tricks here? No, I'm full. So that's that. And I don't yet have enough coal. 220 should be... Yeah, there's the station. Yeah, okay. I need coal. Where's coal? Should be somewhere on the way, since it's rather common. And I think there was coal near the station anyway. The light consumes a lot of electricity, but the suit itself also consumes electricity. So if the battery is down, your life support is down. So in other words, if you find yourself stranded at night, where you cannot see your station, and you don't have the tracker with you, because you were lazy or stupid, which happens to the best of us, and then I would like to take more with me, but there's just no way. Should I toss the bottle? Yes, toss the fucking bottle. I will just toss the bottle. Because I also want some coal to burn in the solid fuel generator. Then you could actually decide to wait out the night, but you should just turn off your light, because it will just eat your battery. You can last for quite a long time without the light on. Until the fear starts setting in, and then you get the hallucinations effects. That was a different game. That's not its Stationeers. Yeah, these caves look interesting, but they're just holes in the ground. This is not yet the new terrain system where there could be actually something to be discovered down there, and there will indeed be. Because once the new terrain system is out, and everything will be created manually by the community and by the developers, except there will be some procedural generation. For example, there might be a region where you find a certain ore, but the actual ore will spawn dynamically, instead of instead of being placed bit by bit, or having been placed by the map author completely. And also the exact location where you spawn could be random. And these maps will have a size that will be within certain limits. What those limits are have not yet been told to us, but we were told that the standard size of the map may well be 8 by 8 kilometers, which is very big already. With that in mind, I mean, one of these boxes is 2 meters. 2 meters by 2 meters by 2 meters makes 8,000 liters of water in volume at Earth sea level pressure, yeah. So anyway, this is 2 meters. So for 8 kilometers, you need 4,000 of these boxes to have that entire thing filled. And, you know, that's indeed the maximum.
Power critical.
Maybe we should first, before I start with the furnacing, make the airlock more convenient. What do you think? Yeah, that stupid Minecraft pickaxe is something you could use, but I'm not gonna. So temperature in here is 70 degrees already. Not good if we have any plants, which we don't have. There's the furnace. For that I need some iron sheets. I don't have enough of these, I believe. Let's make some. I only have 1 iron in there, so that's not enough. The walls I no longer need. Oh, by the way, there is a locker in the survival supplies. You can also print that. There are various types of these. I will use the big one. You can see I have 2 in my hands, and the big one, is the only one that needs all 2 of them. Too bad you can build this thing in the wall. That's a bit annoying. Oh, I think we have printed enough here. So you can also have them stacked for you automatically. For that you need, guess what? A stacker. Which I could print now. The stacker can also be used to take an ingot and to split it into different sizes. Because this cannot be split. I can click here all I want. That doesn't do anything. But if I click here, then I can split 1 or half away. Okay, so we have our silver, which I want to merge with gold, that I currently don't have available, not at least in the amount that I would like. And we have some nickel. That's pretty cool. Let's put that here. Then I would like to print with the hydraulic pipe bender a second active vent. Oh, it's not yet powered. Right, I didn't connect these because I didn't want to risk the current print. That was ongoing. Active vent. Iron, gold, copper. Copper. And here I have to recycle some resources. Yeah, that can get annoying fast, but I mean, at some point you're gonna have so many resources that you will just not have that problem. Also, you can automate all of this. I can put some chutes on this thing. I can read them out with logic values. I can have some silos where that stuff is coming from. I can have sorters which check what is currently flowing through it, then pipe that out to the left and right side, stuff like that. I will leave this lever open because that expresses that this thing is empty. And the electronics printer. Now I make the advanced airlock. So, something about these airlocks, you should, it's not necessary, but you should unassign the things that you have assigned here. See, the extra vent was not showing up. Before you dismantle this airlock and put up the new one. Because otherwise the doors stay locked and it would be overall a slightly awkward experience. Okay, now we have the advanced airlock. I can change the external repressurization value, of course 0. When I'm going out to the moon, then it cannot pump in from the moon 101 kilopascals. There's nothing out there. But from the inside, I will also just set that to 0, so we will have an explosive decompression situation, which is also indeed moving some objects on the ground depending on pressure relationships, but sadly doesn't really throw me into the wall or anything like that. I wish that was so, because I mean I always resort to just use that in the end because it's so easy. So I think there should be some the simulation should push me to do that, I think. So glass door exterior, yep. Airlock interior, also a door. Then active vent, which one is which one? I don't know. This one is accessible and this one is, you can see the tooltip is now locked. But I was selecting the external one, so that was wrong. Exterior, interior, gas sensor done. Okay, the new advanced airlock has been configured. What's missing is the passive vent there. But that's not a problem. What do I have now? I have to drink something. Let's look at the survival supplies. There we have the water bottles. Not many, you might think. But it's easy to get more water, because I have water here. I mean, all I need is to screw that thing on a base plate, of which we even have some, I believe. Somewhere in the hydroponics supplies, I think. Yeah, here we have portables connector, which allows you to connect this thing, or this thing, even though they're gases, or this thing, even though that's water. And then the two pipe openings will be supplied, depending, you know, there's a liquid pipe opening and a gas pipe opening. But nothing will be let out, because these things too will be closed. And then I will have a water supply that can flow into these pipes. And then I can connect that to my water bottle filler, which I can put up on the wall, on the ground, whatever. And then I can have my water bottles refilled. Or I could print a water fountain where I can push the button and just drink from it directly. That's also possible. Now I will fetch a fresh bottle. So I'm always 100% supplied here. I will also put the coal here for later use prominently, visibly. For the coal burner and another cereal bar maybe. Yep. What? Where's the other cereal bar? 43. Huh? Oh, I thought I had dropped one. Oh! Wait, what? No, it's... I'm a bit, if not even more so, confused. Ignore. Okay, now let's print a passive vent. Which needs iron, which we don't have here. So, since I don't have extra iron right now, I will have to fetch this one again. Oh. And then we can complete the airlock, and we can start making the furnace. We can start setting up the furnace. We could basically set up the furnace right now. All I need is some iron sheets for that. But I want to first... I want to set it up correctly, in a way that is already long-term safe, not just right now for my smelting. So I'm looking for some pipes. There are my pipes. Okay. I will need those. And I want to use a pipe cowl. Pipe cowl is like a passive vent, except it has lesser volume. Which means, okay, I'm not going to explain everything in detail, but that's one difference. But most of all, it can just stick out in the air instead of having to be mounted on a surface. And that's very good for the chimney that I want to make now. Chimney, well, I need also a valve, which we should have here somewhere. Wasn't there one as part of the airlock supplies? No, there wasn't. Oh, then I have to print one, I guess. Let's print a valve. So, let's go into the explanation again of the kit. Well, there we have the classic valve. Or not the classic, this is the simple valve that I want to use now. It's just an open pipe that I can close. There we have the same thing again, except this one has only one direction. I can also turn this one off. There we have the, okay, let's say again, that's the valve gas, it's the one-way valve gas. And then we have the condensation valve. You can see on the left side we have a little drop, a big one, and on the right side not, which expresses, yeah, these are gas connectors, and this on the left side is a liquid pipe connector. So if we have a pipe on the right side where for whatever reason a gas is becoming liquid, then that would go through this valve, not all of it, it has a certain flow rate, to the liquid side. The expansion valve is the very same thing in the opposite direction. You can see the drop on the right side. And then we add the valve gas again. Okay, so let's complete the airlock. And then... and enjoy the airlock. I mean, I want to show you first. And then I set up the furnace. And then we use it to make steel. Oh, how convenient is this now? Okay. Where will we make the furnace? I want to make that in the place where I could also use its gases to in a filtration unit on the inside of the station. So let's just toss that stuff down here and that too, and get the furnace. You can see it's a pretty complex device, which has 3 pipe connectors, and on the left side an outlet where the ingots would come out, and on the right side an inlet where the raw materials would come in, or even the ices if you're choosing to, you know, to burn ices. You could also use one of the pipes to pipe in fuel gas and then ignite that, or just pipe in hot gas, because heat is ultimately the thing that you need. And since that thing bleeds thermal energy to the environment, I already explained that when it comes to my Europa stations and so forth earlier, this means this thing basically can also take in energy. In other words, if you have a hot world, or if you have a room in there that you keep very hot, you can use that also to smelt your stuff. So, short break. Oh crap, was this recording symbol in there this whole time? Man, that's a stupid accident. Well. Anyway, so I will have it so that it tosses its materials into the station, and the pipes on the right side, and into the stations. Of course, kind of a cheat if I do it like this. It tosses that through the wall, right? So I will instead have some chutes up there. That's too far away. crowbar. Oh. Yeah, this looks good. Okay, now we need the wrench and the sheets. And the welding torch and the sheets. And that's the furnace. Here we can see what's inside. Here we can see the pressure and temperature. This is the igniter. This is the lever that makes sure that everything comes out. And here we have the output pipe connector. Could also make that higher, but you know, it's not necessary here. The advanced furnace could use a higher chimney because sometimes the gases are coming out there with pressure. A real flamethrower, I mean, truly. Okay, so that thing was ready for use before I even added these pipes, but then I couldn't have emptied it at some point, which is not fatal, but also, you know, a bit stupid. Now we can make steel. Should we make steel now? What do you think? No, one thing's missing. I want to add a lot of... not a lot. Let's add two chutes, just to show the concept. And to not cheat here with the excretion of the ingot. Crap, man, I think the half of the video is now polluted with that stupid red recording thing. I don't know, I have no way for me, there's no way for me to check right now. In fact, I've been recording with the video format this whole time, for this whole year, that if I would have some power outage, I would have to start over, because some kind of dictionary information hadn't yet been written. These are pretty expensive, and you would have to print tons of these at some point. So you will need tons of iron. Good thing then that that's the most common material that you will get. So you can see it's yellow again, the thing with the two pluses, and one of them is yellow, the entire thing is yellow, blah blah blah. You know how from the cable and the pipes. Then we have the corner chute. Again, the auto rotate key is your friend. The chute outlet, which is the one I want to incidentally use here, but then we have the inlet, not used here. Overflow chute, which can then pipe to a different location. Then we have the valve that you can turn on and off. The flip-flop splitter, which flips and flops depending if something's going through, then it switches, something else is going through, then it switches again, ding dong ding dong. The junction, which allows two paths to join. The window chute, which is just like the normal chute, except you can look inside what's happening, and if there's gas going through it, that will be affected by the environment. So yeah, if you have something in, I mean gas, oxide for example, if you want oxide to go through such a thing, you would have to use closed chutes, not the window chutes. And that's where it will come out. Alright, now let's make steel. So, as you remember, we have to achieve 900k and 1 megapascal. How do we do this? Should I put an entire stack in? No. Maybe I should show you just quick what happens if we do such a thing. First of all, yeah. Okay, first I want to get that thing going, because if I, for demonstration purposes, oh, what just happened? Many things at the same time. If for demonstration purposes I toss an entire stack, then that would I have to click the ignite button 50 times so that it melts that one item that is going in there, so that the entire stack is consumed and is inside them. But what I can do instead is I can get some kind of flow going here. Now my hands are not occupied with something that would show me my hands visibly on screen. That's what I wanted. So now that my hands are occupied, when I split the volatile stack, it will not fall into my hands, but instead it will fall into the world right in front of me. And so that's a trick that you can use. It's not a cheat. It is
Power low.
a clear shortcoming of the what's its face? Of the user interface. So that's in there now, huh? And now let's see what happens if we add some oxide to this too. The pressure is increasing. Okay, maybe it's enough. Maybe it's enough. No. If we're at that point, there's just nothing you can do. This is the end. There's death.
Cognition critical. Health critical. Suit critical. Low pressure.
So now I'm respawning. Since we're in easy mode, okay, let's first assess the damage. What's happening here? Well, I guess a little bit of gas in the station is now being mixed with all the volatiles and is leading to a burnable atmosphere. And since we also have some burning going on, you can see that there. And everything is destroyed, discolored. Yeah, there was this flow of sparks. Well, in easy mode, if you respawn in your spacesuit. Yes, you can also play third person, though you cannot really play that. It's just an afterthought, which you can tell, for example, from the fact that you cannot look at yourself from the front. Really a shortcoming that I hate. What you can do, if you want to make a video, is you can pretend as if you're not the guy who made the save game by editing the save game. So you load the save game, which means that you drop in a new capsule. You will see yourself standing around in there, whom you are no longer, from the outside, and yeah, that's something I've been doing. And in this way you can even play in all three species at the same time, because you can play 3 different species. 2 of them are DLCs, each of them about 10 euros. And one of them is a robot, which doesn't need to breathe and doesn't need to eat. You just have to keep your battery fresh, but you're very dependent on it. And the other is the Zrillion, Z-R-I-L-I-A-N, Zrillion, which is an alien. Freezing the sun again. And that breathes actual volatiles and breathes out N2O. If you remember, N2O and volatiles together are the most potent fuel there is, so that will land then in this canister here, and sometimes, just due to pressure alone, it will self-ignite. So that's advanced difficulty. And the starting conditions are not adapted. That's a shortcoming on the developer side, or, you know, so that makes the playthrough even harder, because you're not starting with a reserve oxygen tank. But that doesn't mean it can't be done. I have pulled it off even on Europa, which is already harder, on Stationeer difficulty, as a Zrillion. That works. So, I mean, if you want to raise the challenge, you can. So you can play as all 3 species as in a single player game at the same time. Just, I mean, you cannot control the others at the same time. You have to edit the save game in between reloads, you know? Okay, let's do this then for real, once I have topped up my battery. So you have seen now I want something in my hands. Then I want to split some volatiles and ignite so that it goes in, otherwise the chute is stuck closed. And if this thing is already burning and hot and you stick an entire stack of iron in it, that will work. But if it's already very cool, then it might be that only part of the iron stack melts, and that's the end of it. You might think that's a bug. It's not. It's the normal logical behavior of this thing. It will not open. The furnace is basically kaput. However, here you can use this input for fuel gas. And you can actually do that. You just print yourself a little canister holder, use one of the pipes, stick that on there, stick your welder canister in there. That will then give some fuel gas, enough to heat that thing up again, which frees up your slot. Then you can put the and so forth. I mean, it's very fun to play with this game. Oxide, that too now has to be smelted by me by hand, because there's no heat in there now. But now Both components are in there. You see, we already have 1,000 of degrees Celsius. But 1,100-ish degrees Celsius already. 1,400 Kelvin. 1 megapascal. That's already in there. So as we remember, you need 2/3 volatiles and 1/3 oxygen, since the oxide is not pure, but that's still I mean, that's the way it works. But and even though, yeah, that's what I want to say, even though the oxide is not pure, you can say 2 volatiles, 1 oxide, that is a good mixture. And I will now put even more in there. So now we have 4 volatiles in there, and wait, oh, that was too much oxide. Okay, that's not bad, it's not a problem, that was just stupid. So now we can go smelt some stuff. You can see contents, none, because the gases don't count as content. And now we get iron, and this will produce an iron ingot. I mean, if I pull this lever now, once the inlet is done, once the smelting here is done and it's in there correctly, then it will toss out the iron ingot. And this will produce a 100 larger ingot, you know, 100 grams. Maximum is 500 grams, so eventually this thing would just spit out multiple ingots. And now it's saying it will not produce anything. Why? Because now I don't have one pure thing in there. I have multiple. And these multiple are not a proper recipe. But once I've put in the iron, we should get the proper steel recipe. Because I believe even though there's lots of material in there, yeah, 200 grams of steel, which has off-gassed a lot of gas into this thing, we should still have enough heat. Yeah, we have 900 Kelvin plus, 900 Kelvin, and we have 1 megapascal plus. Yes, we have 11 megapascals. You can tell that the recipe is valid also here by looking at this, which I think is not implemented correctly in the advanced furnace, but in the simple one, in this one definitely is. But anyway, you see here, we'll produce that. Also, you can check your parameters. Sometimes your parameters are drifting, like currently my temperature is falling, and so the moment you read here is a different moment when you pull the lever. Obviously, it's not happening at the same time. It's a second or 2 or 5 later, and that might be too late already. But anyway, we have our steel, and now we have the furnace, which is still screaming hot and has lots of pressure, but it's the furnace. It's built for that. Let's ignore that. It is also very loud, by the way, and it's disappointing that we cannot hear that here, but well, what can you do? It's the moon. Alright, now we have that. Let's make the station battery. And actually, no, let's make first the stacker. One of them at least. I need an iron ingot. Do I have iron still? I don't have any more iron. That is very annoying, because for all the subsequent things we will need some of that. So we have to go mine again. Not something I wanted to do now. Don't tell me that's lead over there. It is lead. Glorious. Wonderful. Because if I want to do the programming stuff, I also need solder. And solder is made of lead and iron. Some more gold will be required, so I can make my Electrum stack that I wanted to make. 50-50, you know. And then I want to have 50-50 lead and iron. And I want to have a lot of iron, since we need that now. I need to make some more pipes. Yeah, we still have 15, but still. And iron is just needed all the time. Yeah, sorry about the mishap with the recording button up there. I think that was visible the whole time. I wasn't aware of that. Too much going on my screen. That was because I had not told ops to only use the window that I had selected for the for my own head-up display that I programmed in Java with the help of Grok, by the way. But instead, because I didn't want to sieve through all the XML stuff, like what do I have to look up how, and how do I implement the XML, do I need a library and so forth, I just told it what to do and it did that, and good. I mean, half of the application was made by me, half of it was made by Grok. That's also how I work at work. It's a real productive tool now. I love artificial intelligence, I fucking love it. I love it, I love it, and I love it. Because I get the feeling it loves me back. Of course, that's a metaphor. In the same way, I love computers. Okay, that's definitely enough lead. I also needed only needed one stack, now I have 3. I thought I could uncover some more lead for later, maybe? But apparently that was all the lead. Or was I misled? No. Iron and gold, please. If ever, when you're out here, your suit battery craps out, obviously you can just put one of your tool batteries in there. That will solve it. The small battery, like in the tools, currently, I mean later I will just print large ones, has 1/8 of the large battery's charge capacity. And there's even a larger battery, the nuclear battery, for which you need the advanced furnace and some advanced materials. And I need some gold. Oh, there's gold. Very good. And that has 8 times again the capacity of the large battery. Exactly 8. Maybe you can tell that the rock around these ores is a bit harder, particularly around gold ore. With a better drill, that doesn't matter so much, but it still matters. I should have brought some of the mining charges, too bad I forgot that. So that's something that you can try. Start your save game already. Play Stationeers. Don't let me chew all the food for you. I mean, Stationeers, in other games, you level up by playing for long enough. You hit, like you kill 1,000 monsters, then you level 2 or whatever. And in Stationeers, you level up by building, by having an airlock at some point, a bigger airlock, a better airlock at some point, a better manufactory at some point, and so forth. But what also levels up permanently, so in a way it's kind of a roguelite game, you level up. And that kind of leveling up that you experience here in this game, which I'm taking away a bit from you by telling you all the things, is a unique experience in all of gaming. I mean, I've been a gamer for many years. I'm basically around 50 already, years of age, and I was with the computer community in the computer world from an early age of 8. That's why I've been a programmer for 40 years already. So when I tell you that this is unique, or at least it's outstanding in its quality, the self-learning experience where you improve yourself and how it matters in your functionality in this game, that you can take that to the bank. So this first time where you level up yourself in Stationeers over many weeks, getting better and better, that is absolutely irreplaceable, wonderful experience, and I am envying you because I cannot have that anymore. I cannot do that. Maybe some drugs could be used to get there, but that's not my thing. I've been super sober for actually 20 years straight now. I mean, super sober when I say that, not even caffeine in any of its forms. No tea, no coffee, no coke. Nothing. Because all additional stuff is additional stuff and useful. I'm not denying that. New usefulness here, usefulness there. But ultimately, what are you building your engine for? To run it. And it runs best if you use the normal operation mode instead of over-tuning, bending out of shape, whatever other things you would describe this as. Okay, now we have enough gold. We have enough iron. We can continue. Right, that was stupid. I should have done that right away. Wait, what? What's happening? Is sometimes there are some visual glitches, like I could just look into my spacesuit throat, then switching to third person, there's a hotkey, I don't know which one it is, I changed mine to shift. And returning to first person solves it, and if these panels here begin wandering to the top a bit, like there's a gap down here that will never be closed again, you can just save and exit the game and reload. That will solve it. That will eventually, of course, be fixed. It's an early access game, man. And people who think that this game, having been in early access for 10 years, is one of those, we take your money and run, that's ridiculous bullshit. This is the last game of which you should ever think that. Not only did they say that they will keep developing this even past version 1.0, even though they do not have, no one is paying them to, because really this game is underfinanced. And the tutorials themselves, they took already like 300 or 400,000 dollars to make, and they're basically almost void because you know they are currently dysfunctional. So there's so much money going into this game. Right, I remember I wanted to make the stacker. And also, we get, during the weekdays, we get sometimes 2, sometimes even 3 new beta versions per day. Per day. That averages easily to 1 actual game update per every weekday, including the weekends, although then it doesn't happen. Only some rare exceptions that happened there. I want to print this stacker. And so it has been for years. You can watch on their official Discord, which is linked on Steam. There's a dedicated channel in the discussion forum of Steam. What's changing, you know? They're right there. Okay, stacker in this direction and stacker in the opposite direction because of the buttons and such, the knobs. And then there's the unloader. You can toss, for example, your spacesuit in it, which will then unload, will remove your belts from it, and will remove all the things that are in the belts and so forth. A complete disassembler thing. And then it will also toss out the belts and the suit. Actually, I don't know if it's recursive like I just described, but I think so. Stacker. I'm wondering where to place that thing. That looks good. Okay. Or maybe the other direction? That would make more sense. This wheel can be used to input a value, which is how large the stack shall be. But in this occasion, and others too, you can use the labeler, which I already used to rename some stuff. Where is it? There it is. To set the value directly. So that's the thing. Now this thing needs to be powered. Maybe we need some more cables, huh? Yeah, I can turn this on. And if I toss in now, for example, where's the steel? There it is. It's going to be set to 1. Okay, then we will get 200 ingots, indeed. Instead I click here. And I decrement it while holding the modifier key that you can see in the tooltip. And then I will get 4 ingots. And if that doesn't work out evenly, the rest will just stay in there and the lever will stay down. You can click the lever to get the rest. Okay. Let's make the station battery. Finally. Needs copper and gold. How much gold do we need? Oh, 20 gold. That's a lot, man. And copper, which we have. This will take a while. What I will also need is a few steel sheets. I don't know how many. I think it is 2. See, that was one of these 0.5 situations in action. Okay, here we have the gold that we want to smelt together with that. Okay, how do we make Electrum, huh? We need an arbitrarily high temperature, but the pressure needs to be relatively low. I guess the furnace out there is already colder than this. From my experience, it makes sense to produce the Electrum and the solder together, because once you have done the Electrum and haven't put in too much fuel, it will be cold enough to... Is that the only iron I had? Ah, damn. I need more iron. Crap. We'll have cooled down enough so that you can then make the lead, the solder. How far are we? Where will I put that thing? I can put them on the indoor side of the station. I will put them here. Normally I put them outside, but I will just start in a second. Well, currently I have the solar... Okay, that's the thing. The solar panels pump in energy. If I don't connect the battery to this, this energy will not be put into the battery. I would have to put the battery in a place where it can also be filled with the solar panels. That's annoying. Not sure. Maybe I could put the batteries here on this side. There is the station battery. That is the station battery, the small one.
Power low.
And there's room for another one right next to it, which we cannot print at this point. Okay, where is the steel sheet? I have it in my hand. Let's empty that again before it reaches its critical point. And, well, currently it's 83 degrees in here. That's too fucking hot. We need to cool the station down. For that, I want to use, I want to print a cooling solution that will need gold that I don't have, because I want to make... so I need to go mining again. Annoying, but that's the way it is. Then we have to turn that on. The large batteries have their switch on the front, so if you have two station batteries, two small ones right next to each other, you cannot operate the switch. Not a problem, you can just tell it via logic to be on. So which sounds, of course, to you still like it's tedious or tricky or whatever, because you are not yet but to you it's still new. But at some point you will be dealing with logic in this game the whole time. It's completely normal then. And oh, that's the wrong. And then this one command that you need is indeed one command to turn on all station batteries on the same cable network. One statement only, one line. But once you're there, then that will be, you know, just routine. You're a stationeer then. Okay, now the battery is being charged via the solar panel. Basically, maybe I should restore the normal day-night cycle now, huh? Let's do that. Orbit times scale 0.3. Because now we can print some lamps in here. I'm not recommending that you should do it like this. No, I'm just... I wanted to show you things without it getting annoying. So I need to go mine. Mining drill is full. Okay. Because we need more iron, we need more gold. Because I need to print the... how much gold do we have here? Nothing. Nothing. And the electronics printer has 2 grams, that's nothing. And here we have no gold whatsoever. So we need gold, that is reserved for furnacing. And yeah. Currently the station is not actually benefiting from the battery, but as long as I don't unbuild it, it will keep its charge, so I can just later put a cable here and problem solved. But first I need copper. We have copper, actually enough copper. I could, you know, let's just print a ton of cables. While I'm away, while I'm mining, let's print cables. And later then, when I have gold, I can print large cables. Do we still have enough oxygen? Enough for this. Gold. Nice. Part of the supplies, man, I forgot to bring the charges again. Part of the supplies that we land with is a mining belt, like we have already, and so you can easily store more things. And you can bring multiple mining belts. You can even you can even print multiple backpacks, not just jetpacks, but backpacks without the jetpack component. And you can put them in your backpack, and you can stack that arbitrarily. And that's of course a bit fucked up, but the furthest I go is to bring like 2, maximum 3 mining backpacks, which I then carry in my jetpack backpack, and then I sort full stacks into it. You can also just wear the backpack, which will then have the same effect as if you're wearing your mining belt as a belt, so things will land in that backpack automatically. But I like to pre-sort things and like to be in control there, so that's why I like to be able to fly, and all of these factors combined lead me to just using the backpacks manually. No more gold? Oh, come on! What did I need the gold for again? For the lead. Copper we should have enough. There's more iron and more gold. So in Ops Studio I can define what sources it grabs its imagery from, and I grabbed from my Java program. And I forgot to say insist on the title. And so it was just looking for a window of similar type, and then it found that that recording thing. I mean, I still don't know if it was actually on screen. I guess so. The moment I had closed that window. That's sad as an accident, the entire video polluted by that. Too bad. Well, shit happens. I cannot edit this out, you know. I mean, I have DaVinci Resolve, but that part of the image is obviously gone. I could actually have this patch replace thing where it would try to do something similar in that place, but I don't have actually this DaVinci Resolve doesn't yet have an AI-driven such thing. Weirdly, because DaVinci Resolve has like 60 different AI generators in it. It's very good. I mean, even the free version, which you can even use for commercial purposes, is already very good. DaVinci Resolve, I mean, it's the video editor of the future from the current perspective, you know. Can only recommend it. So, let's get some more gold. Is that more lead? Not that I need it. It is. And more silver. Soon we will have an eclipse. Because that's Earth, that's the Sun. By the way, if you would have a telescope thing now, which in principle even exists in the game, though I've never really gotten it to work because it requires the proper coordinates, which you only get if you have a rocket in orbit, and then you have to translate that with Arcus tangents and such like that, which is beyond me currently. I mean, of course I could just say, hey, AI, do that for me, and no, that doesn't keep me stupid. Instead, I see it in front of me and it is utilized, and so the more I get in touch with this, the more I will actually learn about it. That's how this works. This idea of AI will make us stupid, I mean, some people will rise, some people will fall. I care about the risers and try to ignore the others. Okay, let's go back, except if I find some more gold. Where's the station, man? Oh, there it is. Direction 100 degrees. Can someone remember that and tell me? Silver. Need gold. I can see that only while the sun is up. Or when I'm very, very close. Ah, there it is. So, I mean, this day-night cheat thing that I used here, you can basically start playing your game if you wish, and if you're proficient with the plants, because that is a very tricky thing for beginners to get right. I mean, what we say in the forums, basically to every beginner, oh, look at that, the eclipse. When they ask, hey, my plants are dying, see, that's fucking black, man. Is print yourself the plant analyzer cartridge for the tablet, because it will tell you what's going on with your plants in regards to pressure, gas mixture, pollutant, temperature, light, and darkness. They also need. They need their darkness break, basically. It will tell that. Okay, now it is past it. So, once you're proficient when it comes to plants, you can actually consider doing a playthrough with an altered world term. But remember, you have to set that every time you load the game. Every time you have to set that anew. No more gold? Okay. At some point you will see the Earth lit from below, and you can tell the time of night by that. And when the Earth is already entirely lit, but it's still dark, you know it's morning for you, because the sun will be over there. Time to print some lights, huh? Oh, we have cables. Look at that. So again, F1 is for help, F2 is for the head-up display, F3 is for the console, F5 is for quick save. And you can also save here and create a new save game. Oh, by the way, every save game has a save game rotation. So you can just load... Oh, we still had gold. That's nice. Now it's smelting even more of that. You can load a game from 10 minutes ago, from 20 minutes ago, from half an hour ago. That stuff, you know? And this shows you that a stacker attached with chutes to a manufactory is probably a meaningful thing. But then you will have a new problem that you didn't have until that moment in time. Which is, you need to turn that thing on. If you forget that, it will be blocking the manufactory. And so the manufacturer will burn through electricity and produce the item for you. And then when it tries to output that item, it will not be able to. And then that item will basically not exist, and the resources will not have been used up, but the electricity and time will have been used up. But, of course, you can automate that. But then you have to, I mean, like I told you, this thing will only spit something out once the stack is full. And you would set this thing to 50 or 500 or whatever when you put that behind one of these, because the highest stack for any item, except if it's an ingot, is 50. So if you use like 100 here, it will still spit out after 50, you know? So that setting really does matter then. 91 degrees, man. Yeah, well, the sun was up there here, and that was already too far away, basically, from the solar panel, because there's only a tight cone where you get proper electricity, and then it fades out quickly. So anyway, you would have to then click this guy, because it don't produce 50 sheets of iron, you produce like 10 maybe. So then you have to click here. And then later you have to turn that off again if we want to save electricity. So what you then want to program is something that turns this thing on simultaneously with its manufactory, and then tosses stuff out automatically when you turn off the manufactory, and then afterwards turns this thing off automatically too. All of that can be done, and it's a fun programming challenge. This game can be fully automated, entirely. Including getting gases, because you can launch rockets also fully automatically to get ice from space. Oh, look here, I'm blowing up my station. Or not. When you pick such a thing up, it will immediately be disarmed. Don't even have to click. Or you can disarm it by clicking here again. Yep. So we need to cool down the station. We have the gold to do so. We have iron. I don't know why I have so much iron on me. Ironically. Yeah, I wanted to make some more pipes, and I wanted to make the radiators that I want to use for my cooling system. Pipe, kit, radiator. It needs gold and it needs steel. Both of which I have. And how many do I want to print? Multiple. Let's see. 48 divided by 3. 60 divided by 3 is 20. Yeah, that's good. Just keep printing. How much steel does this need? Less steel. Okay. So gold was the limiting factor. Now I need to print some... Okay, I need this for that, for the pipes and such. And I need to print cables with the electronics printer. Heavy cables. Not for the cooling solution, but... because I need to change my cable setup. Everything that's coming from the outside shall now be heavy cables, because you might think I only need heavy cables between the load situation, like here is the solid fuel burner, here is the battery, heavy cable from here to there, but here directly attached, and that's possible. You can just have a junction heavy cable here, and then you connect straight away a thin heavy cable, a thin cable, no problem. But that's not how it works. This cable could still burn out, because that is where the game is just, you know, winging it, where it's where the simulation is limited. What's that? No more power. We are experiencing a power outage. We no longer have power in our station. Do we have power in the airlock? Yes, we do. Cool, by the way, that the composite door also has its own light. Not just a light that is lit, but also a light that lights. As opposed to some lights in the game, which will just show that they're light, but they will not actually excrete rays of light, so to speak. So what do we do here? Well, for example, I can pipe this thing, cable this thing up with the rest of the station, which I hereby do. Then we will have electricity, but not for long, because this thing too will eventually run dry. But this will allow me to continue printing the thing that I want to print. Can we see the amount of charge that this thing has? No. But you can read it out. There's a number, and you can show that number on an LED. There's also a light type that is a progress bar, so to speak. So you can show the ratio from 0 to 1. There's even a ratio value that you can read out from the batteries. Whenever the power is out, this thing will stop smelting and it will even turn off the device. I don't know why it does that. No other device does that, so that's a bit fucked up. Anyway, so we now have this power problem. How do we solve it? I want to print heavy cables. Do I have some gold left here? No, maybe on the outside. When the smelting aborts... Look here, we still have power, but not too much. Same thing, basically. Then it will toss out the ingot that was smelted so far and will just not smelt the rest. In other words, we now have some gold that we can use to make the heavy cables. And then I will need... Where are the frames here? We'll make some frames out there so I can place the solid fuel generator. That's why I hadn't yet set it up, because I thought maybe there's a better placement for this. Heavy cable. And that needs... Oh yeah, just print, dude. I need them, I need them, I need them, and I need them, and I need them. See, I basically have not yet used the station to really breathe inside of it. So maybe I should not have filled it with gas yet, because then the sun didn't have anything to heat up. Because contrary to what Hollywood keeps lying to you, a vacuum doesn't have temperature. It's not hot, it's not cold, it doesn't have any temperature. That's the reason why we use that as an isolation material, so to speak, in your coffee, in your thermos canister. That's why there is a vacuum between those two walls of quicksilver coated mirrored glass. So do you freeze when you're out there in space? Yes and no. First of all, when it's winter, you will sometimes... Right, I have to replace that cable. You will sometimes feel that the temperature that is displayed on your thermometer at home will feel colder, even though in the summer you would be glad for that. Well, one reason is you probably have a higher core temperature in the summer, because you came from the outside or something. But one reason probably is that the walls are not radiating heat. Or, I mean, yes, they are, because they're not at 0 Kelvin, but they're radiating less heat. So part of your heat experience, or your temperature experience, is that not just the immediate fear that you have of the air, but also the radiation that comes in. And so if you would be in outer space, in the shadow, where the sun is not immediately screaming at you, because that would be screaming, that is the sun without atmosphere. You're well aware that this causes cancer, yes? Yeah. Without the shielding, we're fucked. So if you're in the shadow, for example, of the moon out there in space, you will feel cold because you have no thermal radiation coming towards you. So you will cool out, not by convection, but by radiating your heat away slowly. That's what will happen. And so you will also feel immediately cold, not ice cold maybe, who knows. I've never been in that situation. Because the radiation that you normally experience, oh, that was wrong, is just not there. Except when in the sun, when things get hairy. So what about your nostrils and eyes? Well, there's a problem, because as you have seen in the phase change diagram, which is not realistic, but is realistic-ish. If the pressure is basically 0, then you will have evaporation, even at cold temperatures. Which means that where your body is exposing water, basically, that water will evaporate. And evaporation cools down, like I said. And so these parts of yours, you will even rather quickly be frozen. There will be ice. So that will also be in your lungs, which is very, very bad to have in the lungs. Because the crystals, they are cutting from in principle. And, well, also, you don't want your lungs frozen in general, huh? So, rest of the cable. So that's what's going to happen. But you don't freeze like an ice popsicle. Aha, now it's charging up via the solar panel. I'm not yet done. There's still a cable that could burst. Yeah, now I have to cut that cable and I cannot get to it. What you do then is you merge it with a cable that you can get to, and then you cut the whole lot. Oh, there's a heavy cable already. Okay. Alright, now we're getting some charge from the sun through the heavy cable, and the heavy cable is also connected to the solid fuel generator. See, things, I mean, maybe you don't feel it, but things are now accelerating very slightly, because we have a broader field of things that we can do stuff with, and also because we have more resources to play with, and so it will go into the breadth and into the speed more and more, this game. That's why it was very meaningful that I showed you some more advanced station situation at the beginning. Oh, look at that, the thing is turned off. That's fine, because I didn't want to burn through all the resources here anyway to make all the cables. We have enough cables for now. In principle, if someone says we have enough cables, there should be a season station here which should say because you never have enough cables. Though currently we do have for the foreseeable future. Alright, let's turn this on again. No, we can't, there's just no power. What do we do in the absence of power? We will burn some coal. How much coal will we burn? Oh, only a little bit, only a little bit. Okay, I will do multiple things at once. I will get ready to make the silver, not the silver, the Electrum, so that we get some computation done here. Sorry, rather late today. Yeah, that stuff. Iron ingot goes here. Can't explain that.
Power low.
Maybe you have guessed already, this slot is not for ore or for general for general stuff like pipes. You can only put tools there. Cables count as tools. And here you cannot put tools there or general stuff. You can only put ore there. That's a game balancing thing. So that you have an extensive inventory, but it's not too big. Okay, let's burn some coal then. How much coal do we want to burn? Only a little bit. Can already turn this on. And this is even lit without power, lol. Now it's filling up the battery. The battery is powering our station. And even though the solar panel is no longer doing much, or maybe not anything at all, this guy, you can see this one is already solidly lit. And I've only put 10 coal in there. It will fill up to half or even further. And this guy packs a punch. I mean, the amount of charge it has is... I did the math at some point, don't want to do this now. We have definitely much larger, I think... okay, I don't know exactly. Okay, what was the next step? We have enough cables. We need to cool down the station because it's boiling hot in here, literally. So we need an active vent. I need an active vent. I will now show you a minimal... That's the wrong one. I will now show you a minimal cooling solution. That you can at the same time still automate. We need iron, gold, copper. I thought we had some extra copper here. We don't? Confusing. I was so sure we had extra copper. Huh. That sucks. Then I will take this. At some point I want to pump out, some location I want to pump out the station. Atmosphere, it doesn't really matter from where, I guess, so I will just pick this as basically a random spot. Now let's cable that up. You can see that this is all bent out of shape. The air is really already distorting from the heat. Okay, now we need pipes. I have 15 pipes. I want more pipes. Or is this enough? Kinda, quasi, maybe. Well, let's take these 15 pipes. Let's just take them. Where are they? I have them on me. Haha. No, I won't need that many. Damn, I didn't place the active vent correctly. Yeah, it's not that important. Let's just go with it for now. The pipe is just one volume, so if you would put in some gas on this end of the pipe, you would immediately see the gas when you're looking for, or pumping from the other end of the pipe. So if you make a 10 kilometers long pipe, yeah, it's gamified, but you never run into that feeling here. So we have the convection radiator, which is for, I believe, 30 or more kilopascals. I don't know exactly what the level was. below that, the radiation radius, they're effective indoors too, but the convection are much stronger. Out here though, a waste. Let's use these ones. I thought I need more, okay. Now I can immediately cool the station, but it's not yet convenient. I can just pump out some gas. The temperature, the pressure in here decreases. Maybe I can somehow measure what's going on in the pipes. You can see the temperature in there is 50 degrees, 49 degrees, 47, 45. It's radiating away into space. And the longer the pipe is, the more pipe radiators you have, the more gas you can cool at the same time. The more radical that gets. And at some point, the fact that there's a pollutant in there, there's also CO2 in there, will come into play. And so let's pump that dry quickly. It pumps that out. The less gas is in there, the faster the temperature falls. You can see that there. So the stress at the right top, okay. I thought, I thought we would not be fast enough. At minus 10 degrees, the CO2 would begin to solidify, become liquid, and then the stress goes up. The temperature in here is now no longer 90 degrees, it's 72 degrees. So in principle, with this, we could now cool down the station. But I want to do this correctly. Is that a fun game or not? Need some pipes. Some things are tedious, but you know, to overcome the tedium, to find some solution that lastingly frees you from that. For example, by printing an entire locker full of pipes or whatever, or have an automated print. You can even program these things. So program 10 cables and then 5, but whatever, you know. This is one of the challenges. And then you have achieved that. You have completed your project in whatever complex way you sought. And yeah, that's awesome. That's fun. Of course, there's some kind of plateau situation where you kind of have everything that you need. You have your plants, you have something to drink, you have infinite resources, you have convenience. And then what? Well, then you can keep expanding and making things even better. But yeah, at some point it plateaus. But there's hundreds of hours in the game, man. And you have multiple worlds currently already. Later there will be many more worlds, because the community, which is already creating modded worlds right now, and I've played some of those, there's some videos even, the community will be pushed much harder to create more worlds, because the fact that the worlds that we have will be finite means that finite in extent means that we will have a stronger urge to have more worlds. And that means that there will be more reason for people to make custom maps. This means there's more reason for the developers to give us tools to make that relatively conveniently, which they are already doing. So there will be many more worlds to enjoy. That's the way, that's how you have to think about it. The world is complex. So these radiators, I will use radiators here. I will turn them up so that they're not in the way. Because when they go down here, there's less headspace. I can still walk underneath that, but once I have a floor here, or once there's a pipe I have to climb over, that might not be the case. Do I have more radiators? I thought I had more. I do not. Okay, that's not a problem. Yeah, that's not ideal. I forgot something. Because I also want something very specific. A pipe analyzer. I need to print that with this guy, and I think I don't yet have the materials. The pipe analyzer, it needs Electrum. Okay, that's the next thing I wanted to make anyway. Good. Iron, gold, Electrum. Do you have some gold currently? Yeah, kinda. So I can smelt that. And I have some gold on me also. Oh no, that goes into Electrum. Yeah, what's the idea here? The idea is, let's already use that. Now we'll pressurize the pipe, which means that now... that was stupid. Which means that now we have the pipe's convection and radiation effect is kicking in. The maximum pressure here is 60 megapascals, then the pipe bursts. At 50 megapascals, the pipe will start screaming, moaning basically. And the small pipes, the water pipes, they only can take 6 megapascals. So now I'm cooling down the room directly because the pipe is not just itself getting cooler, but it's also connecting its situation into the room. The pipe's cooling down, we have to take measures. I will pump that back in. That should give us... Yeah, you see the stress there in the pipe? Now it's gone, because some of the CO2 and pollutant was liquefying. So now we cooled the station down to 50 degrees, so we now have already a working cooling solution, in principle. Yeah, let's cool that down again. Let's do that again. Cool, huh? And this is all natural effects. I mean, this might be a bit with the radiators. I don't know how strong that would be in reality, but in principle, that's how it works. We're connecting this heat with that heat or temperature, and that with the space, and it's radiating heat away. Yeah. And the fact that the room gets hotter and hotter the whole time, that's a true thing. Why is the room still so hot? Yeah, I have to pump that out now. Basically, I need more of these radiators indoors, so I need more pipes. Oh, I'm pumping in the wrong direction. That's stupid.
Low pressure. Oxygen low.
I mean, if I pump in some megapascals, like 2 or 3, to have this cool down my station, and if I do that automatically, then that would stay in the pipes until I pump it out again. And I would pump it out when the room is cool enough. I could also, of course, use the pipe analyzer to detect whether there's some liquid building in the pipe and then pump it out again, but that would be a pretty annoying cooling cycle, pumping and pumping on and off and in and out the whole time. That's what she said. But instead, I can just make the overall cooling stronger by making it connect more with the indoor atmosphere by having more of the radiators here. And here they are not in the way. Need more radiators, which I have. Not too many. That, and of course, yeah. Now let's go and make some Electrum. Let's see how much this furnace has cooled down by now. We have 122 Celsius, which is 395 Kelvin. So still pretty hot. And I think it's still hot enough to put something into this input slot there. I don't want to test this now, though I can, because it's harmless. I can just use ice for that. Aha, see, 100 degrees I believe is the limit, and then it will just stay frozen basically. And that has cooled it down even, that's funny enough. And the pressure has fallen. So now let's get rid of all the gases in there. Which will take a while. See, all that dirt is in there. Outdoors, pipe, furnace. That would actually take a while. Let's just do some other things meanwhile. The advanced furnace is much more convenient in this regard because it has 2 pumps. One is to pump in fuel gas but you also can use it with just tossing an oxide ice if you wish. And it has a pump directly built into the heating chamber, however that thing works, that pumps out everything in the chamber. So if you want to empty that furnace, it's only a few seconds. This one takes a while. Okay, let's drink something then. I could also begin setting up some kind of drinking scenario, right? Here, for example. Yeah, that's good. Okay, let's take the portables connector. Yeah, I wanted to put filtration here. Let's use this corner then. Then I will carry the water over. Then we use the wrench. By the way, if this would be a gas, I don't know how this guy behaves, but oh, look at this, the graphics are upside down. Well, it's the current, the game is constantly evolving, so slight things like that can happen. Oh, what am I saying? The pressure is 12 kilopascals. No, that's correct, actually. Because it's not showing you the water level, it's showing you the pressure, I guess. But the liquid volume is also low. Anyway, if this would be the gas tank, this one. I don't know what about this one, but for this one I can tell you, if you turn this open and you screw it here, you can no longer operate the wheel, but it will still be open. So you can pump gas in here and it will come out there right away. It's hilarious. But it can be abused for back pressure, for a pressure regulator, because that is a pressure regulator. You can turn this open to the degree that you want. Currently something's coming out, I don't want that. Now nothing's coming out, even though it's open still, like I expressed, 20 kilopascals, but we have 24 in the room, so nothing's coming out. So there's a pressure regulator. There's also a pressure regulator built in the game that you can make with the pipe bender, and a back pressure regulator, which makes sure that the pressure of the input pipe is never exceeding a certain level. Yeah. Okay, now I want that to go into careful. If I use the wrench, I can actually open the station and then the gas escapes. It's an easy mistake to make, so be careful. Where's the water bottle? There it is, the water bottle filler, which also has two build forms. You can see the 1 and the 2 there. I will now scroll and rotate. Now it's at the bottom where it belongs. This thing needs power though. But we will need a power grid on the ceiling anyway. Alright, and then these hydroponics trays, which I cannot yet use. I will just stick them here, you can stick them next to each other, no problem. There's also the hydroponics device. The difference is you cannot stick these adjacent directly to themselves, because no device can be connected directly to another device. That's the way it is. But you can read out what's going on in there. But that's not the only way to find out how your plants are doing in an automated fashion. Why are there 5? Anyway. Okay, let's make sure that we get some cables up in this bitch, or what is the next step exactly? The furnace should now be empty. Let's make the Electrum and the Solder. Need to print some filters soon. First order of business, close valve. Yeah, still some pressure in there, but who cares? It's just a little bit. Save. You should do that before furnacing. Since the sun is out, I have to use the split trick. So that should be enough. Is it heating up? No, it's just warm. See, why doesn't this ignite now? Because there's a difference between it being hot enough to smelt something, or to melt the ice that I just tossed in, and between it burning. Ignition, I mean fire, is a different thing. You can also, there's even a pipe igniter that you can slap onto some pipe network to make sure that the gases in there are ignited. That's also possible. I mean, the game has so many features. You have seen a spectrum so far, but not all of it by far. Okay, Electrum. A pressure of 2.4 megapascals maximum. And a heat of who cares. That's basically it. So what do we have? We have a pressure of way too much, so let's open that, just let out some steam basically. And the temperature is high enough, so at some point that thing here will turn green. Of course, the hotter this thing is, the more pressure it will have. And the less gases in there, the faster it will cool down, because there's less reason for it to stay hot versus the environment, which is cold. And if I close the valve now, which I will soon, then it will still decrease in pressure because it's getting colder.
Air tank low.
So it needs less, so it will occupy less volume. See, it's green now because we're now at hot enough, which was 600K I believe, and the pressure was 2.4 megapascals tops. So now we have our Electrum. There it is. Now let's make solder. As I'm tossing this in, you will notice that the temperature is going down ridiculously, because now it has to smelt all that stuff. To make solder, we need half iron, half lead, that's in there, and we need a pressure of 1 megapascal or more, and a temperature of 550K tops, so 350K minimum. So we're almost at that low temperature, and the pressure is still too high. I can accelerate that pressure thing by by the temperature thing by letting out some pressure, because the less gas is in there, the less body of heat is there that insists on the heat. Yeah. I think we should see the Kelvin dive down quicker and quicker. I think we already are seeing that. Of course, it should also decelerate, because the temperature differential between the furnace and the environment is decreasing. So there's less reason for it to get colder. Yeah, if you want to get stuff cold, you can, for example, toss some water in there, some ice. How, by the way, is our station battery doing? Oh, looking good. Very good. So we want to accelerate the cooling down. One thing I can do, I can put more oxide in there. That means more gas, and also needs to smelt that. See, we need to reach 550, we're almost there. You might say, hey, that makes it hotter again. No, only if it's fuel gas makes it hotter again. So there needs to be a mixture of volatiles and oxygen, and it turns green. And there's our solder. Nice. And I will now evacuate everything for next time. Okay, now we have that. So we can now print the logic stuffs, and we now can print, the computer, for example. We cannot yet upgrade the manufactories. For that, I need to make the other 2 ingots, for which I also have the materials already. So that's pretty good. Except I would need more nickel, but you know, that little bit of nickel that we have is enough. I don't need to make that much. All right, there's the stuff. Let's print the pipe analyzer. which needs gold and electrum. Ah, I forgot to smelt the gold, right? Or did I? I think I did actually think of it, just didn't take it in again. Convenient airlock that we have here. But it can be made faster, of course. We're not gonna get to that though. Ah, there it is. I didn't smelt the gold. Shit. I don't actually remember how much gold we needed. Maybe that's enough. One. Oh, that's good. Pipe analyzer. And let's put that away. And the pipes. And these pipes too, why not? I'm just using auto rotate until I'm satisfied. So there's a pipe analyzer. Let's make sure that it has power. Now it has power, let's turn it on. And now it tells us there's nothing in there. Let's put something in there. We see the capacity, 270 liters. We see the temperature in Kelvin. We see what gases are in there. We will also see if something is liquefied in there. Temperature of the station dropping from 36 to... Yeah, it's done already pumping out. You can see nothing's in there. So the cold stuff was felt by us immediately. Then it equalized with the rest of the gas in the station moving around. Yeah, this thing is now basically pretty superfluous, right? Let's remove that. Then we have a reserve to make another cable network. Normally, what you have after your station battery should be a heavy cable and then you branch out into various cable networks. But, you know, let's keep it for now. Keep it like this for now. There's a battery that we no longer need. Let's just charge that from... And this charges not directly from here, so it's sucking the battery here dry, but not that much. Because, 0%?
Hydration critical.
Right, this is connected to the outside network. I need to connect this now to the indoor network. Okay. The outdoor network is not currently delivering anything. Oh, let's just do this then. And I will correct the cable situation here. You can just go into the wall with your head to see what's really going on there. You might think that's a bit stupid, but on the other hand, I mean, it's a good trade-off between all the potential things I would have to do to solve that. Alright, okay, see, the airlock is being charged only from the solar panel. That's bad. That's a bad thing. So I need to decouple this now. Let's prepare that. And all of that is fun. I mean, currently for you, I don't know, if you're still watching this at this point, then it was probably not too boring. And it's fun to deal with all these little fiddly things and improve stuff. Yeah. And now it's charging. 54%. 50 what? What's happening? Why is it not charging that battery? Did I construct that the opposite way? Oh yes. Yeah, stupid me. So that's a thing that can happen. I just wanted to show you that. Power and charging 48, 49, 50, and it's charging now for our station battery, which we can easily top up with just a few grams of coal, because 20 kilowatt is really a shit ton. And the solar panel is still going here, I trust, or not? It is. It's going through the airlock for whatever reason. That is no longer necessary. We could clean that up also. Yep, looks correct. Also, the cable analyzer can tell you what's connected with what, obviously. Yeah, it's dark in here. Dark is not beautiful. Let's put up some lights. I need iron. And some cables. There's no acceleration for these cables, you indeed have to put them up bit by bit. Unfortunate. How do I do this now? That was wrong.
Anti-critical. Filter low.
Yeah, that's another thing you have to prepare for. Try to keep everything in balance without the warnings or without the immediate situation that would force you to solve something, because sometimes things will just come together in a way that will just overwhelm you and then you're dead. I mean, of course you can just load the game, but who wants that? Who wants to cheat? Isn't that what that's cheating, isn't it? Okay. 5 lights, let's put up all of them. Okay, the lights, let's show those first. Guess I have to top up my oxygen before I do that. The pressure in here keeps decreasing, of course. The volume of this guy is much higher than the volume of this thing, and I think we have now learned to appreciate that it is all simulated. It's not a hard-coded thing that is the oxygen tank that does the certain thing, la 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 blah blah blah, but it is a gas container that has this volume and has this inlet, and therefore everything behaves accordingly. So this is a systems game where they are programming on a high abstraction level, and that's much more fun and allows for much more emergence, of course, because the high abstraction levels are sets in which more lower level data points are contained. Okay, so here we have the wall light. Many people use this. There's a light round small, uses also 50 watts. Angled light shines in that direction. Light round, just a style choice. We have a wall light battery, which functions kind of like the area power controller, that it has a battery buffer. If you put a battery in, that is. So that thing would keep burning even if there is no more power left. Then we have the diode slide. That thing is lit, but it doesn't light things up. And that's the progress bar thingy I was talking about. Then we have my favorite light, the wall light along white, which also doesn't give out more light than the other ones, also consumes 50 watts, but it is completely white, completely lit basically visually when you look in this direction. So it gives you the feeling as if there's more light, when there is not, in fact. Then we have some angled versions and some like that. And ultimately there's the LED whose color you can program. It consumes only 25 watts, and yeah. So let's put up some big lights. Can also place them on the ground, there's no problem with that. Let's enjoy the light then, right? What a difference. Just click on it to turn it on. A space station on a planet. So it's a planetary station, not a space station. Ironically, I need the light now to find the cables to cable up the light. Where you put your cables is completely your choice. You can also spray paint them, and you can even spray paint a stack of cables. That would be advisable. Spray painting produces some pollutant. So, yeah. Okay, and there was light. Nice. This consumes, of course, a lot of electricity, but we can just put up a few more solar panels to balance this out. And that's this balancing out game, which all of you Astroneer players know is one of the best parts of the game. Some more solar panels, a little bit more coal. I can also program this thing to turn on whenever the battery is low, and then when it's high enough it turns off again. And then when it falls below the lower threshold again, it turns on again. All of that is possible. With what? With computers. So let's make a computer. Needs copper. Crap. Right, I detected earlier that we don't have too much copper. Damn. Do I have to go out mining again? Good thing it's day, so that's feasible. Shit, I have to go mining again. By the way, let's get rid of some of this stuff and cool down the station in the process and get some more pressure in here. And once we're done with that, let's listen to the best sound in the universe. So we need copper, definitely. Also, it wouldn't be too bad to find some more nickel. How full is the... oh, that's nice. I mean, the mining drill is really a bit underpowered with that small battery, right? Oh, let's use a big one then. Filters, bit low. Need copper. And nickel would be cool too. That could even be nickel over there. It is nickel, god damn it. And what's that? Is that lead again? I'm blessed with a rare shit. I think we will get easily 2 full stacks here, if not 3. Way more than I needed. And again, I forgot the fucking mining charges. Even though they're so fun. I mean, you explode part of the landscape, you get a big crater and all of the ore falls down to the bottom. And it's a lot. Also, I mean, maybe you have gathered, the ore is not just on the surface. There's even some mining glasses that you can make later with advanced materials for which you need the advanced furnace that allow you to look through the soil, and then you can see the ore right there. And not only that, but you will also see what it is, because it's kind of like looks a bit like the Matrix, you know, unrealistic. There are suddenly some boxes there in 3D that have CU or was it CO? I think it was CU for copper and AU for gold. Yep. There's another set of glasses or another chip for those glasses that allows you to look through your station, so you can see cables in the wall, including their color and stuff like that. Must have run into a double cluster of nickel here, I guess. Yeah, mining is one of the most tedious parts of the game. But with the heavy mining drill, it is double as fast easily. And also, you can have the deep miners, so there's something to strive for. We can print that with the advanced manufactory, which I can print, which I can make once I have enough nickel, and I have enough nickel by now. I just wanted to exhaust this field here. And yeah, copper I need. Maybe we could also get some more iron while we're at it. There's copper. Station should be over there, I think. Oh no, there. Oops. Direction is 0. Oh. Well, the deep miner will then drill through the soil to the bottom, to the bedrock, and then occasionally, every 90 seconds or so, it will spit out a ball. What is it? Well, you won't know. You have to send it through the centrifuge first. And then it will turn out to be copper or iron or whatever. It will just keep putting that out in the ratio that is defined for that world's bedrock level ore distribution. So you will get little nickel, little gold, but lots of iron, for example. And if you have 2 or 3 of these running with 7, 8, 9, who knows how many centrifuges necessary, then you will get definitely more materials than you can use. So no more mining for you, except if you need gases, because that's the thing. In the bedrock level, you will never get any gases. You only get iron and such. You don't get oxide, you don't get nitrides, which is nitrogen or N2O ice. And you will not get water ice. Also, the raw ore, I don't know what the name was again, this brown ball that you get there will already be degassed. So if you were hoping to just abuse the fact that you can use the centrifuge or other means to get gases out of your ore that you gather, that is not possible. I mean, it's not like the fact that you have to centrifuge it to get something from the brown ball degasses the brown ball, so it is then useless afterwards. But no, in fact, the brown ball itself is already degassed. There is 100% consensus. There's no question that is de facto so, and I also tested it explicitly myself. That is the way. Anything that comes from below bedrock will not have gases. I need copper. Silver. Please, before the sun is down, I need some copper. There it is. That is copper. Station is direction 180-ish. And I think I need quite a lot of copper. I need 1 full stack, so we have some more copper to work with. I need 1 full stack, so that we have the material that I will then fuse with the nickel to make 1/2 of the next step of the... okay, fewer words, more showing. Ingots. We have steel now. And I made Electrum and I made Solder. But Invar and Constantin I don't yet have, and I want to make those. One of them is necessary, at least one of them is necessary to make the upgraded manufactories, and one of them, possibly the other one, is necessary to make the heavy mining drill. Can I carry more? Yeah, I can. But there's nothing more to be found here. Oh, there's some. Nice, nice, nice. Yeah, that shall be good enough. Let's go home 190. Oh, the battery is very low. We should put some coal in there. Well, this thing with the bedrock deep miner thing, they will also deliver coal, so you will have an endless energy supply from that perspective alone. Then you can automatically pipe that from the centrifuges here to this guy, or through a silo first, or whatever. Yeah. So we need 1 stack, because I just need copper. When your helmet is open, your suit will still consume oxygen from... Actually pretty much oxygen. Why is that so much? Because it is still cooling you and other factors. I mean, this can reduce to a very, very, very low rate automatically. But, I mean, ultimately you can just do this. Turn these things off. And then when you go out again, suddenly be surprised because it will say oxygen low. And then the question is, what is it? Are your lungs damaged because there was some pollutant here in your oxygen canister? It was lower than 0 and higher than 50 degrees or something along those lines? Or is the suit polluted with some stuff? The first step should always be flushing, I think. Or what is the reason? And the reason usually is that one of these or all of them are off. And then you will see, well, they're on. No, they're not on. That's the thing. They're currently turned off. Need some copper. So now I'm living off of the volume that I still have in my suit, so the pressure decreases and decreases and decreases. Actually, I don't know quite why it decreases, because it would mean that the waste tank also increases in pressure, but it doesn't. Why is my suit's pressure decreasing even though the waste tank is not increasing? Where is that pressure going? I wonder if there's an implementation error there of sorts.
Oxygen low.
Anyway. So what is it that I want to print? I don't remember. The computer, yes? Let's make the computer then. And then we need the IC10. And then we need a housing for that. There are various ways to do that. I could print the atmospherics kit, that I should show you that anyway, that has a chip slot. So that's convenient. And now I should immediately have the suffocation effects, I believe.
Oxygen low.
Yep.
Oxygen critical.
4 grams only, okay. Well, there's other types of spacesuits, but in particular there's the hard suit, and there's some more suits that developers already made, but have not yet put into the game so that we can actually use them. Ah shit, it wasn't enough. And the hard suit, which is in the game, also has a chip slot, and you can then indeed program that thing so that whenever you're in an environment that's nice, it will just turn off these things and will open your helmet. So where will I place the computer? Here we will have the batteries, and I could have the computer basically right next to it. This version or this version? Let's use this one. That's the computer. Now we need to put a motherboard in there, since we are astronauts, since we're in space, everything has its own dedicated hardware instead of doing that with software. But what motherboard do we need? Well, we need the IC programming motherboard. I think it's the editor. Yeah, IC editor. Need gold and copper. Need more gold. Wait, what? The ingots are being joined when you toss them in. So IC editor motherboard. So let's turn this thing on. Oh, nothing's happening. First, let's cable it up. And you have to cable up the logic too. I'm pretty sure. This is the IC editor motherboard. Here you can select which chip to write to or to read from, and then you write your source code to the chip, or you read the source code into the editor. There's currently no chip connected yet, so yeah. So let's first print the IC10, which we definitely need, there's no question. Steel Electrum solder. Solder. That's what we needed that for. And meanwhile, let's take a look at this guy here. Okay. This is the atmospherics kit, which is one of the most important things in the entire game. This thing here is the air conditioner. I won't explain its functionality down to the detail, but one thing you have to keep in mind, from the right side you pump in the gas that you want to cool or heat. On the left side you get the result, which might be not quite up to snuffs yet, but it will be closer, probably, maybe. Depends on many factors. And on this side, the left arrow there, you will have your waste gas. That is not actual gas that will be pumped, but that is thermal energy that will be transferred into the machine or out of the machine. So it doesn't move gas, it just moves the thermal energy. So for example, you could have a pipe out there which goes up like this and has some radiators, and that is out here, because maybe you want to use that as a cooling solution. For example, but there needs to be some gas in there, of course. If you don't put gas into the pipes yourself, it won't have any effect. Then there is the nitrolyzer, where you can pump in some nitrogen and some oxygen, and on the other side you will get the nitrous oxide, which is one of the gases in the game. Then we have the H2 combustor. You put some fuel gas on the left side, and on here you will get some pollutant and so forth, and super hot, like 2000 degrees water, steam. You can cool that down then and filter it, or first filter it and then cool it down, because the filtration doesn't play well with liquids. And then, yeah, you will have water that you got from fuel gas. And that is very important on Vulcan, which has a mostly volatiles and CO2 atmosphere. So you can use the CO2 to give your plants something, and they give you oxygen, and then you join the volatiles and the oxygen in here to have water, and then you cool it down, which is tricky since Vulcan is very hot and is orbiting a black hole. I mean, not that this actually matters, the black hole is just the fluff. So, and then we have the electrolyzer, which uses water and turns that into fuel gas, pure fuel gas, but it takes a lot of electricity. And then we have finally the filtration unit, which takes in a gas, and here on the straight line it pumps out the same gas, except if you have some filters here in these slots that you can see, that will then make sure that that filtered gas will only come here out to the side. If you have no filters, everything will come out to the left. Maybe I'm mistaken here, maybe it's exactly the opposite, but you can read that in the description of the filtration, and you can also see that with the tooltip when you point at the openings. Now we could use one of these guys to run the chip, but I want to show you the full spectrum of the programming, so I will show you the housing, which has some screws, which is relevant. I mean, the filtration unit, and so they also have a chip slot with has some screws, but anyway. Oh, look how full this is. Even though I only burned 15 coal to make it happen. By the way, after this I think I want to print a solar panel, since we can program these now in principle, so we can point them at the sun. That would be prudent. Kit solar panel needs copper and steel. We need some more steel. And currently I have no copper lying around. So let's get some copper. And maybe I should have made some chutes. So that we can automate the arc furnace fully. Yeah, now the game accelerates a bit. Solar panel. How many will I print? Let's say 2. That's what the copper allows me to print. And now let's put the IC housing up. Here.
Oxygen low.
Doesn't matter where actually. Why is the oxygen low?
Oxygen critical.
I don't know what the reason is here. Oh, my helmet is closed. Really? This whole time? Or shouldn't that have happened earlier? Anyway. And stick the chip in. You can spray paint the housing and spray paint the chip separately. The chip housing is like the logic chips, that it has multiple connectors. This one is for power and this one is for logic. The logic chips usually have 3 connectors, one for power and one for input, one for output, which also allows you to separate cable networks. So you could have one cable network piped in some logic here and the other, you know. And now, when we turn on the computer, we have the IC housing selected. The name shown here will be the one given by the labeler. Default is this one. So I would say let's make a sensor, actually multiple, so that we can measure the indoor temperature and automate the cooling. And I would like to have some more of these guys. Or I would just take them from the outside. It's not a biggie. I mean, the cooling solution is a bit overpowered the way it is. So I will just take some from the outside.
Oxygen low.
That's a unique game if you ever saw one, huh? Damn. Yeah, which means that I could now print these chutes. Let's do that. Which take a lot of iron, but I have a lot of iron, so yeah. Okay, solar panels. Now what's the next step? I wanted to print some sensors. The solar panels will land here. For that I also need glass. I don't have too much glass right now. So it's time that we print some. Do I have the respective materials? Yes, I have, which is silicon, but currently the printer is busy with other stuff. I will print 3 sensors. One to turn on and off the indoor lighting when I'm outside. One to turn on and off the computer when I'm in that cell there to do something, to program something. And one to determine whether it's time to cool the station. Since the cooling is over here, it would make sense to put the sensor a bit further away, as it might think, hey, the room is cool enough, we can turn off the cooling, when in truth the room has not yet quite cooled down far enough. Conversely, if I put it as far away as possible, then I might actually overcool, so it should be kind of in the middle. And there's all of these things you have to consider. You can just, of course, ignore them and just live with the small downsides, but it's fun. It's really fun what this game has to offer. It's just realistic, man. I mean, this thing with the sensor placement, was that programmed by the developers? No, it's just a naturally emergent behavior of the game. That's the way it has to behave. And some indoor presence sensor. Could put that here. Yeah. Oh, I wonder how much it would have produced. Because it still had some iron in there, huh? 10. Oh, let's set that up right away. And the solar panels too, why not? Because I only need 1 sheet of glass for them. So the sun is making this arc. In other words, I would want to put the solar panels in a way that they're not, well, in the way, in each other's way. Here we have a cable from the light. What am I doing? Don't have the solar panels in my hands.
Oxygen low.
Right. And now we can place this.
Hunger caution.
Can place the solar panel where we want. We can see here that they have 2 connectors. A bit tricky to see. Now we can see there's a logic connector and there's a power connector. Power is where the power comes out. They don't need power to be oriented with logic. It's a bit weird, but you know, gamified. And we also have this variant where both is on the same port, and you don't want that with these solar panels. Normally you don't want that. And in this case we definitely don't want that. Well, 108 watts of power indeed, still producing. Okay, where's the cable? I'm not sure where the cable is. Let's just pretend as if I know. Around the corner, here we go. Aha, look at that, it's completely yellow. So this thing is now logic controlled, or is now in the hands of logic. So is this guy. Now we need to make sure that they can output their power. I don't know if I actually have some cables that are in the way here on the ceiling. Maybe I have. I don't. Very fortunate. And further we go so that they reach down to the battery input. See, one is yellow, one is green. And now we're already immediately producing, 0 watts of power. Let me correct that. With the wrench. Of course, that had to happen. The flashlight does not cast any, doesn't cause any electricity to flow in. And the plant light, there's indeed a grow light that we have, also doesn't affect the solar panels. Conversely, the plants are only affected by the sun and by the grow light. See, and currently 400 watts are flowing into the battery, and here too. But of course I will automate this. So we have set up the solar panels. Now let's set up the chutes. There was 2 stacks. One. Pretty sure it was 2. I know I had 2 stacks. What the fuck happened? I don't know. A mystery. Oh, there it is. No, that is not necessarily the same. Haha. Okay. I want to be able to throw stuff in, but this shouldn't happen accidentally, which is a possibility. It shouldn't happen accidentally. Therefore, I will put the inlet up here, so I have to throw stuff. Rotation now is a bit tricky. That's correct. On the left side, we have the inlet, and on the bottom, that's where it goes. Yep. And that consumed 2, because it was a more elaborate chute. And here I guess I will use a window chute, so we can see a bit what's stacked here, you know. Corner. So now I can toss in multiple materials, and they will all be fed in one by one, but I have to push the activate button manually every time. Not necessarily once this thing is programmed, which will be very simple actually. But first I need some more chutes. Oh, that doesn't fly. I have to use another direction to toss. Oh, there's some more chutes. But where is that stack? I know I had 2 stacks of 10 chutes each. And then it was somehow lost while I was building the solar panels. I tossed both of them here. What's happening? Where are my chutes? Well, they're flat out gone. I don't get it, man. Anyway, so I will just toss the materials in here. Here I don't need a window chute because there will not be a stack here. It will not be delayed. It will just spit stuff out, period. Have the chutes fallen through the ceiling into the room? They have not. Where are these fucking chutes? There was a stack of 10 chutes. And I don't have them on me. I put both of them on the ground out there, remember that. Well, let's print some more then. How many do I need? The cable might be in the way, I'm not sure. It is actually in the way of me building this now, but not of the chute itself. Wrong. First take the battery from the charger, then the chute battery. Oh, I cannot point this upwards. Oh, that's awkward. I hope it won't toss them directly into the manufactory, because that would also be pretty awkward. So the computer's, like I said, consuming 200 watts this whole time. That's quite the waste. This thing consumes 50 watts this whole time. And this guy is already less full than it was before. So first step, let's print that missing sensor for the daylight direction. Right, so it's just sensor. Let's just put it here.
Filter low.
Yeah, the filters are low. Let's work on that problem. And print 2 new ones. Dioxide. Here we go. Needs iron. The filters are always used up from the left to the right. That's not important, but I like to keep things neat. And what do I do with the used up filters? They're garbage, right? Not quite. You can put them in the shredder, and the shredder will also spit out some brown balls, a different type of brown balls. And, well, that can then be put into the centrifuge and you get some of the materials back. Okay, I will first do some fast programming moves and then we'll explain a few things. Here's our editor. Here with F you can see all the functions that exist, and it looks like it's a lot, but many functions are composed. We have the B as branch somewhere, we have R as a branch relative, other branch commands don't have the R. So that's already a composition. We have a composition of this and of that, and then we have EQ, which means equal, or GE, which means greater than or equal, or GT, which means greater than. So composition, 1 element, 2 elements, 3 elements. And there are multiple variants of this, and this one is either there or not, and this one is, well, it's just branch. And then here we have Z, for example, which means 0, so you don't need the third parameter. And so forth. So it's not really that many commands. Also, you don't need to know all of them. Case in point, I don't know all of them. Then here we have some values that you can look up. And here we have some keywords that you can look up, but over time you will just remember them. And this is just to make the thing transparent. I'm not sure if this works, let's see. Yeah, that works. So now the computer turns on only when I'm nearby. I will explain a bit first. I will explain a bit later, not right now. Okay, this takes care of the lighting. And there was the gas sensor. Oh, it is already connected. It is. And then we have the pipe analyzer. And I want this cooling solution to work automatically. Oh, and a thing that I should show you while we're at it. Let's remove that guy here. Because we should make a passive liquid outlet. I'm not sure which one that was. I think that was kit drain, yeah. Again, no copper, huh? So here we have the passive liquid inlet that I already mentioned in passing. You connect a pipe network to it, and if there's some liquid on the ground, or maybe some in the air, I don't know, that will be sucked in there. When we didn't yet have liquid in world water, but when there was just a fog that was spreading out, what I did sometimes was I had some water container here, and I just, you know, pumped all of it out into the air. And then over here, I gathered it all up again until the air was completely dry again. Haha, okay. Then we have the active liquid outlet, which has a power connector and a logic connector and a switch and a liquid connector. So you can connect it to a pipe network, and then when it's turned on, it will pump out the liquid into the air, into the ground basically. And then we have finally the passive liquid drain, which is of interest here. Let me demonstrate why. So now that we have a pressure in here of several megapascals, we can see the pipe stress is increasing because there's some liquids forming inside of it. Here you can see that is kind of raining down. This gas is raining down, as in is becoming liquid. This is the liquid that it has become. Now everything, all the pollutant that's in there has become liquid. The pipe stress is fine. It's once it reaches 100%, the pipe will start taking damage. Before it won't. But we can get that liquid out of there just with the passive liquid drain. See, the liquid is reducing and reducing and reducing, and it's gone. So that protects this system here from there being liquefaction of CO2 and such. It will just seep back into the station. Otherwise the pipes take damage. So that's a good thing to have. Also, I think you have seen enough now that this will tell you that you can build an air scrubber purely by using pressure and such a thing slapped there on the outside. I will say no more. Now let's make sure that this cooling system works by itself. First let's... Well, I can actually... Oh wait, this is cooling down further and further, right? Yeah, let's pump it out again. Not something I want. Okay. How can I program this now? I'm not sure. I think I should just program this now and then later explain why I did what I did. Because I've never done it in this way so far, maybe with good reason. Well, who knows. And where's my labeler? There it is. But also some people might be further along and they just want to see the goods, you know. Also, it's pretty late. I mean, I should stop this video now, but I want to explain some parts about programming first. So I would rename this cooling. I want a systematic naming convention here. So let's say this is analyzer for the cooling system. Then we have the vent for the cooling system. And then we have the sensor of type gas for the cooling system. As you can see, you can use Ctrl A to select everything, Ctrl C to copy everything, and Ctrl V to paste. Normal clipboard operations. Maybe I should explain a few things here. Okay. I am accessing devices. There's the motion sensor, for example, that I planted on the ground. And with this, I'm reading its value. Which value am I reading of the sensor? The activate value. Here you can see the values that they have, and activate is when a sensor has been, well, is on, when it's green basically. You can see here it's green currently. No, it's not. This thing is green currently because I'm still in the room. No, it's not. And I can read out the activate value. However, why does this, what I've written here, read that sensor? Couldn't there be a second such sensor? Indeed, there could be. That is why this command, L as in load, is of the LB variant. I'm not just loading a value, I'm loading a value batch. So if there's like 10 motion sensors, I'm loading from all 10 motion sensors at the same time. And I'm reading the value activate of all of these 10 or so motion sensors. And if there's more than one motion sensor indeed, let's say there is 10, then all the activate values will be added up, because there's some here. You could also say maximum. So if only one of them has someone walking through its grid or being in its grid, I will read a 1 here. Or minimum. So if even one of them only is not occupied, I will read a 0. And finally we have the average, which is useful when we want to read out the station batteries and want to show their values on a diode slide, which I will not do right now because we have our diode slide right here. If I would have multiple batteries, then that would make sense. Maybe I should try to put to do the. I mean, I will explain more, but first I want to read the solar panel. We'll just pause this. Now the game is paused. I will load into. Okay, now I have written this text here, but I can do that up here too. Define sense motion hash. Wait, why doesn't this work? Oh, yeah, right. I cannot use underscores and names in these variable names here. That's too bad. This is an identifier. And this is also an identifier. Here too I cannot use an underscore. And this is of course a label to which I can jump. Here I'm jumping to start. So this is being executed infinitely often, but it's not executed at infinite speed. That's what this yield does. This yield means that I wait one game step, which is half a second. And if I would have no yield here, this would be executed at infinite speed basically. But only 128 different 128 executions. This one, and so forth. And then the game would say, dude, that has been quite enough. I will just force a yield now. This might be here, for example. And the next iteration, it might be here. The next iteration might be here, depending on how we're landing on the 128. And so there's a yield anyway. In other words, we usually just have our start marker and then we write yield and then we do our stuff, because there's going to be a yield anyway and I want to be in control of where that is. Also, why would I execute this 20 times before I have a yield? I mean, I will not ever read a new information here, or the setting here, like turn the light on, will not ever take effect before not the game step has completed. And so we write a yield here. So the motion sensor, I have used that here inline, but up here I can just define that as a number, so I can then use the keyword here. That's not necessary in this case, I'm just showing you that. The gas sensor might be... that's a different thing. By the way, how do I know these names? Simple, let's look at the gas sensor. Here we have the kit sensors, and you have the gas sensors, the structure gas sensor, click done. And this here I could also copy by clicking on it, but I won't, because that doesn't tell me much. There. And hashing this is the hash function, turns that into that very number that I now did not copy explicitly. I could have put the number here too instead of hash structure gas sensor. But I mean, you saw me program all this stuff here. Can you remember that number? No. But can you remember this simple concept, structure and then blip, structure and then blip? Yes, you can. And so that's why I always use this approach. This is not necessarily the one approach to do it though. We also have these screws here. This is directly 0, directly 1, directly 2, directly 3, 4, 5. I will just attach the battery to the logic circuit, to the cable network with its logic, so that it is controllable, and also so that it shows up if I use the screwdriver now. Before it would not even show. I will just use this screw, it doesn't matter which one I use. So, if I click here now, I will switch to the pipe analyzer. Now I have switched to it. The next one I switch to is the arc furnace. Now I've switched to it, and so forth. I will switch to the battery now. Station battery. Now I have the station battery selected, the next one will be vent cooling. If I click again, whoops, too late, but I can hold the modifier key, and then we're back at station battery. And now I will just say in my source code, write to D0 off on 0. So the on logic value, the logic value that is called on, of the station battery will now be set to the value 0. And that was not too wise, because now I have no power, for example, to run the computer. But thankfully I didn't do that in a loop, otherwise I could have just have turned off this guy, because then it doesn't have effect. Whenever I write the source code, the entire script will be executed again from the start. But you already gathered, I guess, that R0 is a register. We have 16 of these, up to R15. And they hold their values. Even if you save the game and load the next day, if you start up your computer and then load into Stationeers, that value will have been remembered. So even though the entire source code starts over when I write it again to the chip, the values, they are persistent. That is sometimes important. So I could just write to the screw that this battery shall be off. I could also load into R0 the... yeah, let's do that. Load into R0 from D0 the ratio. There's even a help here. If I just type this, you can see that. And if I hover here, it will tell me also what that does. Loads device logic type to register by housing index value. Okay, this is not the way a human would think or speak, but I mean, if you already know your way around, then this will give you the necessary pointers so that you find your way. So I'm loading the battery fullness ratio from 0 to 1 from whatever is connected to D0, and if that doesn't have the logic value ratio, there will be an error. Into register R0, and now I can say write to the device in which the chip is housed. That could also be the atmospherics device. I could also turn the atmospherics device on and off or whatever. But now I'm writing to the housing, and I'm writing whatever register R0 is holding. And this is happening in the loop. So we can now see here that the battery has 48% and is currently being charged up. Useful, because, you know, the solar panels are currently delivering power. So SDB setting R0 writes to the chip housing thing, the setting value, and R0's value. R0 was the ratio of the battery. But let's use the screwdriver and screw things up. Why is this still working? I don't know. Ah, now there's a problem. Okay, and now it's saying error, incorrect logic type at line 10. It's of course clear which line that is. It's the line that tries to read from the battery. It's of course the line that is affected by this screw that I just screwed up. Oh, and now that the script is not running, everything is down that would be running on this chip. So there's something to consider. I will just delete this because you have seen what that does. And write again. And now we're fine again. So you have 3 ways to address a device. 2 of them I already showed you. One is you use the device type, and in addition you can also use the name. I will use that soon and show you. The other is we can use these screws, but then we're limited to 6 only, except if we use multiple chip housings and then the chips talk to each other somehow. That's possible. And funny. State 0.5. I stopped that exactly at 50% of the battery. That's basically impossible. Anyway. And the third one is you can write directly once you know the ID, because the game has a number for this room. That is irrelevant to the topic, but you know, it has a number for this room. It has a number for the pipe network, but in the same way, it has a number for this thing, for that thing, for everything that is here, for everything. And the things that are logic programmable and are connected to the respective pipe cable network here can then be written to. You can say, how do I find that? Well, there is a configuration cartridge. Fuck me sideways, I don't have copper. So let's look at the battery again as the go-to example. This one has the following configuration. Here we have its reference ID. That's the very number I was talking about. And using the scroll wheel. By the way, if you're using the tracker cartridge, you need the mouse wheel too to select which target you're trying to track. I forgot that. Anyway, so here's the reference ID as the number as we know it, 5903. And as a hexadecimal number, that is written like this. You can write this in your source code or you can write that in your source code, doesn't matter. But 5903 is the number. And I will now try to use that. Write directly 5902 on 0 to show that I'm indeed addressing the battery. Export. Problem. Device not found at line 5. So this number that I just thought up is indeed not in use, or at least not a device that can be found here. You have seen that, yes? So SD writes directly. Load D loads directly into R0. Write writes to D0, D1, D3, and so forth, or to the housing itself, the setting, you know. And we have SB, which writes to all the lights here that they should be on, but only the lights of this type. If I would have chosen some other light types at some point, then that would have been a different world. And then we have SBN also, that's the one that I want to use next. So we have the gas sensor, and I can now, I have this, wait, what am I doing? Sense, gas, cooling. Okay, I need a different name here. Too bad the program doesn't complain. I'm writing this not as sense, gas, cooling, you know, when it comes to upper lowercase, because you see that the words that the program itself uses are already like this, uppercase and then lowercase. And so by writing it in this way, I'm avoiding any potential collision. Okay, now I want to know the station temperature. Load batch named into R0. From this device type and this device name, the temperature, and since it's a batch command, I have to give one of the 4 modes, which is minimum, maximum, average, or sum. I always use sum because it's short, easily written, and if I have accidentally multiple devices that I'm accessing there, then I will get a number that is very wrong, and this means I will detect the error early instead of at some point wondering why is my station on fire, you know? So, well, I read that value, I know something's wrong, but it's intentional. I will now write that to the setting of dB, so we get the station temperature in Kelvin here, but this doesn't work. We have a 0 here. Why? Because I wanted to demonstrate something to you. What I demonstrated is that this is indeed only reading from from the thing with the respective name. If I just use this, now I'm reading from all gas sensors together, not from this one, because this is on a different cable network. This is its own separate cable network. To separate cable networks, you use, for example, this device. Power is coming in here, power is coming out there. That's a new cable network. So I can now read the gas sensor, but I want to, since gas sensors are a very common thing, I wanted to filter down to the name that I had given it. So let's use the correct name that I have given it and say load batch named. Wait, that was wrong. Load batch named, and then paste that again. And you have seen before when I had this in here, it was reading a 0. Now it will read the correct value, because now I'm using the correct name. See, now I'm filtering this down. So in this way you could also say some solar panels are placed like this with the logic on that side, and some solar panels are placed the opposite way because I wanted to save on cables. How do I write their orientation now? Simple, by filtering them by name. You name all of these 1, for example, and these 2, just the digit 1 or 2, whatever, and then you use the then you write to all of them in this filtered fashion. So you write SBN, and then of course you don't have the R0 first, because I mean every command first wants to know where does the data go. Here, S writes to DB, load writes to R0. That's a way to remember that, you know? Alright, so now we have the temperature, but I want that in Celsius. Oh, that's simple. Subtract the target is again, because the first thing is always where does the data go, into R0. And what do I want to read from R0? Remember, 0 degrees Celsius are 273.15 Kelvin. And so if this room currently has 273.15 Kelvin, and I subtract from this value that value, then I will get in R0 Celsius. And what do we have? 41 degrees, like shown down here. So now we have a precise temperature, and that's what we want to control our cooling system. But I also need the pipe pressure. So I will define another thing up here, and that will be the pipe analyzer. Structure pipe analyzer, and here the developer team made a mistake. They wrote it like this. That's something you can see in the Stationpedia, so it's not a secret. It's just, you know, that's how you can remember that. I want to use the pipe analyzer, so I write structure pipe analyzer. Size. Let's put the word size in there. You know? Okay, that's the type. And now let's use the pipe analyzer for cooling. I gave it that name with the labeler. And what is happening here? I'm defining a constant number that will then be in this word that I can just write here. This is a number. And the number is generated with a hash from this word, or here from that word. So you don't have to bother with the thought like this is about the type and this is about the name. Functionally, that's the same. You're just turning a word into a number. So now I want to make sure that the pipe analyzer is on. So I write batch named to the pipe analyzer type, and then to all the devices that have this name. Yes, I could also have other devices that have that same name. It doesn't matter, it's just a filter. A combination of this condition and of that condition. I want to turn that thing on. Another thing, I also want to lock it. Why? Because I don't want to accidentally, as the user that I am, the human, I don't want to turn that off. You heard it just turned on, and now I cannot turn it off. The tooltip is saying cannot interact as device is currently locked. How much hard disk space do I have? 150 gig? Okay. Okay, now I can read this thing and it will never have a wrong value because it will never be off. If it's off and I read the pressure of the pipe, I might get a value that's completely untrue. The vent is already there. Okay, let's add the vent into the mix here. Structure active vent. And there's the vent cooling. So, what is it that we want to do now? The station has 42 degrees centigrade. That is too hot. I want the station to cool down to the temperature of 25 degrees. How do I do that? Well, first of all, there are subroutines. I could say JAL, subroutine, or my sub or whatever, and the subroutine would be down here, my sub, and then I jump back to RA. I told you we have 16 registers. That's true. However, there's also SP, the stack pointer, which I'm not gonna go into this time, and we have RA, the return address. And when I do jump, I jump unconditionally. But in this case, jump AL, I also say remember where we were, and that is written into RA. So JAL remembers the position, and here I jump back, not here, but here. This is where I end up being. So this allows me to call this like 10-20 times, every time with a different current value of R0 and whatever, which then this subroutine can work with, and then it can jump back to where we came from. This is not the approach that I want to use this time, though. By the way, and if you want to jump from this subroutine to another, you first have to save RA, because, and then, of course, wait, my sub. Basically, you can say move into register R10 or whatever, or R0, RA. So you have written this value now here. It's a copy command. I don't know what's called moved. That is how it has been already since 68K assembly times in the 1980s. So that's normal assembly language. It just copies that value here. And then down here I can just say jump R0 because that's the same thing. It's not a special register or whatever. It's just a number. And in here then I can say JAL somewhere else and then return, and then it will end up here. And I can return down there by jumping RA because RA is then valid. But I mean, this overrides RA. And so if down here I would say RA, I would end up here again. That's not good. So anyway, but I don't want to use the subroutine approach here. Instead, I just want to make a block of lines here that belong together. And then when that is done, we are still here. We're just flowing from the top, blah, 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 executing everything, and we end up down here. Oh, by the way, we have this arc furnace here, right? Let's automate the arc furnace, which is very easy. Define arc hash structure arc furnace, and then I will not use the named approach because how many arc furnaces do I have here? And then I want a load batch named load batch slot. There's load batch named and there's load batch. And there's load batch named slot and load batch slot. And there's even load slot. There's not load directly slot for some whatever stupid reason, but I could load, you know, from a screw. Could load from a screw. What is slot? Well, the devices like the arc furnace, some of them have a slot or multiple slots. You can see here we have the slot index 0 is the import slot. That's where the stuff goes in. And export is where it goes out. And here are the arc furnace values. For example, activate, which is the button. If I write a 1 here, the thing will start burning. And here I write a 1 to turn that thing off. And I can even read out what type of thing is currently the in slot, which is where it will be smelting then. So I could show that on a display. That is also possible with the hash display, which is for the console, the thing that I have there in the airlock. So I want to break free. No, I want to load from the arc furnace, from the slot. Slot index 0, whether it is occupied. And then I want to write to all the arc furnaces that I have on R0, and I want to write to all the arc furnaces that we have activate R0. So yeah, that is all. This will read whether something's in the slot, and it will turn off and on the arc furnace accordingly, so now we're even saving power. And let's use something that it can reasonably toss in there. Yeah, let's use iron, why not? And now it's burning. See, the arc furnace is now automated, and at some point the iron will come in here. That's convenient, huh? Okay, where was this thing? There it is. I want to fix up my tablet again. So let's reiterate the source code that we have. Up here we're defining some constant numbers that the computer knows what to do with. I'm defining the type, structure, motion sensor, so that I can turn on the computer if I'm in this sector. And the gas sensor, and I have given the gas sensor a name, so I'm turning that into a number 2. The pipe analyzer, also type and name. The active vent, type and name. The arc furnace. Oh, did you hear that? There it is. Thankfully it didn't land in there. But if I have an entire stack of stuff that I toss in here, I guess it will, you know, push that over. Hey, I wonder if that can actually be simulated. Is it now smelting 15? It's re-smelting the ingot, that's funny. Should be pretty fast, I think we can observe that. Let's stay here and look. Okay. I wonder if it can resmelt the steel. I've never tried that. No. I never tried to smelt a steel ingot with the arc furnace. This is the first time in 2000 hours. God damn it, it has turned the steel into a reagent mix. To get this thing to be steel again, I have to... See, that's something that can happen. Sometimes you fuck up your mixture, you know? And then you will only get some brown goo. You can toss that into the centrifuge, and then you will get the pure materials again. The ore type, not the ingots. But what if you have a material that is advanced, where you put in as some one of the source materials an alloy, like steel, like this stuff, when it was an ingot still. And then you fuck up your mixture, and then you get some brown bars that you toss out. All of that you toss into your centrifuge, you run the centrifuge, but do not stack the stuff that the centrifuge is outputting. If the centrifuge is outputting this stuff here, do not, I mean, if there are multiple of these, do not stack them together, do not. Instead, heat up your furnace, toss this thing into your furnace, out comes the steel, or out comes whatever alloy that was. But if you stack them together, that won't work, because then again you have a mixture in here, which then of course outputs something meaningless. So whenever you have this here, just throw it into the furnace when it's hot enough. I think 100 degrees might be enough even. I'm not sure. It just needs to go through the slot, I guess. And then you have your steel again. It was only 10 steel, so it's not a big loss. Okay. And so forth and so forth. Then we have our start marker, and the program will just run, will execute this, blah, 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 blah. It will arrive here, and then it yields. This is where it actually waits half a second. then it will read the motion sensor and turn the computer on accordingly. If activate is 0, the computer will be 0. If activate is 1, so I'm currently in this field here, the computer on will be 1. Occupancy sensor for the lights, same thing. And here I'm doing that with the occupancy sensor again for some reason. I don't know why exactly. I think I was building up to reading the gas sensor, so let's delete that. Or maybe that was supposed, yeah, that was supposed to be the daylight sensor. Yeah, let's do that. Let's do the solar panels while we're at it. So, yeah, for that I wanted the daylight sensor to be up here, because that word will repeat also. Sense daylight. Or sense day. Structure daylight sensor. So the vertical angle, I'm reading that into R0, and then I'm writing batch to all. Actually, don't know what the hash is for the solar panel.
Hydration critical.
I think that's the one. We will see. If it does nothing, then well, let's see. If you use D0, D1, or this direct writing to the identity number, then the program can throw an error that can be useful or it can be a problem depending on how you look at it. If you're using these batch commands, you will not have errors because it will just take whatever gets hit, and if nothing gets hit, then nothing happens. That can be good, it can be bad. Your choice. I prefer this approach. Alright, now I'm writing the vertical and horizontal values read from the daylight sensor directly to the solar panels, and that's probably not correct. Aha, now they're moving immediately, that's good. Where's the sun right now? Well, it's currently night. It's dark out there, and the Earth is not lit from this side, so it's maybe the sun was just... I don't know, it's hard to tell, we have to wait until the sun is here. But one thing is for sure, I mean, look at them. They are moving in this direction. You can see that. And we can say the sun is definitely not up there. So for whatever reason that I can't fathom, the vertical angle is kind of inverted or kind of rotated or whatever. I don't know why that is. But when I now correct this and add something to it, there's also the consideration of the horizontal angle, because maybe the horizontal is basically turned by 180 degrees. So if you think the vertical is moving wrong, I have to subtract that from 90 or something so that the motion is opposite. The reason that it is opposite might actually instead be that the horizontal is turned by 180 degrees-ish and then has to turn by 90 still or whatever. So yeah, that's a bit tricky to figure out. But, I mean, one thing I can certainly do, I can say add R0, R0, 90, and then see what the solar panels are doing. Okay, that looks more right. But the sun will move this direction, right? It will move up here. Huh. And we just saw them move this way, further and further and further. So the direction is wrong. I mean, the most reasonable approach is to first go and say, I will rotate the horizontal. Add R0, R0 180. So the Earth is now lit a little bit, so I guess the sun is like over there, for example. We can even read that here. The vertical angle is 140, now it will be 141. See, the sun is going down. 0 is noon, 180 is midnight. However, it might not reach actually noon or actually midnight values, but that's the rough area. That's how you have to think about this number range. So it's moving towards midnight currently, since the number is increasing. Okay, and these guys are now, you can see that they are moving basically in the right direction, but they should already have moved there quite a while ago because the sun is already down. So I guess adding 90 is the way to go here. Now we won't see anything. Yeah, that too, of course. And at midnight, when this begins to go up again, this value, I mean in the direction of 0, then these guys in just that moment should basically turn by 180 degrees, because that's when they basically prepare for the sun to come up again. By the way, you can program this stuff intelligently so that when the sun is no longer there,
Temperature high.
you would they can already
Power critical.
turn around to prepare for the morning. Why would they? Because it could be that that the power is out. We actually have that situation here. The battery is pretty low, and we are drawing 50 watts, 100 watts, 150, 200, and so forth. There's a lot of energy, and I'm also programming here. This is 200 watts. There's a lot of electricity being drawn here. And if my station is without power and the sun comes up, I don't benefit. The solar panels will be over here. They will stay there. Then the power is out because no more power is coming in. The solar panels are stuck there. The sun is here. It's not giving me any electricity. Eventually it arrives over there, but that's too late to give me any considerable juice. So to prepare these to be pointing towards the morning, even if the station is without power, it would be woken up by the sun coming up again, and then everything will be saved by that. So that's not a bad thing to do. Anyway, I wanted to deal with that cooling solution here, so let's do that. We have the station temperature already in Celsius, and now I need branching. That's why I was talking about these branching commands. But first, what are we doing? Computer automatically, light automatically, solar panels may be done automatically, who knows. Then the arc furnace automatically. I want to keep that bundled together, you know. And here we're dealing with the temperature, and so I will just combine these into one block. This is kind of the headline. You can also write some comments here, also at the end of the line, but not after a label. That's not allowed. But that's not what I want to do here. Also, careful, you have a limited amount of lines, and if something's written down here, and you don't consider that when you're inserting some lines up here, it's gone. It's gone for good. I mean, if I say cancel now, fine, nothing's lost. But if I say confirm, it's gone, yeah. Something you have to keep in mind. But the source code is in the save file completely, and if you have a previous save file, you can just open the text file, copy that part of the source code completely line by line, it's a multi-line thing, and paste it back here. And that's not a cheat. By the way, the copy and paste command, they copy the entire source code, so we can edit this with an external editor, and paste overwrites the entire source code, of course. And clear deletes that. And library opens your personal library of source code snippets, which I also have, but I don't use those. I always write everything in new, for whatever reason. So, that's not how I do that at the job, of course. There I have a library. Okay, the pipe analyzer, I want to know, I have the pressure, the temperature now, the temperature of the station in R0. I can also do something I show you now. Yeah, let's actually do that. Let's do that. You have already seen define, but there's another such command. Henceforth, I can use this word to refer to this register. I can still use R15 directly, but that would be ill-advised. And why am I using R15 here? Because R0, R1, R2 and so forth, these are my temporary values that I work with. But R15, these are the ones that, and R14 and so forth, I grow downwards with the labeled ones. Okay, while I'm at it, I have read the station temperature into... Oh, okay, that was wrong. So into that, I read that, and see, that's why I normally don't use these aliases. I normally don't do that. Because this gives me, by color and by the text written here, R0, it stands out, you know? Gives me a very clear indication of what this is. But here you can get kind of lost in the forest. We have load batch, what now? See, that's why I'm trying to avoid that normally. Now I also want to read the pressure. The pressure is always all logic values that you read when it comes to temperature will be in Kelvin. All logic values that you read when it comes to pressure will be in kilopascals. So, for example, the station pressure is 44. Yep. Load batch named into pressure, sense gas cooling pressure. Okay. Now I want to read also the cooling pipe system pressure. So I just prepare my values. It's not necessary for me to do that at all times, in all states of the program, basically. But I'm gonna do it because I don't care really about being efficient here. Pressure. Now I have the pressure... Wait, that was wrong. Load batch named sum. Now I have the pressure of the pipe. Let's see if that is actually a thing. SDB setting cooling pressure. And then I will put some pressure into the pipes. Currently it's 0. Now there's some pressure in there, and yeah. Now it's decreasing. Why? Is there a leak? No, it's cooling down. That's why. Almost done with our cooling solution. Okay, now we have to do the actual logic. I will now compare the station temperature. And that's this B that we had in when I gave you this overview of all these commands. Branch if greater than. And now how was that? I think the first thing is I have to give the label where it shall branch. A, B, C. Branch to line C if A greater than B. Now, okay, the first thing is A greater B thing, and the last one is where to branch. The A is the temperature. The value is 25 degrees Celsius. And room to hot is where I want to jump. See, okay, this here is when the room is not too hot. And this is when the room temperature is too high and I need to drink something. Is some power coming in? Where's the sun? The sun is there, and the solar panels are currently delivering power. They're pointed correctly. It looks as if they're pointed correctly. We can see here what power is coming in from this solar panel. That's very useful that we can see that from below here. And maybe I should introduce you to the concept of cable analyzers.
A Sum FM t-shirt yet? Well, you need one. So go to sumfm.com/t-shirts. They're available to our supporters at the $15 support level. You can see some pictures of some of the other people who've gotten their Sum.
No more copper again. Shit. But okay, one is enough to demonstrate. I could put this now here to see what overall power is coming in. We have 1500 watts of power coming in, about 1000 watts from our dynamic solar panels and about 500 from the non-dynamic one, and that will now keep decreasing because, or maybe first increasing and then decreasing, because it cannot adjust where it's pointed at. This one is delivering basically 100% efficiency, so we have correct solar panel source code. Nice. So now we have actual power that is being delivered to our station, more than 1000 watts right now. That should keep us afloat, I think. I mean, this one should become stable any minute now. But will this last through the night? I don't know. We might have to burn some more coal. I don't know. I still have some coal. Then I would have to put up some more solar panels. Not today, though. This video has been quite long enough. Anyway, so we want to make the room cooling too. So branch, if greater than temperature is greater than 25 or greater than or equal. I mean, it's a floating point number. Who cares really about that infinitesimal difference? If the temperature is greater than 25, the room is too hot and then it jumps down here. If it is not too hot, we will just keep flowing along here and afterwards we jump here. So if the room is too hot, we jump here and we end up here. And if the room is not too hot, we flow here and we end up here. So that's a good structure. So let's say the room is too hot. Then I want to, I want to write to the active vent that it shall pump some gas into our cooling system. For that we have to do three things. First, I want to write to that thing that it shall, that it shall be on. But shall it be on unconditionally? No. What's the condition? The condition is the pressure. If the pressure in the pipe system is less than, let's say, 2 megapascals or 3 megapascals, or let's say 2 megapascals, then R0 shall be 1, because that is what this is. That's yet another new command I'm introducing it to. S writes a logic value. Where does it write that? Into R0. What logic value is that? It's if less than. And we also have greater than and greater than or equal, the same stuff again. See, that's what I said. We have many commands here, but it's actually not that many. So write into this thing a 1 if this condition is true. What is this condition? The condition is if cooling pressure is less than 2 megapascals. Kilopascals times 1000 is megapascal. So, write if less than. Write into this register AB, if A is less than B. But we have to do a third thing, and the third thing is we have to write the mode of the active vent. That is in the documentation of the active vent, which I will not bother to open now. 1 means suck into the pipe network. Here, there's this ominous switch. Set inward. If I click on this thing now, it will do what it says. It will set that to inward. So this is not a past tense set. It has been set to inward. No, this is the future. I will set that to inward. Now it is set to inward. So if I turn this on now, it will suck from the room into the pipe network. Inward, that's what that means. Set outward. Now it would suck from the pipe network into the room. The default mode is outward, which is 0, and mode 1 is suck inward. At some point you will know that. So I'm telling the active vent, suck into, and I'm saying turn this on only if there's not yet gas below, if the pressure in there is not yet high enough. And that is already what turns on the cooling. So we're done here. The cooling is done now. We can jump back to start, yield, do all the other stupid bullshit, and then we come down here again and check what the room temperature is. And let's say that room temperature is now no longer too hot. What do we do then? We empty the pipe network. So we suck into the room, we turn that thing on, but we only do that if the pressure in there is greater than 0. And there's a special command for that, like this. So I mean, I could have done it like I just did, but this is dedicated command for things that involve a zero. That was developed like this back then when assembly language was invented, because every memory access slows down the processor. And so if it has to look up in memory this value here, that is a memory cycle. But if I write this instead, I can just use the information that it has already gotten, which is the information which command to use. And if there's enough bits in the command expression, in the thing that expresses which command to use, so that we have some left, then we will add some commands that also have 0 as the special value, because that is a very common value. And so we have a processor that's faster. So that's irrelevant in the game context here, but that's the reason why these commands ultimately were invented. So, greater than. If cooling pressure is greater than 0, this here will be 1. And so we will suck into the room. Otherwise we won't. This is the cooling solution. The entire cooling solution is done. Now we have this pressure. We see that it overshot a bit because every game step it sucks a certain amount of gas into the pipe. Now that is cooling down. This will lead possibly, since the room temperature is rather high, to some liquefaction in there of the pollutant due to the high pressure, and maybe even of the CO2. However, as soon as anything in there becomes liquid, and O2 and nitrogen are far away from becoming liquid, that's like around minus 200 degrees Celsius, it will come out here, now, you know, where the liquid would bleed out. So the cooling solution is safe, and it is also effective. At some point the pressure in there will have fallen, since it's cooling down, and the colder it gets, the less pressure is in there, of course. And so this means that this thing will kick in again, suck more gas in there, because we're no longer at 2 megapascals. Anyway, the room is now cooling down, and when the room has reached no longer higher than 25 degrees, then the branching will not take place. Instead, the commands directly after that will be executed as the next commands. And what are those next commands? The commands are write into register R0 whether the pipe network is still greater than 0 in pressure. If the pressure is still greater than 0, that will be a 1 in our register R0. And so the active vent will then suck into the room from the pipe network. But once the pipe is actually empty, it will stop sucking. But as soon as the room temperature is higher than 25 degrees again, that entire cycle starts over. The cooling solution is done. It's not super effective, but it's strong enough for our purposes. And we can open the helmet again. So we're now finally in a situation where we have a station temperature and pressure that is fine for us to breathe, and the CO2 here, oh, that's a bit unfortunate, and the CO2 here is also high enough for plants. So as the last thing that I do in this video here, I will show you how to plant plants. You can see here that I already supplied these with water, and we have pressure here, and the temperature is between 20 and 30 degrees, which is also ideal for plants. The cooling solution is not that strong. This here is the two cooling solution taking place, yes, but we fell down to this because I just melted another stack of oxide to have higher pressure, you know. But let's plant some stuff here. And I will not plant all the plants at once, which you should normally not do, because these seeds are irreplaceable, except if you do trading and are lucky enough to get an organics trader. So it's not saying that the potato is thriving towards fruiting. It needs a certain amount of darkness, it needs a certain amount of light, but all of that is, these conditions are met here since we have glass, and since we're on the moon where the sun is strong enough, and since we have this 20-minute day-night cycle. If I would have custom day-night duration, that would not be the case, and I would have to protect these from the sunlight, since if I want to have custom lighting for them by the, where is it? Where's the plant light? It should be here somewhere. The grow light, where is it? I wonder, it should be... Ah, there it is, the grow light. has its special own blue light, you know. You can also accelerate your plant growth a bit if you turn on the grow light simultaneously when there's daylight. And one way to do that is, of course, to ask the daylight sensor for whether the light, the sector where the daylight sensor currently is lit. Because that's a value you can read out. But you can also say, I want to turn on this light as long as the angle of the sun is below, like for example, 90. I will now add this here. So the daylight sensor vertical, I will turn R1 a logic value less than. If R1 is less than, no, if R0 is less than, let's say 110, so it gets a bit more light. Then we have a 1 in R1. Now I write to any and all structure grow light. On R1. So now we have that as a supplementary light source. Now we turn this on, and you see it turns off again, so it is now currently under the control of the chip, and I just caused some stress for the plants. I was talking about the plant analyzer cartridge. Let's print that one too, so I can show you. Shit, we have no copper. No copper whatsoever. Okay, that's really unfortunate. God damn it. I mean, I have some copper there, but I wanted that for my smelt, which I'm not going to do in this video anyway, but... well then. How much do we need? Again, how much do we need? 5. Okay. But let's turn that off. And maybe I should burn a little bit more coal, because, I mean... we are burning through too much electricity here. I need to put up some more solar panels, which I'm not going to do now. So let's smelt some of the... oh shit. That wasn't good.
Power low.
I should have done that from the indoors. I forgot I have this automatism now. So the plants, they need, I mean, it depends on which plant we're talking about. Potato needs, these are the parameters for the potatoes.
Oxygen low.
And they need, for example, a certain amount
Critical.
of darkness and light. Is it still burning stuff? No, it is not. There it is. So let's look at those plants. Alright. You can see the grow efficiency is 98%. Very good. This growth efficiency is a summary statement. This summary statement emerges from the breathing efficiency, which is itself a summary statement, and from the temperature efficiency, which is also a summary statement. So we have the actual value of the temperature, which is within the range of the min and max ideal temperature. So the summary statement for these 3 data points here is 100% temperature efficiency. Then we have the breathing efficiency, which pertains to the to this stuff here. So it's a bit unfortunate that is not listed up there, but down here. And that is a summary statement for those data points. And then we have the pressure efficiency, which is the summary statement of these 3 data points: minimum, maximum, current. So the summary of pressure efficiency, temperature efficiency, and breathing efficiency, and actually the light efficiency also, that summary currently is this. And that is then how good the plant, how well the plant grows. And that is then broken down into statements like thriving, or growing well, or barely growing, or growing not at all, whatever. Okay, So we have seen these values now, all of them, all of them, all of them. Now here we are at the light efficiency. Illumination stress is caused by illumination change. So when I turn on this grow light, see, that causes stress. And so this causes the light efficiency to go down, and the growth efficiency now has also gone down. Currently the light intensity is 0. And at some point that you cannot see here, if I keep the light off for too long, illumination stress will go up. Why? Because the darkness deficiency will say in red letters dark deficient. The light deficiency will say light deficient. And this keeps counting up. And the higher this goes, the further down the light efficiency goes. And so the further down this goes. If the light situation is fine again, then the illumination stress will slowly count down again. So the light efficiency will slowly restore to normal values. So this will slowly return to normal values. That is how this works. Complex, complicated, but ultimately simple. Because we need to do nothing but wait. These plants will they will grow properly. And then this, it's all set up properly. We're fine. Yeah, what's the pressure here in our cooling system? None. So yeah, it worked. Now, what about the plants? They will grow to the stage that you have a potato here, or two if they have grown well, which most of the time they do. Then you can click on this thing and you will harvest a potato and you will hold that in your hand. And one of these, somewhere here is a microwave oven, which you can wrench down to a table that itself needs to be electrified. So some tables are electrifiable, some not. It needs to be an electrifiable table. And then you can stuff the potato in there and turn that on and roast it. And that will be more efficient food and will also last you longer. Or you can eat the raw potato, which will not do much food-wise and so forth, but yeah. And there will still be one potato on this thing, if it has grown well. And you should not pluck that last potato, because after that cycle, it will strive towards seeding. And once it has arrived there, you will get one seed that you can pluck, and then you will still have the potatoes that you can pluck. So what you can do is let this thing grow to its very end, take the seed, take the potato, then the plant is gone. Then you plant a potato in here, or potato seed, it's your choice. Not a roasted potato though. And see, in this way, these guys basically multiply. One turns into 3, One plant turns into a seed and 2 potatoes. So we have, we replant that, and then you still have a potato, and you have seed. But if you harvest both potatoes before the seeding has completed, then you will not get to the seeding stage. And that's it. That's this video, and it has been quite long enough. See you!